A river cut down the rock. A river cut down the rock not because of its power, not because of its power, but because of continuous persistence. Why I'm saying this statement again and again in every class? Because to clear any competition exam, yes, the hard work is required, but that hard work should be consistent. Consistent like water flowing and cutting the rock, guys. That rock is a competition exam, and the continuous flow of movement of water is your persistence, is your consistency. A very warm welcome. I, Abhinav Negi, a very warm welcome to all of you guys in this beautiful sunny morning. And if it is not sunny there in your city, guys, let me make it sunnier with this complete geotechnical marathon where I'll be telling each and every chapter, guys. Each and every chapter I will be doing here. Okay, each and every topic we'll be doing here. Hey everybody, so many students are there, even I cannot read all the names. Anusha, Anbu got the prize na? Anbu, last time, so I hope you got the prize, the cash prize. Okay, Arun, so many, let me make the screen bigger. Yeah, so many students. Sikh, Soita, Girish, Akela, Ronaldo, everyone. So guys, are you all super excited? Yes. Good morning to everybody. Our moderator, Mr. Chandramoli Singh from Shadol is also here. It is useful for ESC. Yes, it is for GATE and ESC both, guys. The concepts and the topics of geotechnical engineering are same. Okay. Yes, Anbu got the cash prize of strength of materials that in that marathon. Let us see that who is the winning the prize today. In between, I'll be telling you some questions. I will first of all tell you that this is a prize question. Okay, not every question. Okay, here guys, this marathon is not about questions. It will be concept plus question both. Concept plus question both. Everything will be there. Okay, in between, I'll taking some questions and I will be taking that this is a prize question. So at the midnight, again like Som, that midnight practice session, I'll be announcing the winner by analyzing the results and giving the cash prize like that day he's get. Okay, Josh is very high, excited. So guys, this is about me. My name is Abhinav Negi, having done MTech from IIT Delhi in Geotechnical Engineering only. So in which I have done MTech, the same Maha Marathon is going on right now. Okay, so guys, these two sessions will be coming in next 3 to 4 days. Ask me anything and how to utilize those 3 hours, because guys, you have studied 1000 hours for those 3 hours. So every minute here you have studied so many hours. So how to utilize that, everything that I'll be telling you here. So guys, this is midnight today. Okay, now then on tomorrow will be the FM marathon. Okay, complete FM marathon. Then Sunday will be having expected questions, and for a change, the marathon of surveying will be at night, Monday 9 p.m. Okay, so these are the coming sessions. Yes. Your super favorite Richa ma'am is also here. Okay, so guys, this is the workshop that will be on 15th of Jan. The mega workshop this time, the super duper workshop this time. Okay, 7 success mantras to clear gate. That will be on 15th January, Sunday, 12:30 noon. 90% scholarship is available. You can give the test on 8th of January at 12 p.m. Okay, now guys, let's go for the Maha Marathon schedule. Som is done, steel is done by the Sahu sir. Richa ma'am has yesterday taught you environment. Now today is geotechnical, then fluid mechanics. Okay, and guys, Sunday surveying marathon on Monday will be at night, 9 p.m. Okay, you can join me in Telegram. This here, guys, after the session, a long day, long session. After the session, I'll be sharing that PDF here in the Telegram. Okay, excited. So many students are here, and guys, I filled with 3-4 water bottles. A couple of Red Bulls are also there. So I am fully prepared. I hope that you are also prepared. Okay. So guys, before going to each side, guys, there are more than 500 slides. Okay. I guess in 20-30 slides there are certain schedules and these kind of things, but 450 slides or 500 slides will be of the content. Now, before telling you all this quicksand condition and everything, this is not the first chapter. Let me tell you about the weightage. Guys, soil mechanics is not one of the highest weightage. I'm again repeating, soil mechanics is not one of the highest weightage. As per their recent 5 years, it is the highest weightage. Okay, so it is coming in both sets around 14 to 15 marks. In the 2022 also it was same, 15 marks. Okay, Now guys, if I talk about the soil mechanics ratio with respect to other subjects, you can see that soil mechanics and environment are one of the highest weightage, and other subjects like SOM, transportation, structure, RCC are in the mid range. Then again, like irrigation, steel, engineering, mechanics, building material are little bit less. But yes, they are also important, because guys, each and every marks is important. And guys, see, geotech is very high weightage, but it doesn't mean that it is most important. I guess if you want to see importance with respect to the marks, then you should be checking not only the marks but marks with respect to syllabus ratio, which is very high for plastic analysis, steel, and per CPM, and highway, and hydrology, OCF, like this. So excited everyone. So guys, if I talk about the syllabus change in 2020 notification, August, for 2021 exam, that is IIT Bombay, and upcoming exams like 22, 23, 24. I'm again repeating, the syllabus is changed after every 6 to 7 years, a little bit, 5 to 10% syllabus. Last time the change was on 2020 August. 2020 August notification has come by IIT Bombay for the 2021 exams and coming on. And from that, the origin of soils, the soil structure, that kaolinite, inlite, montmorillonite, okay, and Darcy and Westergaard theory is not there. Now many students, many teachers that time came on 2020 that Darcy law is not written. So guys, if it is not, plus is also not written, minus is also not written, multiply is also not written, so it will not, you will not be doing calculation then. Darcy law, guys, Seepage is written. So that means Darcy law is already in itself is included, nah? Okay, and added is little capacity of pile. Everything will be going to study here, guys. Please share the session, guys. I'm requesting all of you to share the session so that more and more commandos can join in, guys. Please, everyone. Okay, moving further. Guys, this is the sequence in which we will be studying strength soil mechanics today. First, this chapter will be doing all topics in origin of soils and property of soil, phase diagram, okay, physical weathering, chemical weathering, then pipette analysis, then hydrometer analysis, then sieve analysis, then plasticity index, liquidity index, consistency, oven dry method, pygnometer method, water balloon method, everything will be studying here today. Then the classification of soil, GW, GP, CL, CI, and all these things. This is only in engineering services. Then compaction of soil will be studying, guys. Okay, wet of optimum, OMC, and all these things. Then effective stress and capillarity, permeability. Okay, Darcy's law will be studying here. Seepage, quicksand condition, flow net diagram, vertical stress for line, vertical stress for irregular loading, new marks chart, everything. Westergaard, BYJU'S will be studying here. Then consolidation of soil. What is primary consolidation? What is secondary consolidation? What is time factor? What is single drainage? What is double drainage? What is excess pore water pressure? We'll be studying here. Then shear strength of soil, triaxial, everything will be doing there. Okay, then earth pressure and retaining walls. Then after that, active, passive, every case there. Then finite and infinite slopes. Then shallow foundation from Terzaghi, Meyerhoff, and all these things. Then pile foundation, then soil exploration. Each and every topic we will be studying. Okay, please let me know. Please let me know. Are you guys? Please put a heart sign on the comment box. Give me some josh. Give me some josh. Give me some josh. Everybody. Give me some josh. Give me some josh. Everyone. Yes. Excited. Everyone. So am I. So guys, this is quicksand condition. The soil is this is not, the soil grains are not having the capacity or strength to hold the stress. We will study this one by one. If I talk about the difference between GATE and ESE, then origin of soil structure is only in ESE. Apart from this, every 95% topic is in GATE and ESE both. Shweta, everybody. Okay, guys. Audio video proper. Let's begin with chapter 1. Let us write Om also. Like in the school days, we write in the first chapter, na? Everybody excited, guys? Please share the session. MBS, Padma, Girish. And subscribe it also. Okay. Okay. So guys, are you attending the complete marathon? So your explanation is very nice. I am also very nice, yeah. I am also very nice. Let me do to the table little bit side here. Okay. So many students are in full josh. So many students are in full josh. Let's start then. I'll not waste your time. Guys, I'll not waste your time. Okay. I know this is the time of examination. Let's begin with chapter number 1, origin of soils, and guys, soil property. Okay. Now guys, everyone, please see here. We are starting the session now. We are starting the session now. Okay. Guys, now anything which is less than, guys, everything PDF I'll be telling you na. So if in copy you're writing anything, that should be that what I'm not writing here, because this anyhow after 5 minutes, like in strength of materials, after the 5 minutes I provided you the PDF. Same thing I'll be doing here also. Same thing I'll be doing here also. Okay, so please write only that thing in your copy that is not here in this. Okay. Now guys, anything which is less than 80 mm, anything which is less than 80 mm is soil. Even if it is a gravel, patthar, that is also soil. Now sir, how we will find that the size is less than 80 mm? How we will find that? So guys, how to find this? That there are certain sieves, and these sieves, these sieves are having certain openings of different sizes. So suppose 80 mm sieve is there, that opening size is 80 mm. If anything is retaining on it, that is not considered as soil. Anything retaining on it, which is retained on it, retained is not soil, not soil. Okay. Now which is passed down, which is passed, that is considered to be soil. That is considered to be soil. Now guys, moving further, process of formation of soil. This is very important. In 1 marks they ask this. In 1 marks, in various examinations they ask this. Process of formation of soil is pedogenesis. Now how soil is formed, guys, that is very important for GATE also. That is very important for GATE also, because now what story I'll be telling you, from that story, from that concepts, more than 40 to 50 objective questions of GATE can be coming conceptually. So please return to the story of formation of soil. Please return to the story. Guys, basically there are 2 types of soil. One is organic soil. One is organic soil. There are 2 types of soil. One is organic soil and one is inorganic soil. Inorganic soils are the thing that we have to study in civil engineering. Okay, this is the soil that we have to do for civil engineering, and this is formed from weathering of rock, erosion of rock, disintegration of rock. Weathering, disintegration, say all are these same words. Weathering, erosion, disintegration of rock. And organic soil is formed from plants. Everything is written here also, yaar. Organic soil is formed from plants, decomposition of plants, vegetable matter, organic matter, etc. A tree has fallen, from in 100 years it is converted to soil, that is organic soil. From rock, water is coming, after 100 years it will be disintegrated to form inorganic soil. Now inorganic soils are not good. Organic soils are not good, that is why we are not studying them. Organic soils are having very large volume change, large compressibility. Guys, right now, today I am not in studio. Today I am in my home. So I live in a society in 9th floor. I live in a society in a 9th floor. So might be if I have used, or the people here have used organic soil in the foundation, might be the first floor becomes a basement, or the basement becomes further -3 basement, or the ground floor becomes basement. Not that much, but little bit. Okay, so organic soils have large settlement. When I say that inorganic soils are good, we will study them. Organic soil is not in our syllabus, we will not study them. I am saying this good or bad on the basis of civil engineer. This I am saying on the basis of civil engineer. Might be for agriculture engineer this soil is good, but civil engineer deals with the strength of soil, settlement of soil. So for that this is good. Might be, or the agricultural engineer is taking the mineral composition. Might be the organic soil is good there. So now organic soil is formed from decomposition of plants and organic matter. Now how inorganic soil is formed, that I'll be telling you. Okay, I'll be coming to this table again. Let me tell you the inorganic soil formation. Here this every table I will be explaining again. This table I will be explaining again. Don't worry. Now see, this I will tell. Don't see this here. See whatever I am telling you here. This I am coming again. Now see the story. Very important. This is rock. Parent rock, and from parent rocks there will be, guys, this is very important for GATE also, because the concepts here are used in GATE throughout the chapter. Now physical weathering, we will be having coarse grain soil. Coarse grain soils are gravel and sand. What is physical weathering? I'll be telling you. So guys, see, this is not soil. These are not soil because the sizes are more than 80 mm. Cobbles and boulders are not considered as soil because the size is greater than 80 mm. So the soil is this one, gravel and sand. So gravel and sand are the bigger sizes and they are called as coarse grain soil. Gravel size is from 4.75 mm to 80 mm. And the sand size is 0.075 mm to 4.75 mm. This 0.075 mm is also known as 75 micron. Okay, so anything which passes from 80 mm sieve, and retaining on 4.75 mm sieve means it is smaller than 80 mm and bigger than 4.75 mm. This is gravel. Anything which is passing from 4.75 mm sieve and retaining on 0.075 mm sieve, this is sand. Okay, these are coarse grain soil formed from physical weathering. Physical weathering means that rock. Physical weathering means that rock is, this is the parent rock. This is parent. Why this is called parent? Because this is the father. From here we will be getting the soil. So from this parent rock, physical weathering means wind. The agency here is wind, air, water, anything. The physical things are acting, wind, air, water, and after 100 years, after 200 years, the soil is formed. After 100 or 2, good morning, 100 or 200 years. Okay. Now, there is another thing also, that is chemical weathering. In parent rock, the same rock can be acted by physical weathering and all chemical weathering. Physical weathering means wind, air, water. Chemical weathering means like acid rain, okay, CO2, SO2, all these are acted, and here it forms the fine grain soil, very small size particles. These are the fine grain soil. So gravel and sand is coarse grain soil acted or formed by physical weathering of rock. Okay, and this is formed from chemical weathering. Okay, silt and clay. Physical weathering means that water, air, wind is acted on the rock, and chemical weathering means acid rain, sulfur dioxide, all these are acted. And from physical weathering we got a big size particles. The shape is angular. We got a big size particles, not exactly sphere. We got a big size particles, not exactly sphere, are angular. or angular. Now guys, from this story now many concepts, just wait, many concepts will be coming. Okay, gravel and sand. From fine grained soil, we got silt and clay, we got silt and clay, we got silt and clay, very small in size, very small in size, very small in size. Okay, these are very small in size and the shape is generally flaky. The shape is generally here flaky. Okay, and here the shape is angular. Now guys, one thing is very clear. Whatever I am telling you now, no need to read because here it is written. Here everything is written. Now see, from coarse grained soil particles, from physical weathering, the mineralogical composition, I have written this in the previous slide, no need to write down in your copy, just listen. The mineralogical composition will be same as parent rock. Whatever the mineralogical composition of parent rock, same will be there because no other chemical is acted. So they are just the smaller part, very fine part of the parent rock. They are just very fine part of the parent rock. So mineralogical composition will be same. Here the mineralogical composition will be different because certain chemicals are also acted. Certain chemicals are also acted. Okay? Not classification, not concepts of soil classification, Chandramouli. It is the first chapter. Okay, that is soil properties. So here the mineralogical composition is different. Now here the permeability will be more. Here everything is written, no need to write in this table. Okay, permeability is high and here the permeability will be low. Here permeability is high, here there are voids, big voids, na? So water can move faster, water can move faster, water can move faster. Permeability is high, here permeability is low. Now a very surprising thing, here the void ratio is less, here the void ratio is big. First of all, what is the void ratio? Void ratio is volume of voids by volume of solid. Guys, here one void is bigger, but here one void is smaller, but number of voids here are more. There is no derivation because it is not perfect sphere. Here the number of voids are very high and they are such high the volume becomes bigger because volume will be not of one void. Now volume will be volume of one void into number of voids. Here number of voids are so much. They are very small, but number of voids are so much, the void ratio is here bigger. Now specific surface area, SS, is surface area per unit volume. And here specific surface area per unit volume, here it is high, here it is less. Guys, well, let me tell you, one time my first cousin back in my village has eaten the poison. I don't know why. And he has eaten the single tablet. And we have saved him. Then we thrash him like, my uncle thrashed him like anything after he becomes fine. Okay. But if somebody wants to die, wants to suicide, he should be eating poison with doing powder, crushed powder. Because when that is in crushed powder, fine particle surface area will be more easy, fast reaction will be there. But never we have to do this because the whole effort is done by your parents to bring up to this age and you will be doing this. Okay, that is a foolish activity, coward. Okay, so surface area is more because there are small particles have more surface areas. Okay, so these are the properties. And here guys, this fine grained soil will be having what property will be majorly decided on the basis of water content, how much water is inside it. 10% water content will be having different property, 15% water content will be having different property, 25% water content will be having different property. Here with change in water content, the properties are not much changing. Here the gradation is required. What is gradation? I will tell you in the soil classification chapter. Till then you can see, understand that here I want that big particles are also there, small particles are also there, very small particles are also there, medium particles are also there, so that the voids will be less. Guys, when there are different sizes of particles, in that case, when the particles are of different size, okay, when the particles are of different size, then voids will be filled. Voids will be filled with small particles. Then voids will be further filled by further small particles. So that is called gradation. I don't want that soil will be of same size. I want different particles should be there. Double XL, triple XL, single XL, all should be there. All should be there so that the gradation is good. Okay, but here the gradation does not play a big role. Do you know why? Do you know why? Because guys, here the soil is having cohesion. Here the soil is having cohesion. Here it is cohesionless. Cohesion means the attraction between the particles. Here there is no attraction. Here is attraction. Why? You don't know why there is here attraction? Because it is a flaky shape and plus and minus signs are separated. So mostly one plus is attracted to the other minus. One plus is attracted to the other minus. So here is a cohesion. So here the gradation is not important. Even all particles are of same size, then also they can be very strong because of the cohesive force. Please, if you got it, give me yes or no. Have you got it? Please give me yes or no. Have you got it? Please, everyone. Give me yes or no. Everyone on the comment section. Have you understood this? Have you understood this? Yes, our Anbu the Som winner. Okay. So now all these are written here. All these are written here. This is not soil, this is coarse grain soil, this is fine grain. So just believe me here, everything is written. Okay. Retain the property of parent rock. I told you this does not retain soil formed from coarse gravel or gravel and sand. Okay, this you know. Physical weathering happens due to impact of agency like water, wind, less word ratio, everything you know, yaar. Okay, permeability is more, it is high, less specific area. Okay. And they are cohesionless, and grain size distribution is important. Okay, now guys, when the parent rock, from the parent rock, the father, even if it is physical weathering or it is chemical weathering, if it is physical or chemical, anything is physical or chemical, if the soil is here only, in अपने पापा के पास ही है, if it is with his mummy and papa only, if it is with his parent only, it is called as residual soil. It is called as residual soil. If it is with his papa only, his mummy only, residual near the rock. But if it is transported somewhere else, that is called as transported soil. That is called as transported soil. Got it? Got it, everyone? If it is with its parents only, it is called residual soil. If it is transported, then it is called as residual soil. Now on the basis of this what is called, on the basis of medium of transportation, the soil is further distinguished. The soil is further distinguished. Okay, on the basis of transportation. Okay, let's move further. Okay, on the basis, if it is transported by running water, it is called as alluvial. Now tell me in the comment box, when it is lacustrine, transported, deposited by, when it is marine, when it is aeolian, when it is glacial. I know you all are champion in this. I know you all are champions. I know the students' mindset. Now in this, I know everybody will be champion. Okay, otherwise it is lake means everybody has written like this. Remember, like lake and lacustrine, both are same. Okay, I know your mindset. Same is my mindset also, yaar. Marine engineer, marine commando, sea. Like this only you have done, na? Alien. So many times. Here you have not applied any concept. Alien, air, alien is wind. And glacial, also glacial. See, everybody's mindset is same, yaar. Okay. Am I correct? Guys, please like the session, yaar. 99 students are here, 90 students are here. Only 68 like. Now, have you ever wondered why teachers are saying for like? Guys, please, because with more likes, YouTube recommend that video, and everybody wants to be famous. It's nothing bad in that. If I am teaching, if I have made 550 PPT, 50 slides, I want that every student should be getting benefited from here. More number of students here, more is my energy. Okay, now these are some special types of soil. I have this, nothing to teach here. You will get this in PDF. Now, moving further, guys, this is water. Now, guys, actually, the soil is something like this. Soil is, these are soil particles, soil grain. Very, guys, whole soil mechanics you will be getting in a very easy way today, but just the patience is required. And one small request from my side, that guys, please, if possible, watch the video in a bigger screen, like laptop or TV or whatever you have, if possible. Plus, please don't waste time on that. If it is not possible, it shouldn't be like you go running towards your neighbor and asking this laptop and everything. Now see, if possible, because for whole day it will not be very easy to watch it mobile. Yes, after 20 minutes you can watch it mobile also, because watching every time in computer, laptop or TV, it will be boring. So for 20 minutes you can watch in this. Now this is water, this is also water. Okay, now these are the soil grain particles. In between there is voids. Some voids can be filled with water also. Some voids can be filled with water also. Okay, and these are soil grains, solid particles, also called as grains. Okay, and in between there is air. Okay, this is general case. Now, every time remember, guys, from various numericals, also we will be doing those numericals today, that there is a case that when soil is shifted from here, so some excavation is done and an embankment is made here. There are some cases soil is transported like this. So always solid remains same. Weight of solid, volume of solid remains same. Guys, water can be expelled out and air can be compressed by compressing the soil. But solid will be same. Solid will be same. Okay, solid will be same. So all those questions of excavation and all these things, solid weight and volume will be same, both weight and volume. Air can be compressed by compressing it. Okay. Now, okay, Arun, okay. Just little bit, let me come in flow. I'll be increasing it. Now, guys, when this is partially saturated soil, guys, I'm again telling you that void is air plus water both. Void is air plus water both. Okay. Now, guys, when the rain comes, everything is filled with water. Everything is filled with water. Oh, sorry, rain comes when everything is filled with water. And when if you put it oven, everything, air, water is removed. Water is evaporated. So this is called dry case. This is called dry case. Okay, this is called partially dried or partially saturated or partially dry case. This is called a saturated case. This is called a saturated. All voids are filled with water. All voids are filled with water. Here actually only few voids are filled with water. Only few voids are filled with water. But there every void is filled with water. Here every void is filled with water. Only voids. Only voids is filled with water. Okay. Now let us do something. What is water content? First, tell me the maximum value of water content. What is water content? Weight of water by weight of solid. If you want in percentage, multiply by 100. Okay, what is the maximum value of water content? Please let me know in the comment section. Please let me know in the comment section. Everyone. Okay, guys, for dry soil, water content is 0 and water content can be greater than 100%. Can be greater than 100%. Many things that water content cannot be greater than 100%. Okay. Now, void ratio. Fast. Let us go a little bit faster. What is void ratio? Void ratio is volume of voids by volume of solid. Okay, you can represent anywhere. volume here, here, anywhere. Mostly we represent volume on the left hand side and weight on the right hand side. And for whole soil mechanics, whenever I am writing small w, for whole soil mechanics today, whenever I am writing small w, it is water content. It is water content. And whenever I am writing capital W, it will be representing weight. Weight of solid, weight of water, anything. Okay. So, my friends, everyone, what is void ratio? Void ratio is volume of voids by volume of solid. Okay. Void ratio of fine grain soil is greater than void ratio of coarse grain soil. Generally, void ratio of coarse grain soil is 0.7, 0.8 like this, and this can be limited more, 0.8, 0.9, even it can be greater than 1. Now, going little bit faster, guys. What is N? N is porosity. N is porosity. N is porosity. What is N? Volume of voids by total volume. Okay. Volume of air and water. This is volume of void. Air and water both are volume of void. And that total is total volume. And here this is total weight, because weight of air is 0. Any doubt, please let me know. Any doubt, please let me know. Everybody, guys, keep sharing the videos. Okay. Now, this is void ratio and that is porosity. Porosity I told you. What is degree of saturation? What is degree of saturation? This is water. What is degree of saturation? Degree of saturation is volume of water by volume of void. Volume of water by volume of void. Everybody fast. Tell me degree of saturation here. In dry case, volume of S is volume of water by volume of void. S is volume of water by volume of void. Here S is 0. In partially it is 0 to 1. And in saturated case, all voids are filled with water. So S will be 1. Now come on, guys, just keep commenting, yeah. Keep commenting. Degree of saturation. What is air content? Air content, volume of air by volume of void. What was saturation? Volume of water by volume of void. Can you see that S plus AC is equal to 1? Can you see this? S plus AC is equal to 1. When you add both of them, denominator will be volume of void, numerator will be volume of air and water. And volume of air and water is volume of void only. Okay, percentage air void is volume of air by total volume. This is volume of air and that is total volume. Okay, now this one. Unit weight of water, bulk unit weight. Okay, unit weight of solid, dry unit weight of soil, saturated, submerged. Guys, for whole this, just remember one thing. Gamma is weight by volume. Just that's it. Like density is mass by volume, na? Gamma is just weight by volume. Everything will be done from here. Everything will be done from here. Like unit weight of water. This is water. This is water. Like unit weight of water. This is unit weight means just remember one thing, weight by volume. So gamma W is weight of water upon volume of water. Just remember weight by water. Weight by volume. Bulk unit weight of soil. Bulk unit weight is associated with soil. It is represented by gamma T. This is soil, not water. It is soil. Bulk unit weight is represented for soil. So, total weight of soil upon total volume of soil. Unit weight of solid. Unit weight of solid, gamma S. Solid, not soil. Solid. Unit weight of solid. So, weight of solid upon volume of solid. Now, dry unit weight of soil. In dry case, it is represented as gamma D. Gamma D is in dry case. In dry case, weight of dry soil. Weight of dry soil. This is for soil, not solid. Soil. So, volume of total volume of soil. And what is weight of dry soil? There is no water. Air weight is taken as 0. So, weight of dry soil is actually weight of solid. Weight of dry total volume of soil. Have you got it? Please give me yes or no. Yes or no, everyone. Everyone. Now, saturated unit weight means when the soil is fully saturated, that time weight of saturated soil upon total volume. Submerged means when beyond weight is also acting. Submerged means when beyond weight is also acting. Okay, like If I'm saturated here in my room, in my bedroom, I will be very heavy. Yes, complete भाई 4 5 10 बार बोल चुका हूं, complete करूंगा. If everything is, I am surrounded with water, if I am surrounded with water, my weight will be heavy. But if inside the swimming pool I will be there, my weight will be less due to beyond weight. My weight will be less due to beyond weight. So gamma submerged is weight of submerged soil upon volume of soil. And by derivation, I am not going derivation, I know what derivation has to be required here. Gamma submerged is gamma sat minus gamma W. Gamma sat means gamma submerged means gamma sat minus gamma W, not going in derivation here. Now I am writing one thing, I don't know how many of you will understand. Please see, very very important. Highest is gamma solid, then gamma saturated, then gamma bulk, then gamma dry, and least is gamma submerged. Please give me yes or no, Y or N on the comment box if you have understood this. If you have understood this, please give me yes or no. Please give me yes or no. Every commando out there. Every commando out there. Give me yes or no. Give me yes or no. Subscribe the channel, guys. Okay. Guys, see, gamma solid is highest density, na? Because all these things are saturated, bulks, dry, submerged are associated with soil. They are the unit weights of soil. Only this is unit weight of solid. So in soil, water and air is also there, na? In soil, water and air is also there, na? Here is only solid. This is suppose in 10th class, the marks in your 12th class, the average of PCM, physics, chemistry, math. It might be, I'm just assuming it might be more. And this is average of all. Well, English, Hindi, everything is there. Might be physical education, sometimes make it bigger. Leave it. Here this is the lighter material also coming, water, air. This is only solid. And in soil, saturated will be having highest weight, then bulk, then dry, and then submerged. Even for to be very precise, I should be writing here equal to sign. Equal to sign also. Because gamma bulk can be saturated also. Gamma bulk can be dry. Gamma bulk means whatever is the existing condition. Gamma bulk means whatever is the existing condition. Yes, Prince, I am coming on that. So gamma bulk means whatever is the existing condition. Now what is G? What is G? G is, suppose G is 2. That means that material is having 2 times more density than water. Okay, this is water. Okay, suppose G of this steel is 3. So this is having 3 times more density than water. Suppose G of this marker is 1.5. So this is 1.5 times more denser than marker. Suppose G of this napkin is 0.5. Then that means this density is half of water. So G represents the ratio of that thing with water. So solid means gamma of solid with respect to water, and GM is soil. So gamma bulk with respect to gamma water. Generally we use G, this one. This is not GS. Generally in formula, all formulas, this is coming. This is coming. It is around 2.6, 2.7. Okay, guys, can you please give me this answer? This is not the prize money question. This is not the prize money question. Whenever the prize money questions will be coming, I'll be telling you in between. I'll be telling you in between. Fast. Yes. Great, guys. We have to increase in increasing order. So increasing order means lightest. This will be the correct. First will be gamma submerged. Then after gamma submerged, it will be gamma dry. then a gamma dry, it will be bulk unit weight, then saturated, and then unit weight of solid. Any doubt here? Any doubt here? Please let me know. Please let me know. Okay, 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 okay. Guys, little bit I will increase the speed, hai na? Okay. Now, relationship. Now, relationship here. Please see. First of all, guys, gamma D is gamma bulk upon 1 plus W. Guys, it can be also written as gamma bulk upon gamma saturated 1 plus what W. This is also valid. But in this case, the W should be of, water content should be of saturated stage. Water content should be of saturated stage. Now, another is porosity is equal to E upon 1 plus E, or E is equal to N minus 1. Like this. Now, one more, that SE is equal to WG. Saturation into void ratio is water content into G. Where if I have not mentioned anything, this G is, this G is, this G is this. By default, this weight of solid, specific gravity of solid, that is 2.6 to 2.7. Now using this, we got gamma bulk is G plus SE into 1 plus E into gamma W. For gamma dry, S is equal to 0. So it is G upon 1 plus E into gamma W. For gamma saturated, S is equal to 1. So it is G plus E 1 plus E into gamma W. For gamma submerged, gamma submerged is gamma sat minus gamma W. Gamma submerged is gamma sat minus gamma W. If you separate gamma W from here, it will be G minus 1 plus E into gamma W. Now, guys, if you write here SE is equal to WG, if you write here SE is equal to WG, G plus WG 1 plus E into gamma W. So this is taking G common, G gamma W 1 plus W 1 plus E is equal to gamma bulk. Everybody give me yes or no. Everybody give me yes or no. Now, if there is some other liquid, if voids are saturated, this question is also come in the gate examination with some other liquid, some other liquid. This come as asked in PYQ of gate. Then in that case, gamma sat is equal to G plus E G dash into 1 plus E into gamma W, where G dash is the specific gravity of that liquid, which is filled inside the voids. Okay? जिसको डाउट हो पूछते रहना यार. Anybody is having doubt, please let me know. Now, can you please do this for me? MSQ question. Guys, see, I will be solving those types of question in this particular session which is important for getting the concepts, which is important for revising the concepts. Those types of question only I'll be taking this session. But the real application and the little bit tougher side questions I'll be taking tonight midnight, in midnight soil practice session. Have you got it? Have you got it, all of you? Okay. Now something is given. Wet density is given. Water. So first of all, what is the dry density? I just told you rho D is equal to rho T into 1 plus W. Okay. Now this is 2.1 gram and 1 plus W. What is this value coming on? From here, what is this value coming on? Please let me know. Please let me know. Picture quality is, Nagaraj, picture quality is very fine. Just check your settings of your YouTube. Yes, my picture quality is not that much good. That I agree. But here the picture quality is very fine. Guys, picture quality is getting fine or not? Is picture quality good or should I change something? Picture quality सही है भाई? ये सही में सही खराब आ रही है. सही है यार. Picture quality should I change? Picture quality is fine. Picture quality is fine. 1.82. So 1.82 gram per cc. If you convert in kg per meter cube, it is correct. Okay. Now void ratio. Rho T is equal to G rho W 1 plus W into 1 plus E. So from here we are having everything except E. We are having rho T, rho W is 1, G you are having, G, yes, G you are having, G you are having, W you are having. Find E from here. What E you are getting? 0.48. What is N? E upon 1 plus E. Is it coming 0.32? Is it coming 0.32? And SE is equal to WG. E is known, W is known, G is known. S I'm assuming all are correct. And just going into the concepts, not in the calculation. 0.32. Everybody got the concept? Should we move further? Okay. Now, if the water, guys, first, like in the SOM, here also first chapter is very big. After that, the chapters will be small. Now do this. Please. Everyone, please. Please share the session so that everybody can join. Tiksha, Abhinav sir, rock. Yes, I believe that. If water content fully saturated, SE, SE is equal to WG. Fully saturated means 1. E, fully 100%. Water content 100%, 1. G. So E is equal to G. Then void ratio is equal to the specific gravity. Now do this. See again, S E is equal to WG. S is given, G is given, E is given, find W. No need to time waste here. No need to time waste such questions. Okay. Here, if soil E is given, G is given, S is given, W is fine. Do this one, yeah. Do this one, guys. I'll be increasing my speed little bit. Let me just come in flow. Guys. The whole soil mechanics will be done today. Soil mechanics plus foundation, everything will be done, guys, today. Okay. Soil is, guys, the phase diagram will be looking like something. See, the phase diagram will be solid, water, air. Let me write weight on the right hand side. So weight of solid is 1, weight of water is 0.3, of course weight of air is 0. Volume of solid is 0.5, this is 0.3, this is 2.2. Now what is void ratio? Void ratio is volume of voids, that is 0.5 by volume of solid 0.5. Okay, 0.5 by 0.5, it is not 40%. It is not 40%. 2 is wrong. One is soil is partially saturated. So S is volume of water by volume of void. So 0.3 by 0.5 into 100 is equal to 60%. Correct. Now water content is 30%. So water content is weight of water upon weight of solid into 100, it is 30%, correct. Saturated unit weight. Now saturated unit weight means when it is saturated, solid and whole water. So solid remains same, weight is 1, volume is 0.5. So volume also remains same, 0.5. When volume was 0.3, weight is also 0.3. So now volume is 0.5, so weight is 0.5. So here gamma sat is weight upon 1. So it is 1.5. 1.5 upon 1. So 1, 3 and 4 are correct. 1, 3 and 4. MSQ can have only one option also correct. MSQ can have also only one option also correct. Have you understood this? Have you understood this, guys? Come on. Come on. Everyone. Any doubt? Any doubt? No doubt. Let's move further then. Okay, this one. This one. चलो 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 चलो. N is equal to E upon 1 plus E. So आपसे पूछा porosity is 0.2 और E is equal to N upon 1 minus N. So 0.2 upon 1 minus 0.2. So 0.2 upon 0.8, that is 0.25. Okay, Lallu question. Which of the following statements are true? Guys, I am again saying in this particular session I will be doing those kind of questions that will make your concept strong. Now those questions will make your concept super strong, that I will be telling you in the midnight today till 11:55. In all the voids are filled with air, excellent. In a saturated soil all the voids are filled with water, excellent. In a partially dry soil the voids are occupied both with air and water. Unit weight of solid is always less than unit weight of soil. How? Unit weight of solid is soil will be less because soil contains lighter material like water and air also. So A, B and C. Now guys, moving further, everyone, guys, we are having 4 types of water in soil, everyone. Now first type of water is, we are having 4 types of water in soil. Now first type of water is that which is structural water. Leave structural water I will be telling you at the end. One is adsorbed water. One is adsorbed water. Adsorbed water is that suppose this is a solid particle. Adsorbed water is, suppose this is a solid particle and when it comes in the open atmosphere, some water is attached to it. The water is adsorbed on its surface. That is called as adsorbed water. Now the next is capillary water, that is stuck in the voids due to the capillary reaction. Okay, one is gravity water, one is also, fourth is gravity water also. So they have written differently, na? Gravitational water and attached water. So one is gravitational water, that when the rain comes, then that water which is moving down to the groundwater table, it is not stuck in the voids like capillary reaction. It is not attached to the solid particle. Gravity water is that water which is flowing down, to the groundwater table. That is called as gravity water. Okay, so one is adsorbed water, that is adsorbed by the atmosphere. One is capillary water, that is stuck in the voids. One is, guys, gravitational water, that is flowing down. And one is structural water, and that structural water is which is attached, and when water is attached to it, structural water is that water which is attached to the crystal lattice. that is attached to the solid particle in the molecular level, in the crystal lattice. And if that water is evaporated due to oven drying, whole property of soil is changing. So you can think that structural water is a alag hi type ka hai bhai, ghar jama hi hai wo. Okay, that is son-in-law, that is attached to the molecular level of soil grains. Okay. Now there are various methods of water content determination. Water content is weight of water by weight of solid into 100 if you want in percentage. Various methods, let us go them one by one. What happens in oven dry? I am going quickly now little bit. Suppose this is a soil, moist soil. This is a moist soil and suppose the weight is W1. Now I make it oven dry for 105 to 110 degrees Celsius. Okay, I make it oven dry for 105 to 110 degrees Celsius for 24 hours. For 24 hours. It becomes dry soil. It becomes dry soil W2. It becomes dry soil, it is W2. Okay, so water content is weight of water upon weight of solid. Water content is weight of water. What is weight of water? What is weight of water? Here the weight of water is W1, here the solid is W1 having weight, here it is W2. Here it is having W1, here it is W2. So the difference is weight of water. The difference is weight of water, that is W1 minus W2. The difference is weight of water, that is W1 minus W2 upon weight of solid, that is W2. That is W2, like this. Like this. So difference is weight of water upon weight of solid. Now the question can come, or a conceptual question can come, that sir, why it is at 24 hour only? Why it is at 105 to 110 degrees Celsius only? Because if we heat beyond that, then this structural water, if we heat beyond that, then structural water is also evaporated. And if structural water is evaporated, then the property of soil is completely changed because it is attached to the crystal lattice. Okay. So water content is weight of water by weight of solid, and we have to heat this beyond. And you can also say that this weight of water includes gravity water, it includes capillary water, it includes adsorbed water, but not the structural water. Okay. Now for organic soils, heating should be done up to 60 or 70 degrees Celsius only. Heating should be done for 60 to 70 degrees Celsius only. Do you know why? Can anybody tell me in the comment section? Can anybody tell me in the comment section? Because more than 60 or more than 70, some organic compounds also oxidize. Some organic compounds also oxidize, and the reduction W1 minus W2 we are thinking as water, but that is some organic compounds also. That is some organic compounds also. Okay. Now there is a torsion balance method. What happens here? There is an infrared lamp, and this is a rapid method, but only here the measurement is not oven drying. We are using infrared lamp. Simultaneously we are heating and simultaneously we are measuring the weight also. Okay, here there is a drawback here. First of all, it takes long time, and after that, here when you put the tray out from oven and you are going to measuring it, in that much time might be some adsorbed water can come from humidity. So here both are doing simultaneously. It is very taking less time, or not oven dry by infrared lamp. Okay, there is sand bath method. Here is a tray. Here is a tray. In that tray you put a soil. Suppose that weight is W1. Then stove is applied from a sand of 3 centimeter, and after some time the dry weight only left, W2. So difference is weight of water and W2 is the weight of solid, like this. Okay, here we are doing oven, here we are doing infrared lamp, here we are doing sand and stove. Only difference is that. Otherwise difference is the weight of water. Calcium carbide is a compound CaC2. It reacts with water to form calcium hydroxide. and CaOS twice and acetylene gas. And let me balance it, it is 2. Let me balance it. Okay, it is 2. So hydrogen 4, calcium 1, carbon 2, oxygen 2, oxygen 2. Yes. So that means 2 mole of water produce 1 mole. This is acetylene gas. 1 mole of acetylene gas. This is acetylene gas. So by measuring the gas, by that formula in school we do PV is equal to nRT. By the formula we do in the school PV is equal to nRT. By measuring that acetylene gas, we can find out the water. By measuring the acetylene gas, we can find out the water. Suppose 1 mole of acetylene gas, there will be 2 mole of water. Suppose we get 35 moles of acetylene gas, there will be 70 moles of water. Like this. Okay. Now, here is a calcium carbide method. In a soil, we put a capsule. That capsule is a radioactive material. And there is an opening here. Okay. Now, the capsule is emitting the radiations. Detector is taking it. Detector is achieving it. Now, there is a relation that this much rays comes at this much intensity, at this much angle, at this much wavelength. Then there is this much water content. That is, there is an interpolation. Got it? Got it, everyone? Please let me know. Okay. Now there is a pygnometer method. In pygnometer method, what we do, this is a pygnometer. Here's a weight W1. Then we put a dry soil, or this should be moist soil. Let me check. This should be the moist soil. In this pygnometer, this is a moist soil. Dry soil is used to measure G. Dry soil is used to measure the G. Okay. Dry soil is used to measure G. This is actually moist soil. So we first of all take the weight of empty pygnometer W1. Then in that we put moist soil. The weight is W2. Then in that moist soil we put water. The weight is W3. And here it is weight 4. Now we want to find out the water content. Why it is suitable for cohesionless, I will be telling you. Weight of water content. Water content we want to find out. That is weight of water by weight of solid. Now what is weight of water? Everyone. Weight of water can be written as from W2, if I remove the container weight. From W2 if I remove the container weight, that will be the moist soil. And from moist soil if we remove the weight of solid, this is the weight of water. I hope you got it. Removing the weight of container minus weight of solid, it is weight of water. It is weight of water left. And what is weight of solid? Weight of solid is upon weight of solid. Yes. So from here it comes W2 minus W1 upon WS minus 1. W2 minus W1 minus 1 upon WS. Okay. Now from here water content is W2 minus W1. What is weight of solid? Weight of solid is volume of solid in density. Volume of solid into unit weight. Volume of solid into unit weight. What is unit weight? Volume of solid into unit weight. Unit weight is G times of gamma solid. G times of gamma W. Sorry. I hope you got this. Guys, see yaar. Gamma solid is weight of solid upon volume of solid na. Gamma solid is weight of solid upon volume of solid na. And G of solid is gamma of solid by gamma water. So gamma solid can be written as G times of gamma water. So weight of solid can be written as G gamma W into Vs. Okay, minus 1. Have you got it? Have you got it? Okay. Now everyone, let me write it fast. Water content is equal to weight of water by weight of solid. So weight of water is W2 minus W1 is weight of solid. W2 minus weight of moist soil. This is moist soil. This is moist soil. Okay. So W2 minus W1 minus WS upon WS. So W2 minus W1 upon WS minus 1, and WS can be written as Vs into G times of gamma W. Till here you all got it. Now see, I am writing W4 as from W3 as W3 subtract soil. Vs, this is subtracting the soil. I will tell you MVS. I am not leaving the derivation here na MVS. If I am leaving the derivation here, then I will tell you na how to find Vs. I am not leaving it here. We cannot find Vs very easily. That is why I am not leaving it here. So W4 is written as from W3 subtract soil. Subtract the weight of soil. That is volume of solid into density. G times of gamma W. Plus how much you have subtracted. Vs. Add that much of water. I hope you got it. From W3, remove solid, volume into density, and how much volume of solid you have removed, that much add water. From here you can find out the value of Vs. So from there Vs gamma W is written as W3 minus W4 upon G minus 1. W3 minus W4 upon G minus 1. Okay. Now putting that value there. So W2 minus W1. Vs gamma W is this. W3 minus W4 up into G minus 1 upon G minus 1. Everybody give me yes or no? Have you understood? And why it is written as air sucked out? This is very important. Why it is written as air sucked out? Because I am assuming in this statement that everything solid I am removing and putting the water, removing the solid, putting the water, it becomes here. That means VA equal to 0. That means here there is no air. If I am removing the solid from here and putting the water, removing the solid, putting the water, and it is equal to this case, that means VA is 0. Otherwise we have to add VA into gamma W na, that much is air, that we have also added. Please let me know. And it is suitable for cohesionless soil. Because in cohesive soils air can be entrapped. Getting or not? Everybody please. Okay. Now guys, it is short method or long method? It is short method or long method? It is short or long? It is a short method. Results are quickly. Now some students are sorry, it takes lot of time. Arey derivation mein time laga hai na. It takes time in derivation. Actually, in field, measuring this, quickly you will get the answer. Some people say, sir, oven dry is very small, sir. This is very small, sir. This is very small. This is very small. This is very small. अरे डेरिवेशन में स्लो है ना, टाइम तो 24 आवर है ना, टाइम तो 24 आवर है ना. It is more in derivation, but time does not require 24. Similarly, you can find the G also here. Similarly, here also you can find the G, specific gravity. It is W2 minus W1 upon W4 minus W1, W4 minus W1 minus W3 minus W2. Okay. Now, oh, I thought smartboard has been. Guys, the more tough situations in life you will be getting, the more stronger you are. What is this? Just kidding, just kidding. Okay, because every time what happens na, you see the toppers fame, toppers prize money, toppers results, achievement, but you have not seen his hard work, dedication, motivation, failure, struggles. Okay, so now guys, measuring the unit weight. Using unit weight is very simple. So gamma is equal to weight by volume. Gamma is weight by volume. Arey yaar, I am drinking Red Bull yaar. I am drinking Red Bull. Okay, don't worry. Don't worry, I don't drink at all. Just kidding. So guys, gamma is weight by volume. We insert a core cutter. And we bring the core cutter with soil. This is used for cohesive soil, not suitable for cohesionless, because cohesionless, when we insert the core cutter, when we bring the core cutter, the sand will slip, cohesionless soil will slip. Okay, so we insert the core cutter, bring the soil, measure the weight and volume of core cutter is known. Now there is sand replacement method. What we do here? We dig this soil, put it here as weight 1 W1, find the weight here W1, we dig the soil. Now we have to find the volume. So suppose, leave all this. Suppose this is, initially this is filled with VI volume. This is a cylinder. It is filled with VI volume. Now we put the cylinder here. Not over marathon, over this pit from where excavated the soil. After putting it here, we open the shutter. We open the shutter so that sand can slip. It is filled with sand. We open the shutter so that sand can slip. And once the sand is slipped, it comes here in the form of this, form of cone. And after pouring, the volume is VF left. First of all, now gamma is weight by volume. So change in the volume. Sand removed is VF minus VI minus VF is equal to V cone plus V of pit. V of pit or V of soil. Earlier there was soil. So V of cone is known because the dimensions are known here. So V of soil is change in volume VI minus VF minus V cone. Put the V soil here. You will get gamma. I hope you got this. Interesting method. नहीं सही में यार प्रिंस, मैं ड्रिंक नहीं करता हूँ, उस क्लास की तो दूर की बात, वैसे भी नहीं करता हूँ. और मैं इसको कांच के ग्लास में पी सकता हूँ. कांच के ग्लास में पानी पी रहा हूँ ना, इसको भी पी सकता हूँ, लेकिन उसमें मान लो कलर वैसा आएगा रेड बुल का, और कोई बच्चा म्यूट करके सुन रहा होगा या नहीं मानेगा तो जबरदस्ती कहेगा कि पी रहे हैं. ओके, ठीक है. Now some of you may say, sir, what is the use of this cone? Guys, the use of this cone, if the cone is not there, then when we will cutting the soil here, then a huge cross section of soil has to be cut. That is not possible. That is not very efficient. There is a cone tip will be very small. It is easy to cut. it is easy to cut. Okay, have you got this? Have you got this? Weight of moist soil is W1. Okay, now this moist soil is filled with paraffin wax. This is paraffin wax. Now the weight is W2. This is a container. Container is filled with water. Container is filled with water, and after inserting the soil, which is filled with paraffin wax, this green color is paraffin wax, the water is displaced. The water is displaced. Suppose the displaced volume is V. So we want to find out the gamma. Gamma is weight by volume. So weight of soil is W1. Weight of soil is W1, and weight of soil can be easily measured. There is no rocket science in measuring the weight. Okay, volume is, this volume is actually the volume of soil plus paraffin. So in which we have to minus the V of paraffin. Okay, so W1 total V minus V paraffin. So V paraffin is weight of paraffin. So W2 minus W1 is weight of paraffin upon gamma paraffin. This is gamma bulk. Everybody give me yes or no? Everybody give me yes or no? Everybody, please. Have you understood this? Have you understood this? Now, can you tell me, now everyone, can you tell me that why? मैं दूसरे कमरे में चला गया था, दूसरे बेडरूम में, वहां से भी आवाज आ रही थी क्या? क्योंकि माइक तो पहन के ही गया था, माइक तो पहन के ही गया था, आवाज आ रही थी क्या दूसरे कमरे से भी? Now I want to ask you that I want to ask you that why the paraffin is coated? Why we directly we can't put the here? Why we directly not put the soil in the water? Why we everyone please? Why it is not put directly, soil is not put in the water? Please tell me. Because if we put directly in this in water, if you put directly this in water, then the volume will not be the exact volume of soil, because some volume is not displacing, it goes into the voids. That is why no volume goes into the voids. I have coated with paraffin. Otherwise we can directly put it here also. Got it? Yes, one more interesting way is there to find this. An interesting way is there to find this. An interesting way is there. Do you want to know this? Do you want to know that interesting way? That is, if you don't want to coat this with paraffin, then what you can do? If you don't want to coat this with paraffin, then what you can do? You can put this in mercury. Okay, and mercury will not go into the voids because mercury has a large amount of cohesion and surface tension. It is always binded with itself. You have seen that mercury is always bounded with itself, like some water droplets in the leaf. It is always bounded in itself. Okay, so that can be done. Have you understood what I am saying? In that case, you don't have to put in paraffin. This W1, put in mercury, put it in mercury. Okay, some volume of mercury will be displaced. Then gamma is W1 upon the volume, because mercury will not go. That is also called as mercury displacement test. That is also called as mercury displacement test. Do you know about this? Do you know about this earlier? Okay. Guys, can you tell me why the leaning tower of Pisa is tilting? Can you tell me that why the leaning tower of Pisa is tilting? What is the reason behind that? What is the reason behind that? The reason behind that is not settlement. Guys, in soil, settlement is never a big problem. Settlement is never a big problem. The problem is differential settlement. And there is a slurry land. And actually, the Leaning Tower of Pisa in South America, there is only not one tower leaning there. There is not only one tower leaning there. There are numerous of towers. There are numerous of towers. Numerous of towers there which are leaning. Because there the soil is having very different property at every another foot. The properties of soils are drastically changing. That is why there is only the Leaning Tower of Pisa is famous, but there are various other things also. Got it? Do this fast. Guys, first chapter is big, yeah, not other chapters are not that much big. Don't worry, I will finish it in, I know the time. Do this. Okay, in a three-phase soil system, 1/4 of the volume is filled with air, V by 4, V by 3 is filled with water, and what is this? V minus V by 4 plus V by 3, so V minus 3, 7V by 12, so it is 12V minus 5V by 12. Okay, then the void ratio of the soil is volume of voids by volume of solid. Voids is this plus this, that is 7V by 12, and solid is 5V by 12, so it is 7 by 5. This is 7 plus 5. Got it? Okay, excellent. Now guys, break I will give you later on. चलो relative density भी कर लेते हैं. Relative density, this is water. I will chit chat with you for the next 5 minutes. For next 5 minutes I will chit chat with you, okay? Break I will give you later on. So relative density is E max minus E upon E max minus E minimum. What is theoretical E max? I can prove this also, but only I am proving those things that are very, very important. Theoretically E minimum is 0.35. This is in cubical array. Array means order, and this is in prismodal array. I will tell you the significance of this. I will tell you the significance of this. I will tell you the significance of this, guys. Please wait. Please wait. Please wait. After this, we'll chat for 5 minutes. After this, we'll chit chat for 5 minutes. Okay. Now, guys, relative density is what? Leave. इसका physical significance भी अभी बताता हूँ. First of all, cubic array ना. Array means arrangement. See, maximum void ratio, you know, when comes when the particles are exactly parallel. Exactly. When the particles lines are exactly parallel. Actually, it will not be never exactly parallel, never sphere. Therefore, the word is theoretical. That is why the word is theoretical. Okay. So when they are exactly parallel, there are maximum voids, because your intention is not to fill the voids. Putting voids here exactly over the other. Exactly over the other. Exactly over the other. You are just putting exactly over the other. If your minimum void ratio is in prismodal array 0.35, here if you want to fill the voids, now you will not be putting exactly over it. You will not be putting exactly over it. You will be putting here. You will be putting here at the center, here at the center, here at the center, here at the center, here. I hope you got it. I hope you got it. If you want to occupy the voids, now minimum void ratio, you will be putting here soil. You are putting here soil. You are putting here soil. You are putting here soil, like this. Like this. I hope you got it. I hope you got it. I hope you got it. Okay. And maximum and minimum void ratio is 0.91 and 0.8 theoretically. Now, if this is constant things, if our E is less, the relative density is more. And now I hope you got the significance. For a particular soil, for a particular soil, if relative density value is more, then that means that soil has less voids and it is very highly compacted. It is very highly compacted. Okay, if relative density value is more, that means E is less. So that is the physical significance. If relative density value is less, then voids are more. If relative density is less, voids are more. Then it suggests that it is loosely soil. But guys, can you just, anybody of you, this is now my question, price question. Now this comes the price question here. Question 1 of price. Question 1 of price. And listen to me. I will announce the price at the midnight session. Why this relative density, is significant for coarse grain soil only. Now the price question, various price question at the end. I have announced that day. Anbu, see, Anbu might be in the, yes, Anbu is still in the chat box. He is from Tamil Nadu. I even don't know that time that he was from civil. He mailed me his phone pay and GPay number. Then I asked him that in which branch you are. He says, otherwise if he is from mechanical also, we will give him. So Anbu and Manas, we have given the prize. We have only promised for one prize, but we have given 2 prizes. Okay, Akila. Okay, Nils. Okay, Prashant LCT. Okay. I will take the photo at the after this session. Between midnight we'll be having many hours. So there I'll check. Okay, Nils. Okay, Raj. Prince, we are using, why not using for, that is the question. Now, why not using? Why not significant there? Okay, Swapnil, no answer is correct till now. No answer is correct till now. No answer is correct till now. No. No, no, no. Find this a height ratio of specific surface area. Due to cohesive property. Greece little bit correct. Ion significance related density, it is very good indicator of denseness of course in comparison to void ratio, hence no, leave, I am not giving point in this to anyone. But see, I will give anyhow, I will give prize. I am not giving in, okay, I am not giving anyone. See, let me tell you. No, Girish. Now let me tell you. And why I am watching in mobile? Why I am watching in mobile? It is visible there also. Okay. So let me tell you, guys. इस कमरे में मत लगाना ना. Now, see. Why I am see, guys, in coarse grain soil, it gives us the relative density. Okay. So if relative density is more, that we say it is a strong soil because voids are less. But it has no significant, Dinesh, I am telling that only. It has no significant in fine grain soil because even in fine grain soil, if relative density is less, that means voids are more. We cannot comment that soil is not strong. Even with more voids, even with less relative density, we cannot say that soil is more strong, is not strong. Because in there, the strongness depends on the cohesion. Might be the voids are more, it is loose, but cohesion is binding them to make them strong. Might be couple of people have written this, but I am not getting their intentions correct from void ratio only on cohesion only. I hope you got it now. Guys, there is saying in Hindi, दूर से देखा तो गंजे खेल रहे थे, दूर से देखा तो bald people are playing, गंजे खेल रहे थे, पास जाके देखा, when I go near, actually अंडे उबल रहे थे, eggs are boiling. दूर से देखा तो गंजे खेल रहे थे, पास जाके देखा तो अंडे उबल रहे थे. From very far I was seeing that bald people are jumping. When I go near, actually the eggs are boiling. So in fine grain soil with relative density, you can't do anything. Even if it is loosest state, you cannot say that it is not strong because the cohesion is binding there. Okay. Now this relative density has one more formula which is derived from here only. When it is maximum void ratio, gamma d minimum. This is natural case. When it is maximum void ratio, minimum density. When minimum void ratio, gamma d max. Now everyone please see. Now coming to the index property. Before that I want to chit chat with you a little bit, if you allow me. If you allow me, I want to do chit chat with all of you. Okay. Can I my commandos? Guys, first of all I want to give you a little bit little bit some very important things I want to tell you. Today in this session, whatever I'll be telling you, that will be bottom from my heart. That will be from bottom of my heart. Guys, see, please don't be afraid with GATE exam or anything. Please don't be afraid with GATE exam or anything. Because I believe that yes, GATE exam makes career, but the career is not only made by GATE exam. There are various other exams from which you can clear, and even not exam, there are various other things from which you can take a very good life. Let me tell you my story a little bit. Guys, I cleared GATE exam after my year back. I got a year back due to certain reasons, and after 5 years of BTech, I got a GATE 164 rank. So in general category in 2011, even in 212 rank, IOCL has called, but in 164 rank, no PSUs called me that time in 2012. The number of seats are decreased with compared to its previous year. I was having no intentions to join IIT, but since I don't got any PSU, I got placed in ACC company. That was the highest package in my college. But okay, I thought that let's join IIT. We'll give one more time exam for a government exam. But unfortunately, I was not very sincere student, not hardworking. I didn't get anything in those 2 years of MTech. And I also not even applied for placements. So it is almost looking like career is gone. I am gone. From a very bright student in school, being an Olympiad topper in school, All India Olympiad rank 36, in maths CBSE board 36, 100 out of 100. But I am not very proud about my 100 marks in 12th. I am very little bit proud of 36 rank in Olympiad. Okay, and then after BTech getting IIT, not getting PSU even with 164 rank, then and MTech, I was not very sincere, not hardworking. I think my career is gone. Now it is like from a very bright student to nothing, from hero to zero. That time I was not aware about this coaching and all these things. Then suddenly somebody called me that will you teach in Chandigarh? I will say yes. Paisa to kamana hai, I want to earn. He said only 1200 rupees you will get per hour. Actually, when I was in MTech 2012, I go for a coaching in Delhi in Pitampura with 400 rupees that time per hour. But after MTech, somebody called me 1200 and he said that aane jaane ka will give the ticket and hotel will be giving you and morning breakfast will be giving you because it is complimentary. So I thought, yaar, this is very good, yaar. In 1200 per hour and tickets also and hotel also and morning breakfast also. And if I teach every day I have to teach 4 to 5 hours, so it will be 6,000, 7,000, which is very fine. But actually I have to teach 6 hours, but because that time I was very new in the teaching field, first time entering teaching highway that time, so I was not able to prepare the content of 6 hours. So after 2.5 hours, 3 hours, I come to my hotel back because I only prepared that much content. So now if anybody gives me a seat in engineering service, of course my age is not that, but suppose somebody external forces or you prime minister and anybody that okay you want to ESC or any supreme power is offering me a ESC seat or PSU seat, but I'm very happy now with this. Whatever they are earning in 12 months, I am earning in, okay. So now that is jokes apart. Yes, the ratio is very good. Okay, whatever they are earning in 12 months, I am earning in, okay, that's good. But more important is the satisfaction. Okay, more important is the love. मेरे को अभी भी पता है कि एक engineering service officer, if he is going in the mall, might be nobody is knowing him, and if I goes to a mall in Noida or anywhere, a couple of people always meet me that I have seen sir in YouTube. Earning in 1 month, Neela, what to hide in that? Okay, so I know that most of the IAS officers are going in the mall, or if somebody is from railway, my friend is from railway, all India rank 20 in 2011, no 12. Because that friend was my from junior class. I have 2 classes now. I have done my 5-year MTech. One was my original class and one was in junior class. So if he is from earlier he was from Malda division. Now he is in Jodhpur. If he is going Jodhpur railway station, everybody is okay knowing him. But if we go, both of we go to a random place, new place to both of us, there is high probability and maximum times it happens that I got someone, and most of the times again he is praising me. Yes sir, you teach this subject well, this subject well. That time the feeling है भाई बेटा उस समय तू IAS बन गया, बहुत हीरो बनता था, IAS बन गए तुम, उस समय हम 4-5 साल बहुत टेंशन में थे, अब देखो. Okay, so the teaching is not only the option, there are various other things. But I want to say that if you have this if you have this mind and a good heart, I have completed the answer 12 months to 1 month I have completed. So if you have good heart and brain, you can earn anywhere, because you want to earn पैसा कमाने के लिए, you earn money. It should not be the engineering service degree or gate degree is not required aptitude, the mind is required. CD में एंड में 0 हो जाएगा प्रवीण, क्योंकि CU और UU में तो तुम एक्सेस पोर वाटर प्रेशर को डिसिपेट ही नहीं दे रहे ना. U है वो तो लास्ट में U है, तुमने वॉल बंद कर दिया तो जितना एक्स्ट्रा पोर वाटर प्रेशर आया उतना रहेगा, मेंटेन रहेगा. लेकिन CD में तुमने पारा पानी बाहर निकाल दिया. Now guys, coming to the index properties, the first chapter is bigger guys. Whatever time it will take in first chapter second, third, fourth, fifth chapter equal time. So don't worry guys. Index properties are, guys, can you just one more thing, can you please let me know the answers? Can you please let me know the answers of comment box? Your year, are you in third year, fourth year, second year, pass out, comma city, like second comma Gwalior, third comma Guntur, fourth comma Vizag, pass out comma Madurai, like this. Class will end when the syllabus will be completed yaar. Just kidding. Pass out Delhi, fourth year Vizag, RK Beach, fourth year Jaipur, Pink City, Hawa Mahal, pass out Aurangabad. Swapnil I know, Girish I know, Alikya I know, Padma from Guntur, MVS from Tirupati, Namaskar, Balaji, Khammam, fourth Vijayawada, Prince I know you are, mustache person from Punjab, Talwara Township. Third Nellore, pass out Bhiwani, Jai Bhiwani, pass out Solapur, pass out Kolkata, Chatterjee Sahab, House, Havda Bridge, Payday, Allahabad, Payday? अरे अरुण पेडे क्या होता है भाई? अरुण मजा आ रहा है आज? मतलब सही मजा आ रहा है कि नहीं आ रहा? मजा आ रहा है कि नहीं? कर्नाटका, बालाघाट, खानसा from MP. How are you? गुवाहाटी, पास आउट त्रिशूर, पास आउट कोलकाता. अरुण मजा आ रहा है. चलो चले आगे चले. सब्सक्राइब कर लेना नहीं किया तो, अगर अच्छा लग रहा है चैनल तो. जबरदस्ती नहीं करना है, जबरदस्ती नहीं करना है. इफ यू आर लाइकिंग द चैनल देन ओनली सब्सक्राइब, अदरवाइज नो नीड टू सब्सक्राइब. Okay. Now index properties are those properties. Index properties are those properties from which we identify the engineering behavior of soil. There are two types of index properties. One is soil grain property that depends on particle like size, that depends on particle, diameter, shape on one particle. One is soil aggregate property, the whole skeleton. Like void ratio will not depend on one particle. Void ratio will be dependent on the whole skeleton. Okay, porosity will be depending on the whole skeleton. Okay, so guys, grain properties are those properties where we are only finding, where those properties only depending on one particle, shape, size. Aggregate is on the whole skeleton. Now, one very important and very logical thing, that if you want a grain property, it's okay. You can take a disturbed sample also, undisturbed sample also, both fine. Both fine. Because one particle will not change. But you want aggregate property, two things. Either you take an undisturbed sample, because once you disturb the void ratio, the properties in the density, everything will change. So either you take an undisturbed sample or you do the test in the field itself. Got it? This aggregate for this, see guys, if you have to know the whole property of the skeleton, either take the undisturbed sample or do in the field itself. Given property can be done anywhere. Now guys, I want to know the shapes, how much are bigger, how much are smaller. This is very interesting chapter now. Smaller like this. So what we do here, we take sieves, different sieves, bigger, smaller. Okay, we bigger at the bigger sieves, smaller. We put 1 kg of sample, shake it for 15 minutes. After shaking for 15 minutes, we measure what is at the top, what is here, we measure this. Okay, like this. Now measuring, we get, suppose there are actually 11 sieves, 4 and then 7, 11 sieves. This is all micrometer, yeah. 600 microns, 200 microns, and below this it will be fine grained soil. Now suppose we are having these 11 sieves and this is data we got. We put 1 kg of soil, 1000 gram, and we got the data like this. Now everybody please see. So if I write the cumulative data, this is 100, this is 150, this is 160, this is 200, this is 400, this is 700, this is 800, this is 850, this is 865, this is 875, this is 900, and this is 1000. Cumulative. These are the data that are obtained on different sieves. Now cumulative is this one. Okay. After cumulative weight, the total was 1000 gram. Okay. After the total 1000 gram, if I do the cumulative weight out of 1000, 100 is 10%, 150 is 15%, 160 is 16%, 200 is 20%, 400 is 40%, 700 is 70%, 800 is 80%, 850 is 85%, this is 86.5%, this is 87.5%, this is 90%, this is 100%. Okay, now I will explain you, don't worry. Now after here, if I go for the percentage finer, after here if I go for percentage finer, everyone please see. After here I am going for percentage finer. This 10% cumulative weight, percentage finer is 90%. It is 15, so it will be 85, 84, this will be 80, this will be 60, this will be 30, this will be 20, this will be 15, this will be 13.5, this will be 12.5, this will be 10, this will be 0. Now it is very logical also. It is very logical also, guys. How? Please see here, everyone. If above 80 mm 100 particles are retaining, therefore below 80 mm how many particles? 900. That is 90% are finer than this. 90% are finer than this. Have you got it? If above 20 mm 50 gram particles are retaining and 100 mm is already above that, so above 20 is 150. Above 20 this is retaining and this is already retained. On 20 this is retaining and this is already retained. So above 20 is 150. Above 20 mm sieve is 150 gram. So below it is 850 gram. That is 85%. Have you got it? Have you got it, guys? Everyone please let me know. Why suddenly the attendance is decreased? Okay, leave. Guys, audio video perfect fine? Audio video perfectly fine? Please let me know. Okay. Now this is the final. Now from here I draw a graph. On y-axis, my energy will be same even if there is 1 student or 0 student. My energy will be even more increasing. Okay. Now if I draw a graph, log percentage final log D. We make a semi-log graph paper. Why? Because diameter has a huge range. From 80 mm to 0.0075 mm. Huge range. So that huge range should become in a simple scale, should become in a smaller axis. That is why I make it log D. Because see, suppose 10, 100, 1000. They are very far. Very far. But if I make log, they are come closer. They come closer. Okay. So whenever there is a huge variation, then in that case I use the log scales. Now, the percentage final versus log D graph will be something like this. Why? Because for more higher percentage, diameter will be bigger. Of course, yeah, 85% finer, bigger diameter. Bigger diameter has more number of particles, which are finer than that. Bigger number of particles will be having more. Bigger number of particles will be having more percentage finer, Then here, like this. Okay. Suppose let me talk about the 60. 60% is from this 2 mm diameter. 60% is 2 mm diameter. So 60% from 2 mm. Log 2 mm. Okay. 30 is from 1 mm. 1 mm is 30. This graph will be something like this. Okay. Now, this is the grain size distribution curve. There is a term called D60. D60 means that diameter through which 60% particles are finer. D30, that diameter through which 30% particles are finer. D10, that diameter below which 10% particles are finer. D22, any D, D22, that below which 22% particles are finer. D70, below which 70% particles are finer. Got it? Okay. So Cu is D60 by D10. Cc is D30 square by D60. For well-graded soil. Well-graded soil means where all ranges of particles are there. Big also, small also, very small also, medium also, XL also, double XL also. Well-graded means where all range of particles comes. Okay. And my friends, this is well-graded. For a soil to be well-graded, Cu and Cc should be in this range. Cu and Cc should be in this range. This is Cu and this is Cc. If it is not, then it is poor graded. Now, of course, one more thing I want to tell you here, guys, that everyone, now a question is coming, the prize question. Please check. This is percentage final. Be ready for the prize question. And this is log D. Now there are 3 graphs. Guys, this graph is well graded. If the graph is like this, so here we are getting here also value, 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 here also value. That represents the wide range of particles. Wide range. Okay, that means bigger also there. Smaller, medium is also there to fill the voids, and very smaller are also there to fill the smaller voids. That is well graded. Suppose the particles are like this. That means that all the sizes are here. All the diameter particles are here. That means it is a poorly graded or uniformly graded. Uniform and poor both are same. That means only same size particles are there. Okay. it is the same size. We are not having any graph here, we are not having any graph here. Okay, now if the graph is something like this, this is called gap graded. Gap grid means here the percentage below this is suppose 40% and the percentage below this is also 40%. That means from here to here there is no particles. Guys, suppose in a company there are 20 people who earn more than 2 lakhs per month and there is 20 persons who earn more than 3 lakhs. So 20% who earn more than 2 lakhs, 20% who earn more than 3 lakhs, that means between 2 lakh 3 lakh there is no one's salary. And this flat portion represents the gap gradation. So gap graded is like bigger particles are there and smaller particles are there. Medium particles are not present there. Okay, guys, for fine grained soil we cannot do sieve analysis. Can anybody tell me this? Guys, within next 5-10 minutes we are having a question, the prize question, but not this one. Guys, for fine grained soil we cannot do the sieve analysis, and because fine grained soil have cohesion, so they will stuck in the sieve, they will stuck in the sieve, they will stuck in the sieve, and we are thinking that is a bigger particle, that is why it is stuck in the sieve. But actually due to making flocks, there is cohesion in the fine grained particles. Due to making flocks, guchha, due to making flocks, this is stuck in the sieve. Actually the size is smaller. So for fine grained analysis we do the pipette and hydrometer analysis. Okay, actually this is not have come in the examination till now, so I'm not doing this. Have not come in the examination till now, so if at the time at the end remains, then I'll be doing this. Not a single time this is asked in the gate examination. Okay, now the consistency limit of the soil. Guys, if I make a graph of volume and water content, then initially when the soil is dry, this is air, so volume is VD. Then we fill little amount of water, still it is not dry, but volume is same VD. More water it is same, Once the stage will come, then all air voids are filled with water. Once a stage will come, then all voids are filled with water. Price question is coming just after 2-3 minutes. Once a stage will come when all voids are filled with water, that is called shrinkage limit water content. That is called shrinkage limit. This is WS, all are a small w, shrinkage limit water content. This is shrinkage limit. This is shrinkage limit. If we add water beyond this, then the volume will increasing. I hope you got it now, that initially the volume is constant. But after shrinkage limit it increases. And WL is the water content after which soil behaves like a liquid. Very less shear strength, 2.7 kN per meter square. Very less shear strength. Around 2.7 kN per meter square. Liquid state. Okay, after which soil behaves as a liquid. No shear strength, negligible, 2.7. WP is a water content after which soil behaves as a plastic. That means with a constant stress, strain is happening. WS is the shrinkage limit at which soil is fully saturated. Now I am telling a statement. This is not a price question. Shrinkage limit is the maximum water content at which volume is VD. Correct? In all these water contents, volume is VD. Out of these various water content, it is maximum. So shrinkage limit is the maximum water content at which volume is VD. Another thing. In all these blue phases, guys, is saturation is 1? Please let me on the comment section if it is right. After here saturation is 1. Please let me know in the comment section. Yeah, come on. Here saturation is 1. Here saturation is 1. So guys, shrinkage limit water content is the maximum water content at which volume is Vd. Out of these various water content, it is the maximum at which volume is Vd, and it is the minimum water content. It is the minimum water content at which saturation is 1. At all these values, saturation is 1. This is the minimum. At all these volumes, volume is Vd. It is the maximum. Have you got it? Have you got it? Please let me know in the comment sections. Please let me know in the comment section, guys. Please let me know. Yes. Now the question is price question. Now the price question is, guys, where is zoom here? First of all, let me make it. I want to save, otherwise, guys, see here, out of 400 slides, this is 25% completed in the first chapter only, yaar. So don't think like that we are still in the first chapter. I told you that total time taken in the first chapter will be equal to total time taken in 2, 3, 4, 5 chapter even. We are almost 1/4. Almost, even more than 1/4. Okay. So this is like this, where there was a zoom option, na? Now the question is coming. How to do that zoom option? How to do that zoom option? Screen, presenter view, arrow options. Arrow options भी आता है क्या इसमें? Okay. Leave. Guys, have you seen these kind of lines? This line, this one, ये वाली लाइन देखी है क्या कभी? प्राइस क्वेश्चन है, पहले वाले प्राइस क्वेश्चन का किसी ने आंसर नहीं लिया. प्राइस क्वेश्चन, हैव यू सीन दिस लाइन, और यू आर सीइंग द फर्स्ट टाइम, have you seen this line? Now tell me the significance of this. More than 25%, guys, we have completed. Excellent achievement. Tell me. Sudden volume change, no sir. Volume increase, actual behavior of soil. Prakhar, actual behavior of soil means actual limits. किसी ने, have you in any of the book, any of the teacher have not taught you this? Even I also. Nobody. Price question, yaar. First price question, nobody has given the answer. Second price question, nobody is giving the answer. The volume change is not sudden. Why, Prakhar? Price question, yaar. Indicates the shear strength? No. Please tell me. Everyone. No, why actual, that is my question, Girish. Why actual behavior is showing like this? Why actual behavior is showing like this? Why actual behavior is showing like this? Any answers? Okay, so as far as I got the answers here, I am giving this to Prakhar Srivastav. Prakhar, But there are various other questions, na? So Prakhar, thousands of the people will be taking this PDF. Your name will be there. Your name will be there. Look, let me tell you all of you. Let me tell you all of you. Guys, actually na, suppose these are solid grains. These are solid particles. Soil. These are solid grains. है ना? See. Most of you are getting this first time, this concept. This can be asked in 1 marks in GATE. Now what happens? When the water you pour, volume is same, 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 volume is same. Might be it is not fully saturated. Here a small void is there. Here a small void is there. But now when you are adding more water, when you are adding more water, it is not necessary. It is not necessary that that water will go here. It is not necessary that that water will go here, because the void is blocked from, that void is blocked from all around. So that water is now increasing the volume. Even the shrinkage limit is not coming. This small void is still there. This small void is still there. This small void is still there, but that water you are adding is not going there. That void is blocked. Have you got it now? Give me yes or no. And I guess most of you are getting this first time. Most of you are getting this first time. Please let me know in the comment sections, everyone. Everyone. Please. Have you got it? Enjoyed? Yuvraj, share kar do yaar. Yuvraj, please share the session. Okay. Now, liquid limit is that limit after which soil behaves as a liquid and shear strength is negligible, 2.7. Now, how to find liquid limit? There is a Cassegrain apparatus, and in that Cassegrain apparatus, there is a katori like this. There is a katori like this. In this katori, we fill the soil. In this katori, we fill the soil. Then we blow this. Then this katori go one touch. We blow one more, one touch. We blow one more number of blows, one touch, like this. Okay. So we fill this katori, we fill this bowl with soil paste. We fill this bowl with soil paste, and then from a knife, Cassegrain knife, 2 mm is the thickness, we cut the groove at the center. We cut the groove at the center from here. Okay, then after number of touch, that soil will come closer. That soil will come closer. So if we draw a graph of water content and log n is the number of blows to close the groove. N is number of blows to close the groove. Then this graph will be something like this. Obviously, more water content, more slurry will be the soil. More water content, more slurry will be the soil. Less number of blows will be there. Even with 2-3 blows, they will come in contact. And if the water content is less, more number of blows are required. If water content is less, that means it is dry soil, more number of blows are required. Okay. So the slope of this graph, suppose this value is W1, suppose this value is W2, slope, this is number of blows are N1, this is number of blows is N2. So slope of this graph is called flow index. That is, I am just representing magnitude wise, Y2 minus Y1 upon X2 minus X1, N2 by N1. And what is liquid limit here? That is that water content up to which the number of blows are 25. This is this water content up to which the number of blows are 25. The water content at which 25 blows will close the groove, that is called as liquid limit water content. That is called as liquid limit water content. Have you got it? Okay. Now there is a cone penetration method also, IS cone method, from where we put a soil here and we drop a cone of a standard height and a standard weight. Okay. So at which 25 mm cone is penetrating, that water content is called as liquid limit. This is one way, Cassagrande's ways, and there is a IS code method. In IS code method, what happens? We fill with soil paste. We fill here soil paste and we put the load, standard cone with standard height and standard weight. We put the cone at that water content where the cone is penetrating 25 mm. That water content is taken as liquid limit. Now plastic limit is at which a 3 mm thread, when we are making a 3 mm thread, it starts to fumble. That water content at which the 3 mm thread starts to fumble is called as this. Of course, what is, guys, we add the water, when it comes here, that is the shrinkage limit. Okay, what is consistency index? WL minus W upon WL minus WP. IP is also called as WL minus WP, liquidity index minus plasticity, liquidity, water content at liquid limit minus plastic limit. So IP also you can say is represents the range. IP represents the range where the soil remains plastic. This is WS, this is WP, this is WL. So IP is this, WL minus WP. It is a range where soil remains plastic. Okay. So WL is liquid limit water content, or liquid limit, WP is the plastic limit, and this W is natural water content. Okay, if natural water content is less, I consistency will be more. So more is the value of IC. That means that water content is less. IL is 1 minus IC. If IC plus IL is equal to 1, liquid index. See, IC is WL minus, this W means natural water content, upon WL minus WP. So if IC plus IL we do, then from here we got one value. Okay, and what is the significance? Significance is that if water content is less, then IC will be more. Means if IC is more, that soil is very solid, and if water content is less, IL is more, IL is less. Okay, so these are the range. Like, there's no need to remember this. See, suppose IC is more, I told you na, when W is less, IC is more. So when IC is more, it is brittle. Solid soil will always break suddenly. Okay, so like W is less, IC is more. When IC is more, it is stiff, and when IC is less, it means liquid state. Have you got it, everybody? Give me yes or no. Give me yes or no. Everyone. IT is a toughness index, and it is IP by IF. IT is a toughness index, it is IP by IF, and it represents the shear strength at plastic limit. It very important for gate in 1 marks. It represents shear strength at plastic limit. Means that soil whose IT value is more, toughness index is more, that means it is more stronger at the plastic limit. This we have already studied. E less, DR more. So more relative density, I already told na, when it is more, less voids means dense. We have already studied this. Thixotropy is the property of soil by virtue of which it regains its strength. Suppose you disturb the soil and you put down in the floor for next 2 months. Okay, then due to its self weight, it is compacted. Guys, one way of compaction is certain external loads are applied. Otherwise, due to its own weight, it will is compacting, making it stronger. That property of gaining strength after some time is called as thixotropy. And sensitivity is very simple. The ratio of the strength of soil when it was originally there, undisturbed, and after remolding. Suppose the strength of a soil is 20. After remolding it, the strength becomes 10. So sensitivity is high. Suppose the strength of a soil is 20 and after remolding it also 20. That means there is no change, no sensitive. Okay, like this. Activity is IP, that is WL minus WP upon percentages of clay particle. Now these are the properties that you can learn. Okay, otherwise you can do it from one way. One trick I am telling you. Okay guys, till now Prakash Srivastav is leading. Let us see who wins the cash prize at the end. If WL is more, one trick I am telling you to do many questions in GATE examination, then voids will be more. And this is not trick, I am logically telling you. If WL is more, then voids are more. If WL is more, that means voids are more. Why? Because that soil which is having more voids, that soil which is having more voids can contain more water. So shrinkage limit will be coming after a very long time. And when shrinkage limit is coming after a very long time, that means plastic limit and liquid limit is also coming after very high water content. I hope you got it. I hope you got it. Okay, because those soil which are having more voids, उसमें बहुत सारा पानी आ जाएगा. Lot of water will come to make it saturate. So further plastic limit and liquid limit will also be more. So when WL is more, voids are more. So voids are more, so strength will be. Voids are more, so shear strength will be less. If voids are more, strength will be less, If voids, see WL more, here WL same. So WL more means voids more. Voids more means strength less. Easy to remember. And if voids are more, then permeability will be more. For same size of particles. For same size, void size is not changing. It is not like coarse and fine. It is in coarse and coarse. अगर coarse ही coarse में compare करना है, when the voids is same, in that case, where the more number of voids are there, that will be more permeable. Okay, so permeability will be more. And when voids are more, compressibility will be. Voids are more, compressibility will be more. Compressibility will be more. And when voids are more, toughness will be less tough. Okay, when voids are more, permeability will be more for same size. Now everything is remembered with just one single way. That is also logical. Have you got it? Guys? Everyone? Now this you can take as a homework. Guys, these two sessions will be coming in next 2-3 days. Here, any doubts related to you and how to utilize those 3 hours. Okay. This will be, tomorrow will be FM session. Then Sunday, Monday. Monday will be top 100 questions by all of us faculty. And a special marathon this time for serving will be midnight. Monday 9 p.m. And this is today night. Okay. This workshop will be on 15th of January at 12:30. Okay. So this is your schedule. Yes, these 3 are done and this is 30% or 35% done. Okay, this will be tomorrow, then 100 questions, and serving will be night. Serving marathon will be night. Okay, and you can find the PDF in my Telegram group, Civil by Abhinav sir. So now the first chapter is done, that is around 35% of the whole syllabus. Now these chapters classification, compaction, this will take 10 to very less time. Okay, chapter 2 classification of soil. Ready? Or you want a break? अब ब्रेक का सीन बता दो आज पहले एकदम ईमानदारी से. ईमानदारी से ब्रेक कितने चाहिए? ब्रेक 10-10 मिनट के चाहिए? कितने कितने के चाहिए? Break for 5 or 10 minutes. Yes or no? ओके 5 मिनट्स का ब्रेक देंगे. ठीक है, 5 मिनट्स का ब्रेक देंगे. रुको, लेकिन उससे पहले आप एक पोल भी डाल देता हूं मैं. पाँच 10 मिनट का दे देंगे यार. 5 मिनट में कुछ नहीं, उसको तो फिर से दे देंगे भाई. एक और पोल डाला है, इसका आंसर बाद में देते रहना आराम से. लंच वंच कुछ ब्रेक नहीं होगा. लंच वंच नहीं होगा, 5-10 मिनट के ही ब्रेक होंगे सिर्फ. ओके, सो चैप्टर 2 उसके बाद स्टार्ट करेंगे हम. ठीक है, चैप्टर 2 स्टार्ट करेंगे. अच्छा, और एक 10 मिनट्स का ब्रेक है अभी. वो पोल का आंसर दे देना. ठीक है, और किसी को कोई डाउट होगा तो सिविल बाय अभिनव सर पे आ जाओ. सिविल बाय अभिनव सर पे आ जाओ, चैट करते हैं. ठीक है, 10 मिनट्स का ब्रेक होगा. टाइम बता देता हूँ मैं आपको कब आना है. यार फेसबुक में भी शेयर होता है क्या लिंक? मैं आज तक सिर्फ कल किया था एक बार, और एक बार बहुत पहले किया था. एक बार डाल के देखता हूँ. ठीक है, 10 मिनट्स का ब्रेक है, और सिविल बाय अभिनव सर पर आ जाओ. एक बार शेयर भी कर देना वीडियो को प्लीज़. मैंने अपने फेसबुक पे लगा दिया, आप भी अपने फेसबुक या कहीं पे अगर आपको अच्छा लग रहा है तो ही, आपको लगता है कि बाकियों को इससे फ़ायदा होगा तो आप भी लगा सकते हैं. ठीक है, ठीक है, सेकंड चैप्टर पढ़ेंगे इसके बाद, और इसके बाद ना नेक्स्ट 10 मिनट्स में सब कुछ होते जाएगा. बहुत सारे छोटे चैप्टर हैं, 2-3 लगातार. हम मिलते हैं 12:45 PM पे. लाइक और शेयर कर देना भाई. 12:40 लिख रहा हूं मैं. ठीक है, चलो भाई, मैं भी जरा पानी. यस 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 यस, थोड़ा माइक पहन लेता हूँ, माइक पहन लेता हूँ भाई, माइक टी शर्ट के अंदर से जाएगा इसलिए कैमरे से अलग। ओके, चाय वाय पी ली? चाय वाय पी ली? भाई चश्मा कहाँ है? ओहो, गुड आफ्टरनून। यस आई, वो भी होगा, इस पूरे टेक्निकल सब्जेक्ट्स का हो जाए उसके बाद वो भी कराते हैं। ओके, ओके। क्या 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 किया आपने ब्रेक में, ज़रा बताइए, हम भी देखते हैं बच्चे क्या क्या कर रहे हैं ब्रेक में। एवरीबडी प्लीज़, ब्रेक में क्या क्या किए? एट लंच? वाह, इतनी जल्दी? Soil classification, तो I'll be teaching like this, like you'll never forgetting this. मेरे तो घर में भी there is no one in my home right now, so no, and I don't know how to make food. I know how to make tea, but आलस बहुत बड़ी चीज़ है, भगवान सबको नहीं देता। Okay, shall we begin now? Shall we begin? मैं हीटर भी लगा देता ना इस कमरे में, लेकिन आई एम नॉट वेरी श्योर दैट दिस स्मार्ट बोर्ड is good for that or not, because when the person came here for putting the smart board, they told me that this requires AC or little less temperature. Okay, so guys, please tell me some feedback of the first chapter. Have you enjoyed it? Speed increase or decrease? More numericals will be doing in the night. Okay, numericals will be doing in the night. So now the chapters 2-3 next chapters are very small. So guys, have you shared it? One small request from my side, that have you shared it on Facebook, WhatsApp, Telegram, anywhere? Have you shared this? एक बार सिविल बाय अभिनव सर पर भी लिख दो यार बच्चों को कि ज्वाइन कर लो, आप भी लिख दो। So guys, please do join the marathon. Chapter 2 is going to start. स्पीड ओके यार, मेरा मन कर रहा है गूगल मीट का लिंक आई शुड बी गिविंग इन द कमेंट बॉक्स, एंड देन वी कैन हैव अ वीडियो कॉल एज वेल. weather issues life, and how life is annoyed from weather issues. I am not getting that. I am not getting that. गर्लफ्रेंड से तो होता था लाइफ अनॉयड, पर हाउ फ्रॉम वेदर? अच्छा, फैमिली वेदर. ओके 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 ओके. Shall we start? Ready? Please put a heart sign if you all are ready. Please put a heart sign if you all are ready. Let's begin. Okay. Okay. So guys, now we will be classifying the soil. That means we are putting the soil groups, like this soil will be in this group, this soil will be in this group, this soil will be in this group. Certain soil behaves to a certain pattern. So we will be distributing the soil into different groups. That this soil is from this group, this IPL team. This soil is from this group, this IPL team. This soil is from this group, this IPL team. So we'll be distributing those in certain groups. Okay. Now there will be a name prefix and a suffix. So prefix names, if there is G, it will be named as gravel. If it is S, it will be sand. If it is C, S and both are S, sand and silt. So silt will be representing with M, C, O and PT. For well graded, I'll be writing as W. For poorly graded, it is P. For silty, it is M, C. WL less than 35, low compressible, that is L. 35 to 50, intermediate compressible, that is I. Greater than 50 is high compressible. Now, have you ever wondered why this is like this? This is only due to the reason that I have just told, that if voids are more, then that means that liquid limit will be more. If voids are more, then that means the liquid limit will be more, because that soil which is having more voids can accommodate more amount of water in it. And when it can accommodate more amount of water in it, that means liquid limit will be more. Okay, because shrinkage limit, that is S is equal to 1, is coming after a long time. So when shrinkage limit is more, the further liquid limit will be more. Okay, so when liquid limit is more, that means voids are more, so high compressible. When liquid limit is less, that means voids are less compressible, and here it is intermediate. Now guys, everyone please see here, is greater than 5% and less than 12%. For guys, next 10 minutes, if you listen to me properly, then I am assuring you, giving you the guarantee, then you are the champion in this chapter. You are the champion in this chapter, and you will never ever forget this. Okay, let's begin. After now, till 10 minutes, I will not be taking any doubt now. So till 10 minutes, please don't comment anything. Make your mobile or computer in the full screen mode. No comments, because I am not taking only teaching for the next 10 minutes. Let's begin. Guys, anything which is less than 80 mm is a soil. Okay, anything which is less than 80 mm is soil. Now, out of that soil which is less than 80 mm, if more fraction is coarse grain soil, then it is termed as a coarse grain soil. Suppose there is 1000 gram soil, and out of 1000 gram soil, the more part is coarse grain. How to find it is more part is coarse grain? There will be a sieve, 75 micron sieve. Okay, there will be a 75 micron sieve. We will put the soil there, and if more part is retained, that is coarse grain soil. Retained is coarse grain soil, and that thing which is passing from 75 micron is fine grain soil. So if more is retained, it is a coarse grain soil. If more is passed, that is a fine grain soil. Now let's suppose this is case 1, this is case 2. So case 1 is that out of 1000 gram soil, more part is retained. So it is coarse grain soil. Now in coarse grain soil, that is more than 50% is coarse grain. Further, there are 3 cases: case 1.1, case 1.2 and case 1.3. Case 1.1, case 1.2 and case 1.3. Fines means, here everywhere written is fines. So fines means fine grain soil. Fines means Fine grain soil. Okay. Now, out of the case 1, that more part is coarse grain soil, I'm still saying that case 1.1 is that fines are even less than 5%. Fines are less than 5%. That coarse grain soil is already more than 50%. And fines are even less than 5%. That means coarse grain soil is more than 95%, 96%, 97%, 98.5%, 99%. That majority is coarse grain soil. And when majority is coarse grain soil, only 96, 97 is coarse grain soil. Only fine grain soil is 3-4%. The names are GW, GP, SW, SP. Now, whether the first name is G or S, simple. If gravel is more, the first name is G. If sand is more, the first name is S. Simple. The first name will be G or S. It depends on the ratio of gravel and sand. If gravel is more, G will be more. If sand is more, S will be more. WP. WP is on the basis of CU and CC. Here are the CU and CC. Here there are CU and CC. Here there are CU and CC. Kahan gaya? Yeah. This one. If for gravel, CU greater than 4 and CC is in this range, both should be done. Both should be in this range. It is well graded. If any one of these things are not in the range, it is poor. Similarly for sand, if CU greater than 6 and CC between 1 to 3, both should be happening. Both should be satisfying. It is well. Even one is not there, so it will be poor. So on the G and S, here the case 1.1, case 1.1, case 1.1, G and S will be decided if gravel is more or sand is more, and W and P decided on the basis of CU and CC. Okay, got it, sir. Okay, I will tell the concept also. Just let me write the name, so I will tell you the concept then. After, if fines are more than 5% and less than 12%, fines are more than 5 and less than 12. Fines are more than 5 and less than 12. More than 5 and less than 12. That means coarse grain soil is 94% and fines is 6%. Yes, it's fine. Coarse grain soil is 90% and fines is 10%. Yes, it is in this range. Fine is 10. Coarse grain soil is 89%. Fine grain soil is 11%. Yes, in this case. So here the name will be GW, GC, GW, GM. I will tell the logic of all these. GP, GC, GP, GM, same for sand. SW, SC, SW, SM, SP, SC, SP, SM. Now, before telling you all these names, let me tell you about the plasticity chart. There is a plasticity chart like this. Even let me make a simpler one. Yeah, let me make a simpler one here, here, here. Let me make it here. Simpler chart, plasticity chart. That is very complex there. This is IP on the y-axis. IP is WL minus WP. WL minus WP. And here is the liquid limit. There is a A line and this is a A line. A line equation is that IP is equal to 0.73 WL minus 20. So when WL is 20, IP will be 0. When WL is 20, IP is 0. Okay. And here is, suppose WL is 35 on x-axis. Here is a 50 on x-axis. Now, if the soil is here, left side of 35, it is L. If soil is left side, I told you just, when liquid limit is less, voids are less compressible. If liquid is more, so it is more voids, high compressible. Here it is L, here it is intermediate, here it is intermediate. I just told you, when liquid limit is more, then it means more void ratio, high compressible. So you are getting the logic. Many of you have studied till now, it is more than 50, it is high. Why it is high? Because more than 50 means more void ratio. More void ratio means more compressible. And here above A line, it is CH, CI, CL. Here it is MH, MI, ML, or organic can also be below. Organic soil is also below. Now leave organic. Now you have got the logic now today that white is H, white is L. You got the logic. Now, guys, friends, why clay above and silt below? Why clay above and silt below? Why clay above and silt below? Because clay is more IP value. Clay is more plastic. Clay is more plastic, guys. See here, this is WS, this is WP, and this is WL. Okay, plastic is this range, na? That is WL minus WP. This range is plastic. This range is more for clays. Clay is a more plastic soil. Yes, Sudeep. Clay is a more plastic soil. So this range is more. This range is more for clay. That is why the clay has even more IP value. That is why it is above. And below it is silt. Have you got the logic today now? Have you got the logic today now that why clay above? Why silt? Okay. Now organic is also below. Now if it is below, that how to distinguish it is organic or silt? By default, if nothing is mentioned in the question, you should be writing it as silt, not organic. Because organic is not in our syllabus. Organic is not good soil. Not good soil for a civil engineer. Because organic soil have large compressibility. First floor will become basement. For agricultural engineer, might be organic soil is better. Okay. So, if it is below, by default, if nothing is mentioned, we'll be treating it as a silt. We'll be treating it as a silt. How to, in practical life, in questions we'll be treating as silt. In practical life, how we will distinguish that it is organic. Organic soil is dark in color, and organic soil loses more weight on heating, because normal soil only loses water. Normal soil only loses water, but organic soil loses organic compounds also oxidize there. Organic compounds also oxidize. Okay. So above A line it is Cl, Ci, Ch. Below. And how to find it is above or below? Let me take an example. Suppose WL, liquid limit from Cassegrain test of a soil is 40 and IP value of a soil is 20. Now how to find this? Now let us go to the A line. Let us go to the A line. A line IP is 0.73, WL minus 20. So our liquid limit is 40. So 0.73, 40 minus 20. So that is 14.6. That means on A line, it is between 35 and 50. The value is 14.6. But our IP is 20. So it is above. So it is CI. Why I? Because it is between 35 and 50. Why CI not MI? Because our IP is bigger. Our IP is more than 14.6. If IP is 13, less than 14.6, it will be MI. Okay. Now one more question may arise. One more question may arise. Sir, gravel and sand, we are not doing this, and here we are doing plasticity chart because fine grain soil cannot be judged from sieve analysis. Here these distinction between gravel and sand we can define from sieve, but here C and M we will be justifying, we will be finding from plasticity chart. So first letter and third letter will be G if gravel is more than sand. First letter and third letter will be sand if sand is more than gravel. Remember the case, still we are here. And 5 to 12% mean coarse grain soil is 89%. Fine grain soil is 11% between this. Coarse grain soil is 90%. Fine grain soil is 10%. It is in, then the names will be this. So if first and third letter will be gravel, if gravel is more, first and third letter will be S if sand is more. W on the basis of Cu and Cc. If Cu is more than 6 and 1 to 3 is the value of Cc, it is W, otherwise poor. For gravel, if Cu more than 4 and Cc 1 to 3, W, otherwise poor. Now C and M on the basis of plasticity chart. C and M on the basis of plasticity chart. If above A line C, if below A line it is M. Okay. Now case 1.3, that fine grain soil is more than 12%. Fine grain soil is 20%. Coarse grain soil is 80%. Coarse grain soil is 70%. Fine grain soil is 30%. Coarse grain soil is 60%. Fine will be 40%. Coarse grain soil will be 30%. Fine will be 70%. Not this case. Then this will be this case. Okay. So here the names are GC, GM, SC, SM. Clayey gravel, silty gravel, clayey sand, silty sand. Okay, well-graded gravel containing clay in the gravel. Well-graded gravel containing silt in the gravel. Poorly graded gravel containing clay in the gravel. Poorly graded gravel containing silt in the gravel. Well-graded sand containing silt in the sand. Well-graded sand containing silt in the well-graded sand containing clay in the sand. Well-graded sand containing silt in the sand. Poorly graded sand containing clay in the sand. Poorly graded sand containing silt in the sand. Clayey gravel, silty gravel, clayey sand, silty sand. Okay. These are the names, and here the names will be Cl, Ci, Ch, Ml, Mi, Mh will be the names here on the basis of plasticity chart. So this is how. Now whatever I am telling you now, guys, from this you will remember this chart. This is whole chapter. This is whole chapter done. This whole chapter. Now whatever I am telling you, this you will remember for lifetime. For lifetime you will be remembering this. Now guys, why the name is this? Nobody book has written this. Why the name is this? Let me tell you. Guys, when the fine grain soil are very less, less than 5%, there is no significance. So neither we have written C, neither we have written M here. Only dominant things are coarse grain soil. Therefore, coarse grain soil and their properties. Coarse grain soil are distinguished on the basis of W and P. But fine grain soil, W and P is nothing. दूर से देखा तो गंजे खेल रहे थे, पास जाके देखा तो अंडे उबल रहे थे, दूर से देखा तो bald people are jumping. When I go near, actually eggs are boiling. Fine grain soil has nothing to do with W and P. Even the poor soil in fine can be good due to cohesion. Got it? So here, the names will be GWGP, GWGP, SWSP. No effect of C, M, L, I, H. Now little bit fines are more. So out of the 4 names, 1 name is for fine. G is coarse grain. W is also the cousin of coarse grain. W is also the coarse grain. Okay, W is also the coarse grain. Okay, cousin of coarse grain, because W and P has nothing to do with fine grain soil. So out of the 4 names, 1 name is of fine. And now when the fines are more than 12%, out of 2 names, 1 name is of fine. See, the fine percentage is increasing, so fine is taking the more effect. Here, no effect of fine. Little 25% name is occupied by fine. 50% name is occupied by fine. Guys, fine is more powerful in holding the name, because just when the fines is 13%, it is taking 50% shareholding in name. Out of the 2 names, 1 is fine. So when the fine is more than 50%, it is not giving any name to coarse grain soil. Both names C, 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 M, M, M are fine, and L, I, H are also associated with the fine. Now let me know in the comment box, have you understood this concept? Give me yes or no. Have you understood this concept? Give me yes or no. Everyone on the comment section. Please, everyone. Okay. So this we have done. Okay. Now, if a point comes here, neither it is L, neither it is I. So then we name it as ML, MI. If a point comes here, not above is clay, below is silt. If a point comes here in the gate examination, then the name will be MICI. Okay, if the name comes here, then it is not like MLMI, CLCI, that's MLMI. Okay. Now, guys, can you tell me this very interesting question? And the student who is giving the first, this is a prize question. Prize question. Prize question. Let me see who gives the name first. Let me see. First name in the comment box. B, C. Okay. Deepak, that day also given many correct answers. B. So I am taking 2 names, Swapnil and Alekia. I will give the announcement in the night. Swapnil, Alekia. Let me take 5 names here. Who has given it correct? Swapnil, Alekia, Ayan, Prince. 4 names. Ayan and Prince, and one more. Okay. सुदीप बुलाएंगे, बिल्कुल बुलाएंगे भाई जी. Okay, and Arun. Okay, so guys, the name will be SW. How? Let me tell you. Everyone, please see here. Cash price. Okay. Now, guys, 51% particles are passing through 4.75. 4.75 mm sieve. 51% particles are passing through it. That means 49% are here. 49% will be gravel, because more than 4.75 is gravel. So gravel is 49%. How much is fines? Fines is 2%. That is clay and silt. So how much will be the sand? Of course 49. So which case is this? Out of case 1.1, case 1.2, case 1.3, case 1.1, case 1.2, 1.3 and case 2. Which case is this? This is case 1.1. Okay, this is case 1.1. Okay, because fine is less than 5%. Case 1.1. So case 1.1, so name will be GW, GP, SW, SP. Case 1.1, so name will be GW, GP, SW or SP. This tie between gravel and sand, like this match. Yes, Sumit. Like this match. This is Men's World Cup, international match. Men's World Cup. Last time, 2019. Final match. Inland score, New Zealand score, I guess 242-243. 242-243, I guess little bit this much. And Inland were one time losing the match. But then the partnership of Ben Stokes and Josh Butler make them 2-2 tie. It was tie. And the tie, there is an error of umpire. When the Stoke was diving, the ball hit on the bat of Stoke and keeper ke piche se it was 4. Can you believe that? International match, that too the Men's World Cup final, has been tied. And actually the New Zealand must be winning that match, but due to the umpire's error, Ben Stokes has run 1, then again running to 2. When he was running to 2, he has dived and the throw from that player has hit the bat of Stokes, and instead of keeper, the ball goes beyond the keeper 4. Actually from the rule it was 5 runs, but umpire has given 6 runs, 2 of running and 4 of throw. With that extra run, they tied the match somehow. And you know, the miracles are still not stopping. In the super over match, again the match is tied. Come on, man, are you kidding me? The international men's World Cup final is tied and super over is again tied. Oh my God, this is not possible. Yes, that is the truth. Super over is again tied. This is not an ordinary match. And then who won? Inland. And the next time the headline comes that we don't have a loser, but yes, we have a winner, Inland. So Inland wins as per the ICC rules. When the match is tied, then those team who has scored more boundaries will be awarded as the winner. Inland has hit more the boundaries. And you know, if the boundaries are also matched, then what happens? If the boundaries are also matched, then what happens? If the boundaries are also matched, then the 10th class mark sheet of both the players will be taken. Then whose will be having more marks in 10th class will be awarded? No. No. So, guys, here in tie case, always remember, I'll tell you the logic, like I've told you the whole logic of this, na? No book it is written. Here also I'm telling you the logic. Guys, gravel and silt are tie. Now the super over is fines. Fines diameter is closer to what? Gravel or sand. These two are tie. Now this will give the vote. BJP and Congress both are weight. This is BJP, this is Congress, both are tied. Now Arvind Kejriwal will give vote to whom? Or AIDMK will give vote to whom? Chandrababu Naidu will give vote to whom? Or Surendra, Andhra Pradesh CM is here, what? That young dynamic fellow. Okay, who will, that will give to vote to whom? Okay, that is more near to sand. The diameter of Jagannath. Yes, 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 yes. That actually, that time when he won the election, na, that day I was in Visakhapatnam only. So this is more near to sand. So sand is given preference. Sand is given the preference. Same logic here also. No need to remember this. Why I have written 2 as MICI, not CIMI? Because if silt and clay is tying, then gravel and sand are more near to silt. Every logic is here. That is why I told you this chapter you need not to remember after this. Okay, because when silt and clay are tie, the silt is, the gravel and sand diameter is more near to silt. Clay is smallest. Okay, so name will be S. And since it is range of CU is greater than 6, CC is in the range of 1 to 3, so it will be SW. Have you got it? Have you got it? Have you got it? Enjoyed? These are the questions that you can do. This also. Do this also. So that, guys, combined prize I will be giving. This and one more was that person. That person is not here. There was some Sawat or something like this. Okay, so that person is not here. Okay, do this. Do this. Do this, guys. Come on, everyone. Just giving to. This is not a prize question now. This is not a prize question. This is not a prize question. Do it fast. Do it fast. Everybody, come on. D. Why different answers here? I taught same thing for everyone. Okay. So percentage finer than 4.75 mm is 60. So that means gravel is 40%. Gravel is 40% because 60% is going beyond that. Finer than this is finer than this will be fines. So fines will be 30%. Which case is this? Fines is 30%. So sand will be. Which case is this? Case 1 or 2? Which case is this? 1.3. Fines coarse is more. 40 and 30. 40 gravel, 30 sand. 70% more is coarse. So this will be case 1. And fines are 30%. That is more than 12%. Case 1.3. In case 1.3 the names are GC, GM, SC, SM. So either of the names will be GC, GM, SC, SM. So of course this cannot be there. This is no name. Now here the liquid limit is 35%. Plastic limit is 27%. What is IP? What is IP? 8%. And A line if I use, then IP is equal to 0.73 WL. What is this value? Please tell me on the comment box. 15 into 0.73. Please tell me on the comment box. Everyone, please tell me on the comment box. this is 20, this is 35, this is 50. Even these lines are not required because LIH is not here. LIH is not in the name. So this is, you are saying 10.95. So as per A line, it is 10.95 and our IP is less, 8%. So it is M. So it is M. And gravel is more or sand is more? Gravel. So it will be, sand is not more. So how it can be? GM. A option. Have you got it? Have you got it? So these are the upcoming sessions. Survey marathon will be midnight and survey marathon will be most effective because survey, there are certain things that are going to come in the examination most of the times. Workshop will be on 15th of January. Okay, let's move. Now, compaction, this is done, this is done. Now, coming to the chapter number 3, compaction of soil. I told you, the first chapter is bigger. Other revision will be quickly done. And yes, one more thing, that it is not always that bigger chapter requires more revision time. Sometimes a chapter is bigger, but it is only on the basis, on the pillars of 3 concepts. Then certain, that kind of big chapter is also revised very quickly. Okay? Ready for compaction? This is again even smaller chapter. This is again even smaller. Ready? Ready? Kiss share. I know one thing, that if I said share, then nobody, only 2-3 people are sharing. Like Tiksha is sharing, I have seen in my groups. Who have shared? Prince is also sharing. Yes, yes, yes. Okay. Okay, Prince. Okay, let's stop sharing now. Let's do this. Let's do this. Guys, whenever we provide energy and the volume is compacted, that is called as compressibility. And if that volume, this is water, if that volume is compacted by the reduction of air voids, it is called compaction. Guys, solid is not going to change. We assume that solid is constant. Okay, yeah, okay, Prashant. That solid is not changing. If volume reduction may be due to air and water only. So if air is removed, but after compaction, that is after applying load, air is removed, that is compaction. If water is removed, it is consolidation. For a partially saturated soil, if I apply load, first it compacts, first air voids are removed, and if the load is sufficient that all air voids are removed, it becomes saturated, then now the water will expelled out. That is called consolidation. So this is called consolidation. This is called consolidation. This all process from here to here is compaction. And for a partially saturated soil, always compaction happens first. Okay? Now, benefits of compaction, if volume is reduced, so density will be more, and density will be more, then shear strength will be more. Large settlement can be controlled. Guys, if you have already compacted the soil, that means you have already done the remove the voids. So now large settlement will not happen. If you are making a foundation for a building, first you should be compacting the soil. Because if you have not compacted the soil and you have applied the load, then it will compact later on, and might be the excessive settlement may be there. Load carrying capacity will increase because the shear strength is increased, and volume change will be controlled. Now, compaction is an instantaneous phenomena. Consolidation takes a lot of time, because consolidation, water will go out, and the speed of water is not like Usain Bolt. The speed of water is not like Usain Bolt. It moves slowly, so it will take time. Okay, compaction happens when there is air, that is partially saturated. Consolidation happens after removal of all air. That means that time it is in saturated state. Densification is due to reduction of the volume of air voids, and here the pore water is expelled out. Okay, specific compaction techniques are used, like for sand we use vibrations, and for clays we use static roller. Okay, and here it applies on the consolidation is happened on a static load. Okay, now for sand it is not important, so I am telling you very quickly here. Sand they will not be asking. If I apply a graph of gamma d and water content, then sand will be something like this. At 4 to 5% water content, gamma d will be minimum. Why? Because at 4 to 5% water content, what happens in a sand na? There happens a capillary suction, and sucking of a chain is like this. So voids are entrapped. Voids are entrapped here. So when voids are more, the gamma d is weight by volume. Gamma d is weight by volume. Volume will be more because there are voids. So gamma d will be less. And this effect of capillary happens maximum at 4 to 5%. Okay, now comes to the real topic, that is cohesive soil, that is asked in the examination. Everyone guys, now be alert. Here I am making gamma d, here I am making water content, and here the graph is like this. Graph is like this. Everyone now. Guys, here it becomes the maximum density. This is called OMC, optimum moisture water content. And this is gamma d maximum. This is gamma d maximum. What happens? That when we add water, when we add water here, actually you are adding a lubricant. So when you are adding a lubricant, when adding a water here, you are adding a lubricant. So that lubricant is reducing the friction between the particles. So when load is applied in such cases, so easily they can compact. Why easily they are compacting? Because the friction between the two solid particles is reduced by adding the water. Water act there as a lubricant. The friction is reducing it. Okay. Now, moving further, guys, commandos, champions, everyone. One stage comes OMC. And in OMC, what happens? After OMC, that water is so much. The water is so much that where the solid particles was about to move, and settle, already there is water. You have added so much amount of water, that already the voids are occupied by the water. So no space for solid particles to compact. Already there is water, and water will not be expelled out. Because it is not consolidation, it is compaction. So this region is called dry of optimum. Here generally we find flocculated structures. Clay, this is cohesive soil, na? Shape is flaky, something like this. And here it is wet of optimum. I am giving a perfect example for this. Wet it is dispersed structures like this. They are aligned parallelly. Guys, see, giving you an example. Have you seen atta, flour, wheat? Okay, you need the wheat to make chapatis. गूंदना, हम आटे को गूंदते हैं. We need the wheat to make chapatis. Now, when you add little amount of water, it cannot be compacted. No, density is not high that time. And when you add lot amount of water, then also it cannot be compacted with high density. It is compacted with a particular density. Have you got it? Everybody give me yes or no. Now on the comment section, everybody give me yes or no, please. Okay. Now, guys, there are certain things like compactive effort. Suppose I am making a graph of water content and gamma D at a particular energy level. At a particular energy level, E1, this is the graph. And if I apply more energy, graph will be like this. It is quite obvious. Let me explain you. This is OMC of 1 when energy 1 is applied, and this is OMC of 2. Of course, OMC 2 is less required than 1. Why the questions are, why this graph is above? Why this graph is above? This graph is above because energy is more. So when you apply more energy, you can compact more, na? So density will be more, na? That is why E2 is having more density, obviously. When you apply more energy, you are compacting it more. And when you are compacting it more, then gamma D will be more. Okay? Okay guys, gamma D will be more. And why OMC2 is less? Because when you have increased the energy, so less water is required to make it optimum. Actually, you are adding water to remove the friction. Now even less water will affect because now you are adding more amount of water. It has to settle anyhow. Give me yes or no in the comment box. Type of this compactive effort I have increased. Moisture content is this variation. This variation is the variation with the moisture content. Now type of soil. Obviously, a soil which is well graded will be having more density than poor graded. What is rocket science in this? Well graded have all range of particles, big, small, double XL, triple XL, large, small, everything. So voids will be filled. Density will be high. Poorly graded will be having more voids, so density will be less. Give me yes or no. Now zero error word line, very important. This, guys, now for 2-3 minutes listen to me. This is water content and this is gamma D. Okay, please listen to me. This is what when the energy is E1. Listen to me properly. This is when energy is E2. Okay. This is when energy is E3. Now listen to me. If I take a sample from here, and here, I am taking a sample from the 1, this is 2, this is 1, and this is 3. Very important. Please see. 1 has little bit of this solid, water and air. Now how 2 will look? Solid will be same. Why water content is same? Can anybody tell me? Why water content is same? Can anybody tell me? Why solid and water both I am making same? Why solid and water I am making same? Can anybody tell me? This is 1, 2, 3. Can anybody tell me? Because I have taken these samples from the same water content. Okay. So 1, 2, 3. Why the gamma of 3 is more? Now I hope you understood. Why gamma of 3 is more? I hope you understood. Because in 3 the voids, see, gamma D means weight of solid by volume. Gamma D means weight of solid by total volume. So total volume here is less. Why it is less? Because in 3 we have provided more energy. So more energy will be less air. So less air means less volume. Less volume means more gamma D. Have you got it? Yes. Now, guys, if some Rajnikant comes, okay, And after coming Rajnikant, he practically it is impossible to remove all air voids. Practically it is impossible to remove all air voids. But suppose Rajnikant comes and Rajnikant remove all air voids. So that graph will be, it is little bit inverted V shape. This fourth, and fourth is when Rajnikant Hanuman comes. Okay, and air voids will be 0 in that case. Air voids will be 0 in that case. That is the highest density, theoretically maximum density. And of course, at if I y-axis I am writing dry. So dry means when it is air. So guys, gamma D theoretically, this is very important formula. Only one formula in this chapter is G gamma W upon 1 plus E. So it is G gamma W 1 plus WG by S. This is G gamma W 1 plus WG. Now here comes the confusion to the students. Here comes the confusion to the students that sir, how you have taken S as 1? How S is 1? Sir, I am not getting this. For dry case, how S is 1? Sir, I am not getting this. Are you gone mad, sir? क्या था उस glass में जो आप पी रहे थे? What was in that glass that you are drinking? How S is 1 in gamma D? Can anybody tell me on the comment box? Now this is also the price question 3. Price question 3. Let me see who can do it fast. From all these questions, I'll be combinedly giving the answers. In these two cases, Anusha, you joined late, yaar. Anusha, you are from IIT Roorkee, na? Let me take the screenshot. No need to write the time. I have taken the screenshot. Yes. Guys, because here E, I am writing the star mark here. Here E and here E both are same, na? Same, na? Voids here and voids here both are same. So for here, if I can write the voids, this will be WG by S. So WG, S is 1 for here. So these two are having same void ratio. One is void is filled with water, one is filled with air. But void ratio is same. So if I am writing E here, that will be WG by S and S is 1. Because if gamma D I am writing for this case. So E I have to write of this case, but E of this and E of this both are same, and E of this is WG by S, S is 1. Have you got it now? Have you got it now? Have you got it now? Please tell me. Please tell me. Please tell me. Okay, this is called zero air void line. Air voids are nothing here. Zero air void. All air voids are removed. Okay. Now there are guys some Proctor test. Now what happens in Proctor test? Let me tell you. This is a sample. Suppose this is of 944 cc. Okay. We filled one layer of soil, and one layer of soil is filled, and from a 2.5 kg rammer, Hathoda, and from a free fall, not forcing it, free fall of 305 meter, 300.305 meter, we are compacting the soil. We are, let me check this data. We are compacting the soil. We are compacting the soil. 2.5 kg, 944. Yes, we are compacting it 25 times. 25 times. Then again making the second layer. 25 times again compacting it. Then again the third layer, compacting it 25 times. So what happens now in this Proctor test? That after compaction, we are drawing the chart. At this much water content, after compacting 25, 25, 25, what is the density we got? At this water content, what is the density we got after compacting 75 times? Then we make this graph. For every water content we compact 75 times, put a value here. Every water content, put a value here. Okay. So what is if they ask, this is asked in gate, 2-3 times this is asked in gate. Energy per unit volume. They have asked it 2-3 times. So energy is mgh. So 2.5 into 9.81, H is 0.305. Energy per unit volume 944 in proper units. Convert in proper units. mgh, and this mgh is 75 times. 75 times. So this comes here 594.29 kilojoule per meter cube. Okay, similarly in modified Proctor test, this comes 2696. Same process, I am not doing calculation again and again, per meter cube. In same all calculations, here it comes 593.014. Please check the data. This data you have to unfortunately remember for the GATE exam because it is asked 2-3 times. And here it comes 2703.88. Indian Standard, modified Proctor. After modified Proctor, it was Indian Standard. And after Indian Standard light, it should be Indian Standard heavy. Okay, correct. 2703.88 kilojoule per meter cube. Okay, 5 layers. Yes, it should be 5 layers. 5 layers. Okay. Okay. Now tell me this question fast. Tell me this question fast. Tell me. Okay, it should be compaction. Y-axis we are measuring the gamma d, na? So these are the properties of dry optimum, wet optimum. You can not, GATE will not be asking these theoretical questions, but other exams can ask this. Okay, what soil? What is the type of equipment? Just remember, for sand we should be using vibratory, and for clay we generally use the static pneumatic ripe rollers. Okay. Now 1 chapter done, 2 chapter done, 3rd chapter done. The 4th chapter, effective stress and permeability, very important chapter for the whole soil mechanics. Very important chapter for the whole soil mechanics. Ready? Chapter number 4. Ready? No saying, nothing saying, students. Students saying nothing. How many of you have taken the lunch? How many of you have taken the lunch? No, I am not giving break right now. If it is required, I will give later on. If it is required. If it is required. Okay. Okay, so after some time I'll give you a little bit 20-25 minutes break, huh? Okay, so let's study. Okay, Shamshad Ahmed is also here. Shamshad, have you started from beginning enjoying this marathon or not? My dear student. ओके भाई, मेरे घर में कोई नहीं है ना खाना बनाने के लिए, मेरे को आता भी नहीं है, तो ऐसे मैं बीच में खाऊंगा तो बुरा मत मानना. ओके, लेट्स स्टडी. चलो, in effective chapter na we'll be dealing with sigma. We will be dealing with sigma. I will make sigma with white color. Then we will be dealing with pore water pressure. Very important chapter. Then we will be dealing with sigma bar. What is sigma? What is U? What is sigma bar? I'll be telling you. Struggle life, I get you also not believe me. Okay, but even I don't know how to order from Swiggy and Zomato. I don't know how many of you will believe me or not. Samshad, any improvement required? Speed and everything is fine? Samshad, anything improvement, speed, everything is fine? So you will not believe me that I don't know how to order from Swiggy and Zomato, because I am very poor with technology. My WhatsApp DP is same from the day when I joined WhatsApp, because I don't know how to join it. Couple of days back I know that how to put the YouTube link on the WhatsApp status, and Facebook DP is also mine same from last many years. Instagram, LinkedIn I have uploaded 2-3 years back but never opened again. I forgot the password. Okay, so many my colleagues knows, my all faculties they know that I don't know how to. This Richa ma'am, Joshi sir, Rakesh sir, everybody knows that I don't know all these things. So many times I said that I slept, because from 7 to 8 days there is no one in my home. So every time I said that, sir, yesterday I was very tired, so this is not done, this is not, so they always said that, why don't you tell us, we will put orders. Okay guys, please like the session, yaar, please, everybody who has not liked till now. Gautam, will you provide PDF? I always provide the PDF. Okay, let's begin. So guys, what is the stress? It is the same stress as in strength of materials, force by area. Suppose area of cross section here, this area is A total. Actually this A total is formed from area of contacts plus area of voids. See, this total area is A. So these are the area of contacts, This is area of contact. And the remainings are area of voids. Of course, the contact will be at very small portion. Contact will be a very small portion. So actually 97 to 98% of total area is occupied by area of voids only. Area of contact is negligible. Area of contact is negligible. So stress at x-axis is force by area. So one is this F force acting, and one is this total weight of soil. One is this total weight of soil. One is this total weight of soil upon A total. Simple, total stress. Now if I want to make it here in the soil, so this is, suppose I have a dry soil here, and here suppose it is water table. So here it is gamma saturated soil. Suppose I want to find out the stress at B point. So once is F plus this soil weight. Stress is force by area, na? Stress is force by area, na? So what is this force? Weight of this dry soil, gamma D. Suppose area is A. So A into H1. What is the weight of this soil? Gamma sat into volume. Volume is A into S2 upon total area. So sigma B stress, the total stress at B point is F by A plus gamma D H1 plus gamma sat S2. Okay, so now this is the last time I have written like this. From now on I will be directly writing as gamma dh1 plus gamma sat S2 and like this. I will not multiplying by A, dividing by A, I will not be doing like this. Okay, now this is important. Now this is gamma D, this is water table, this is water table, this is B and C point. Suppose B is at alpha distance and C is suppose at beta distance. Okay, now what is pore water pressure? That is U. The pore water pressure is the small u. The pore water pressure is the pressure inside. The pore water pressure is the pressure inside the pores. Now suppose it is a hydrostatic condition. There is no movement of water. In hydrostatic condition, the pressure at alpha distance below, the pressure at h distance below is gamma WH. So pressure at alpha distance below will be gamma W alpha. So B and B are at the same location. So pressure at this point B and this B dash, Pressure at B dash should be also gamma W alpha. So making pressure gamma W alpha, water will rise this much alpha. So what is pressure in hydrostatic case? What is the pressure at beta distance below? Beta distance below, pressure will be gamma W beta. So this C dash is also at the same location. So for making the pressure gamma W beta at C dash, water will rise beta. Now guys, pore water pressure, very important guys for the whole soil mechanics. The pore water pressure is the pressure inside the pores, and the pore water pressure at B is written as gamma W into the rise of water in piezometer. Guys, just wait, many things I have to tell you here. Rise of water in, these are the piezometers. Piezometer at B. So UB is gamma, what is the rise of water? Alpha. UC is gamma W into rise of water is beta. Now you will say, sir, why you have written like this, yeah? Now you will say, so why you have written like this? Just write na simple gamma W into alpha. Let's write some gamma W into beta. Why you written like this? Because this is easy. For hydrostatic case, when there is a movement of water, there is seepage, then the pressure may be here like this much also. And if I have not told you this statement, then always you are writing the B at B, the pressure is gamma W alpha, at C, the pressure is gamma W beta. But it is not only the possible in hydrostatic case, when the water is movement, the head can be different. Even in this case, the height can be something, suppose gamma, suppose delta. In that case, the pressure at B, you again will write gamma W alpha, but it should be gamma W into the rise of water. In rise of water, I suppose this is delta. In that case, the pressure at B should be gamma W into delta. Have you got this, everybody? Have you got this, everybody? Just kidding. Just kidding. धीरे समझाऊं? Should I explain you slow? Guys, many of you will say that why this teacher becomes hero? Why this teacher becomes hero by writing all these things? We know at B the pressure is gamma W alpha, at C the pressure is gamma W beta. Why this has become hero in this? Because if it is not hydrostatic case, it is something different, then the pressure will be gamma W into, actual formula is this, rise of water in piezometer. So it is not always that it will be rising this much, it can rise this much also. Okay? Okay? Now, actually formula is this. For hydrostatic case, yes, you can apply normal formula. For hydrostatic case, yes, you can apply normal formula. Now guys, there is a piece, there are three types of total head means energy. Total head is total head is datum head plus pressure head. I am writing in PRE, so I will tell you, plus velocity head. Now always, I will break this smartboard if you forget this. Always pressure head is zero in soil mechanics. Always pressure head is zero in soil mechanics or foundation. If water is static, then velocity is obviously zero. If water is static, then velocity is obviously zero. But if water is moving, in that case the movement of water is very, very slow in soil. The permeability of soil is in the range of 10 to the power minus 5. The permeability of soil is in the range of 10 to the power minus 5, 10 to the power minus 6, in that range. So, if water is moving very slow also, then the velocity head is assumed to be taken as zero. Velocity head is always zero. Static case zero, movement case also zero, because in movement case also it is not like moving like Usain Bolt, very, very slow. Okay. Now, datum head plus pressure head is called as piezometer head. That is why I have written a PRES. Otherwise, you will confuse. This is piezometer head. In soil mechanics, since velocity head is equal to 0, therefore total head is equal to piezometer head in soil mechanics. And piezometer head is datum plus pressure. Now, many times I ask my students, what is the piezometer head at sea? They say, sir, piezometer head at sea is beta. Wrong. Piezometer head at sea is not equal to beta. Piezometer head is pressure plus datum. So pressure head, the rise of water is actually pressure head. The rise of water in piezometer is pressure head at B point. This is P means pressure. Pressure head at B point. Yes, if you take datum here at C only, okay, then datum will be 0 and pressure head will be beta, then you can say. But suppose you take this as datum. So from datum, this height is suppose ZC. So piezometer head at C is datum head, that is ZC plus pressure head, that is B. ZC plus beta. Piezometer head at B point is not this. This is the pressure head. Yeah, the rise of water is pressure head. Piezometer head is datum head. So datum is ZB plus pressure head. ZB plus alpha. ZB plus alpha. Everybody, please put a heart sign on the comment box if you got it. If you not got it, please, my request, this marathon will be only successful if your doubts are cleared. My request, please put your doubt. Either put a heart section on the comment box. Heart section will signify that you have understood. Otherwise, please put a doubt. Alekia is putting a black head. Alekia, black head means because I'm dark, that's why. Because I'm dark, that's why. No, sir, I believe pure love. Okay, oh my god. Pure love is black. Pure love is black. Okay. I understand your concept. Yeah, my favorite is also black. Okay. Now, let's come here. Everybody. Suppose I take these 3 layers and making free body diagram here. So one is the F here. Of course, from bottom, there will be the contact force, that is suppose N, and if there is water, then water force also, capital U. Guys, contact force in these 3 layers from bottom will be top. I am applying 80 kg downward to the floor. I am applying 80 kg downward to the floor. Floor is applying 80 kg upward. If I make the free body diagram of this 4th layer, then contact force of these 3 or contact force of this layer on the 4th layer will be bottom. But contact force on 3rd layer by 4th layer it will be upward. Now water pressure will be everywhere, yaar. Water pressure is not in vertical direction. Water pressure is everywhere. Okay, so if I am this weight is W. The weight of these solid particles of these 3 layers is W. Okay. Now water pressure is everywhere in every direction, yaar. So on the 3rd layer this will be upward. Water pressure is everywhere. See, yaar, in this water pressure in this wall will be here. In this surface it will be here. But in this surface it will be here. Okay. Now, since the soil is in equilibrium, it is not going to Khandala, it is equilibrium. So F, downward force weight W is equal to upward N plus U. No, These are force. This is force. This is force. U is the pressure. U is the pressure. So U into area. And it is acting on voids. U into area voids. Okay, now dividing by area. Toing, 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 toing. F plus W by A is sigma. N by A, contact force. Contact force by area is effective stress. Area void is 97 to 98% of A. Area void is 97 to 98% of A. So area void by A can be written as 1 only. It is U. So the derivation that you are learning like anything, is actually now derived by the super duper teacher Abhinav Negi. Sigma bar is sigma minus U. Now what is the use of this derivation? Now you can feel that what actually is effective stress. You have felt total stress, you have felt pore water pressure stress, but what actually is effective stress? It is the contact force. It represents contact force, not exactly, but it represents contact force between the particles. And now my champions, please tell me, effective stress should be more is good for all. Effective stress bigger is good for us, or effective stress of smaller magnitude is good for us? Effective stress is bigger. It is good or bad? If effective stress is more, it is good. If effective stress is less, it is bad. We want that effective stress. We want that effective stress between the particles should be more. Because if they are more effective, they are loving each other. They will not slide. They will not shear failure. If they are loving each other, nobody others will make them slide. Nobody others will make them slide. It will not love. They will not go here and there. Loving each other only. Effective stress less means less contact force between the particles. Less contact force. It can slide. Okay. That is why we make weep holes in retaining walls. In mountain areas, you have seen weep holes like this. So that in rainy seasons, what happens? Why landslides are more? In rainy season, U increases because water table increases, pore water pressure increases, gamma WH. So this will decrease. Means failure. That is why we make weak holes so that it can go out. Okay. Now if this is the case, what is the total stress? This is gamma D. What is the total stress? Gamma D into H. What is pore water pressure? 0. What is the effective stress? Sigma minus U. This minus U is effective stress. So U is nothing. So it is gamma DH. Got it? Now suppose water comes here. So what is U? Gamma WH. Of course, if water is there, so it will be gamma saturated. It is gamma saturated H. Okay, sigma minus U is equal to sigma bar. Gamma sat minus gamma W. It will be gamma submerged into H. Toy. Okay, now this is the ground level and water goes beyond. It becomes rainy season, like in Odisha. It becomes rainy season. Baad aa gayi. This is the same H depth, but water goes beyond above that. This is water, not soil. Ground level is here. Now here if I make the total stress, this is gamma W, stress of water, and here this is gamma W H1 plus gamma sat H. Now U, gamma W into H1, gamma W into H plus H1, sigma bar, this will be 0. Gamma WH1 minus this. H1 H1 cancel. Gamma submerged H. From here we got an important thing, that when water was at the ground level, water is at the ground, effective stress for gamma submerged H at the bottom. When even the water goes above this, effective stress is still gamma submerged H. Here also gamma submerged, here also gamma submerged. The reason being, when water increases above ground level, the increase in sigma and increase in U is both due to water. Both due to water. Sigma is also due to water, not soil, and this is also. So answer is same. Have you got it on the comment box? Please let me know. Please let me know. So water table is here. And now some loading is coming. Some Phulan Devi sitting on the ground. This is water table. Phulan Devi is sitting on the ground with Q stress. Phulan Devi is sitting on the ground with Q stress. Okay. This is Q. This is sigma. This is Q. Stress. Q तो आएगा, हर जगह Q increase कर दो. हर जगह increase the Q. Q plus since water is there, so it will be gamma sat. Q plus gamma sat into H. U will be after long time. Why after long time? Tell you later. This is gamma WH. Long time. Why I am telling after long time? I will tell you later. Sigma bar is Q, and here Q plus gamma submerged H. Have you got it? Have you got it? Have you got it? Eating too much of water na. Eating water, drinking food. Please put a heart sign on the comment section, and guys, please like the session. Like the session if you have not liked till now. Like the session, make it 200 yaar. Make it 200 yaar. Okay. Now here is the thing that I want to tell you all. Tell me, this is P point. This is P point. Initially, very important concept. What is sigma? Of course, this is water, so it will be gamma sat into H, gamma W into H, minus करेंगे तो gamma submerged H. Now what will happen? What has happened? I have applied surcharge just after case, just after load is applied, just after load is applied, what will happen? See, very important concept. Once you apply the load na, in a saturated soil mass, all load is taken by water. Earlier the water is having how much stress? Gamma WH. Now what will happen? All this is now not hydrostatic case. This is not hydrostatic case now. All load is taken by water. All load is taken by water. So here, see, water's home is hydrostatic. Water's home is hydrostatic. If nothing is there, it will be in hydrostatic condition. But now this U excess is come. This is U excess. Excess pore water pressure. This is hydrostatic pressure. What? Oh, in a saturated soil mass. In a saturated soil mass, all load is taken by the water. All load is taken by the water, and this much from here to here, this much from here to here is excess pore water pressure, and whatever load you have applied, that much excess pore water pressure will be coming. Whatever load you have applied, that much extra pore water pressure is coming. So now just after the loading, so load becomes at this P point, Q plus gamma sat H, and pore water pressure becomes gamma WH plus Q. Extra pore water pressure is coming, and subtract, it will be same. That means when we apply the load, there is no change in effective stress. Just after application of load. There is no change. Just after application of load, there is no change. Now I am making of long time after. Now I am making a diagram of long time after. Guys, now listen to me. Nobody wants to be in high pressure. Everybody in this universe wants to be in less pressure. So this is the extra pore water pressure. It will start dissipating. It will go out, guys, because nobody wants to be in high pressure. Everybody wants to be in less pressure. So this water will dissipating out. And once it reaches its home, now it's fine, happy. And water's happiness is in hydrostatic pressure. Water's home is hydrostatic. Once dissipating, extra water less. Now it becomes very happy. Okay. So here, my friends, this is Q plus gamma sat H. Water pressure is gamma WH. It becomes hydrostatic. Q plus gamma submerged. So long time after happens this case. Everybody on the comment section, please put a heart sign if you got this concept correct. Everybody. I think my neighbors will come and complain me about me in my society. Neighbors will come and complain about me in society. I guess then now you will save me. Okay, just tell me. Just tell me. Why? Because I'm shouting like anything, na? In office studio, in the walls, there is that sound acoustic, but there's sound absorber. But here in my home, there is nothing in the walls, na? That is the reason. Okay, capillary means the water comes above due to the difference of cohesion and adhesion. And here in capillary, what will happen, na? What will happen? Only one thing you have to understood. That if this is ground level, okay, and this is the water table, okay, and this is like this. Suppose this is 1 meter, suppose this is 2 meter, suppose this is 3 meter, suppose gamma sat here is 20, suppose gamma W not mentioned in the question, you have to take 9.81. Suppose here given a 10, gamma D is 15, and it is given as 1 meter capillary. 1 meter capillary. So this is 1. Now it is asked to make the sigma U and sigma bar diagram. Can you do this? If you do this, please tell me the value of sigma bar. If you can do this. Now sigma, if I make, so 15 into 1 is 15. Then now it becomes saturated because water is there. So saturated is 20. 20 into 1 is 20, 35. Then 20 into 3, 60 more. 95. Got it? Got it? Now Arun, here it is 0 and after below 3 meter it will be 30. 0, 3 meter below 30, gamma W is 10 and 1 meter above it is minus and 1 meter above it is minus 10. If it is 1.5, 10 into minus 1.5. It is 1.7, 10 into minus 1.7, like this. Sigma bar. Why minus? Because let me explain you logically. If here the water pressure is 0 and water is going from 0 to above. Water is going from 0 to above. Water goes from high pressure to low pressure. And from 0 level, if it is going somewhere, so 0 is high for it because water goes from high to low. That means 0 is high for it. Is going from 0 to low. Oh my God. 0 to low. Water goes from high to low, no? So what is going here? That means 0 is high. Water goes from high to low. Water going above. So from here it is going. That is 0. So 0 to, that means it is low. That is why it is minus. Now 0. 15 minus 0 is 15. Just above this layer. No water pressure. So 15 minus 0. Just below this layer. 15 minus minus 10. Why 5? 15 just below this layer. 15 minus minus 10. 25. Then 35 minus 0 is 35. Then 95 minus 30 is 65. Everybody give me yes or no. And please tell me, capillarity is good or capillarity is bad? Enjoying the session or not? Enjoying my session or not? Please let me know. Please let me know. Capillary is good because sigma bar is sigma minus minus u. It is increasing. These two sessions I'll be coming in next 3-4 days. Guys, please do. Are you coming in the survey midnight marathon in Moon? Okay, Geotechnical tonight 11:55 p.m. tonight. Okay, then this 100 questions on Monday and this will be tomorrow Sunday by Joshi sir and Chandrasekhar sir. Complete FM. Workshop will be on 15 January. The super duper workshop by the super duper person Abhinav Negi. Okay. Telegram here you can join me in civil by Abhinav sir. This is complete. More than 50% is complete. This is complete. Now comes to the permeability chapter number 5. See, chapter number 1 takes more time than 2 plus 3 plus 4. Is it right or not? 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 How many bars in serving? It will be less than soam and soil, around 50%. Around 50%. Got it? Okay. 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 Now tell me up to here. Tell me up to here. Is it up to your expectation? The marathon till now? Or you want little bit more? Or you want little bit more? Kya more? I'm saying that you have some expectation from the Geotech marathon, na? Was it same? Was it was more than your expectation? Have you enjoyed more than your expectation? Or it was not that much good? Sayam, I don't know, na? I'm not computer that this much, it will take this much time. You can, in between, you can check. Otherwise, give me your phone number. When foundation will be coming, I will give you a call 5 minutes before. Give me your phone number, I will call you 5 minutes before. Shall we start? Or anything you want to discuss? Or anything you want to discuss? Prize question, how many prize questions have been done? First question nobody has given the answer, then that Shastri Khawat, Prakash Srivastav, and then I have written the names. है ना? And one time I have written the names and one time I have taken the screenshot. Correct na? Correct na? Correct na? कितने घंटे हो गए? अभी तो कुछ only 4.5 hours यार. What will happen in 4.5 hours? In offline I was to teach 13 hours sometimes. And every day 6 hours तो होता ही था. Price struggle life वाला Anbu was a person that has come yesterday in the chat also, na? He got the prize same day. And the announcement of the prize is done in the midnight session, 11:55 PM, after analyzing all the questions results. Okay? Okay? Okay, let's begin. Now, guys, suppose this is a soil and water here is this much and water here is this much. Now I am telling you a beautiful thing here. All of you, I am telling you a beautiful thing here. This is 0.1, this is 0.2, this is 0.3, this is 0.4, this is 0.5, this is 0.6. Let us play the match between these points. You will enjoy like anything. You'll enjoy it like anything. Suppose this is a datum. This is datum. This is datum. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Guys, what is the velocity head? What is the velocity head? Pressure head, velocity head, pressure head, datum head, and this is total head. What is the velocity head? In soil mechanics, even if it is rest or it is moving, it will be 0. Guys, I am doing all these kind of rubbish things na, just to make me energetic. Otherwise, it will be very boring class. Either you will sleep or I will not even sleep. Not that much boring. Okay. So pressure head at 1.0, taking it only, not atmospheric pressure, only gauge pressure 1. At 2 point, the pressure is H1 height. 2 and 3 are at same height, so pressure is H1. 6 is 0, then here H2, and 4 and 5 are at the same height, H2. Now my question is that 2 and 3 you are saying same height. Now the price question here. Top 5 names I will be writing. 2, 3 you are saying the height is same, so you are saying pressure is same. 4 and 5 you are saying that at the same level pressure is same. Then 3 and 4 are also at the same level, na? 3 and 4 are also at the same level. So why pressure is not same? Why H1 and H2? Why H1 and H2? Why H1 and H2? Alekia, no. Okay, I have taken the 5 names. After, other than Alekia, I guess all are correct. Guys, head, I have taken a screenshot. Guys, the head is same. The head is same, or the pressure is same when to both these points we can go from same medium. It is not like in fluid mechanics that at same level pressure is same. No. Same level pressure is same if between those 2 points I can go from a same medium. If from a same medium I can go between these 2 points, here it is water only, same medium. So 2 and 3 pressure is same. 4 and 5 the same medium, water, pressure is same. But from 2, 3 to 4 there is a different medium, so pressure is not same. Even if the wire is or some pipe is connected na, and here is water, then also pressure is same. If between these 2 points I can go through same medium, if between those 2 points I can go through same medium, then also the pressure is same. Okay, now datum head 2, 3, 4, 5 0, 0, 0. 2, 3, 4, 5 0, 0, 0. 1 is H1 and 6 is H2. So what is the pressure? 0 plus 0 plus 0. What is the total pressure? Guys, कुछ फ्लिकरिंग हुआ था क्या अभी? H1 अभी कुछ फ्लिकरिंग हुआ था क्या? S2 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 S2. Guys, in between if it flickers na, please let me know. Do you know why? If you are very old, not very old, if you are seeing me from last 2 months, in between sometimes my smart board was not working properly and I write in a table and from HDMI cable it is written back. Do you know that? Yes, Vidya. Do you know that? I write on the table and it was in the back written. But that we have corrected it now, but in between sometimes it flickers. So now they have updated another chip, so it flickers in between. Please let me know. That is why also I am using this, taking this class from home. So in a long marathon we'll get to know that if it is flickering or not. Okay, so energy in 1 to 3 point is same, that is H1 total energy, then decreasing, then again the pressure is same, S2. This is total energy line, and this is the head loss, H1 minus H2. So guys, only loss occurs in soil. See, 1, 2, 3 same energy, H1. See, water total energy line is not decreasing. 4, 5, 6 same energy, S2. So all losses occurs here. Okay, now guys, it is very obvious that if energy is decreasing, water will move, because everything in this universe wants to go from high energy to low energy. and the velocity of water is proportional to hydraulic gradient. What is hydraulic gradient? H by L. Head loss by L, that is H1 minus H2 by L. Okay, and this proportional sign is removed by K. K is the hydraulic conductivity or permeability. Who is giving you salary? I am not getting. Shweta, Vinayak Mission, who are you? Yeah, Georgie. V is proportional to I. So I is HL by L and this is removed by K. K is coefficient of permeability or hydraulic conductivity. Okay. Now, guess this is discharge velocity. I am not going into the derivation, but this is discharge velocity. Okay, there is a true asli velocity, true velocity. V dash is true velocity. That is seepage velocity, the real velocity. Seepage velocity. So V dash is V by N. N is porosity. Since N is less than 1, so V dash is greater than V. What is the difference between discharge velocity? What is the difference between discharge velocity and seepage velocity? In discharge velocity, you have done Q by A. Discharge by total area. But in actually the seepage velocity, true velocity, is discharged by area of voids only. Area of voids only, because the water is going not from the total area. Water is not going from the total area. Water is going from voids. Okay. So I am not going into the derivation of this. V dash is V by N. Okay, like this question. Can you please do this? This is a previous year question. Water is 55.2 and 34.1 and distance, the inclined distance between them is 2500. I'm just going 5 in 2 minutes, filling my water bottles. Okay. Okay, so guys, time is equal to distance by speed. Okay, so distance is 2500 meter between those 2 points, and of course the seepage, true velocity will be writing na, asli velocity, true velocity. What is V? V is Ki. What is I? HL by L. What is HL? Here the head is 55.2 and there it is 34.1 and L is 2500. K value is given. K is this. So from here we can find V. Now V dash is V by N. Porosity is 0.25. From here you can find V dash, putting it here and you get the answer 925.65. Okay. Now what is the equivalent permeability in parallel? This one, K1H1 plus K2S2 plus so on upon h1 plus h2. But let me first complete. In perpendicular, what is K equivalent? Now h1 plus h2 by h3 upon h1 k1 plus h2 by k2 plus so on. Now K equivalent of this also represented as sometimes K equivalent parallel, and this represented as K equivalent perpendicular. Of course, K equivalent parallel is greater than K equivalent perpendicular. Many of you have studied this, but why? Why? Because this represents the arithmetic mean. K1 plus K1 plus K1 plus K1 plus K2 plus K2 plus K2. This number of times. Arithmetic mean. This represents the harmonic mean. So arithmetic mean is greater than equal to harmonic mean. But guys, I don't know why you are studying like this. Tell me, this is parallel or perpendicular? Permeability is K1 H1. This is K2, thickness is H2. This is parallel or perpendicular? Tell me on the comment box. Tell me on the comment box. Tell me on the comment box. Parallel, Prince is saying. Prince is saying parallel. Prince is saying parallel. Oh, Girish, good. Good, Girish. Guys, that depends. If this is flowing here, water is flowing here, it is parallel. If water is flowing here, it is perpendicular. You are not getting the basic concepts. Yeah, Ashish Sharma is also there that time. You are not knowing the basic concepts. The basic concepts are, for being parallel, HL is same. This is the basic concept for every layer, for each layer. That means from here to here, if the HL is 3, suppose 3.2 any value, from here is also 3.2, from here it is also 3.2. That is why the loss is in this direction. That is why water is moving here. Otherwise, if loss is in this direction also, water start moving here also. The condition for parallel is the head loss through each layer is same. Although these all heads are same, here all these points are head same. If all these points and all these points head are not same, water is also moving vertically downward. Here the concept of perpendicular means discharge is equal to same. Discharge from here, discharge is from here, discharge is from here, same. This is the thing here, not like parallel formula is this, perpendicular formula is this. What you will do for this formula? Have you got? Have you got the concept? Please like the session and share it, guys. Come on. 199 likes. Make it 220 right now. But might be most of the students have already liked it. Nah? Okay. Okay. So permeability is a Aslan formula also. C D effective. What is average dia? What is average dia? Mean dia is D50, below which 50% particles are finer. What is effective dia? D10. Gamma W is density of water. Mu is viscosity, E cube upon 1 plus E. The various values of permeability for different layers. Okay. Now these questions will do in night. 11:55 PM also will begin. Now there is this field test is you have done in hydrology. You will do in hydrology. Okay, that aquifer things is actually in the gate, and it will be in hydrology syllabus. I'll discuss with madam also. Okay, capillary head permeability test, there is an empirical formula, and these are also empiricals. Okay, so should I write these? I will give all these are empirical formulas here. I will give this in notes. This is also empirical formula. For here, what is happening now? Constant head permeability test is done for coarse grain soil. So here is water, head is maintained constant. Okay, here water is going here. So here the water rises up to this point. Here the water rises up to this point. This is A, this is B, and the distance between them is suppose L. This is given here L. Q is equal to KIA, velocity into area. So discharge obtained here is K. I is H head loss, and H head loss in how much length? L length in A. So K is QL by H into A. K is Q into L by H into A. Guys, I am again repeating, all chapters, all topics will be done today. All chapters, all topics will be done today. Okay, and questions will be also done. Those questions which are important to make concept understood. Yes, some high profile questions will be done in the midnight session. Variable head. Okay, so here at T is equal to 0. At T is equal to 0, water is here, then coming here, going here, going here, going here, going here. Okay, and suppose at T is equal to 0, it is at H1 height, and T is equal to T naught, it is at H2 height. Initially it was at H1 height, and after T naught time it is at H2 height. So I'm not going into the derivation, otherwise equating the volume, we can find the derivation also. But instead of going derivation, I'm just writing the formula for you. Everyone, every commando, every champion. It is K is equal to ln base E H1 by H2 into small a, that is area of this standpipe, into L, that is the length of the sample, upon capital A into T naught. Capital A is the area of this, and T naught is the time when water moves from H1 to H2. Okay, from here there is also one more important relation, that if in the same soil sample water moves from H1 to S2 in T naught time and S2 to S3 again in T naught time, then if you equate these two equations two times, ln H1 by S2 AL upon A2 naught is equal to ln S2 by S3. So this same sample, so all these will be cancelled. We get S2 square is equal to H1 S3. Okay. Now give me yes or no. 1, 2, 3, 4, 5. Now coming to the 6th chapter, that is seepage. Then after this, vertical stress will be very small chapter. Okay. Have you got it? Now guys, more than 40-45% is completed. I guess even more. I guess even more. More than 50% is completed. Okay, ready for the seepage? Ready for the seepage? Everyone? Everyone? वीडियो को शेयर कर दो यार. वीडियो को शेयर कर दो यार. Okay. Now, guys, please see what is quicksand condition. Everyone, please. Let me just elaborate it a bit because it is important. See, after this you want break? After this chapter you want break? Please tell me. If you want, I can give. After this chapter you want break? Nobody is replying. No. What about others? Yes. No. Yes. Yes. Okay. So after this chapter we'll give. Okay, थोड़ा सा दे देंगे. After this chapter we'll give. Okay? Okay? After this chapter I will give you break. Okay ना? अब गुस्सा मत हो, चलो. सर को तो रेस्ट नहीं चाहिए यार. Sir has so much energy यार. That too without food. That too without food. और पता है, मतलब मैं इससे एकदम एग्री कर रहा हूं. मेरे को कोई इससे दिक्कत नहीं है. मैं मतलब बहुत सारे को मैं जानता हूँ जो खाना खा के वो काम नहीं कर पाते. मैं टीचर की बात नहीं कर रहा हूँ, किसी की भी, है ना. पर मेरे साथ उल्टा है. इट इज रिवर्स विद मी. विद फूड ना आई कांट टीच. When I was in offline, every day we teach 6 hours continuous to a batch and a 30 minutes break in between. Even 13 hours also someday. है ना. I don't eat in between the class. Okay, little bit this snacks I can take, namkeen and all this and fruity or other things, but I can't eat. Because once I eat food, I don't know why my energy decreases. And there is a very logical reason behind that. The reason is that, guys, what happens now that when you eat the food is here, various blood is going here for the digestion process, cells, whatever these things. That whole blood is here in the digestion process. Okay, less blood is circulating in the head, and then you feel sleepy, you feel little bit tired. Okay, you know I am in this much energy. See, from my home also the messages are coming. Have you eat the food or not? Have you eat the food or not? Should we order? These are the messages coming in the WhatsApp. है ना? So I can't eat in between, because once I eat the food, my energy will be decreased. And once I'm hungry na, that hunger gives me energy. And I totally believe that there are certain other peoples also I've seen which are different. I totally respect them. Everybody has its own body. My body does not require food at the time of teaching at all. That will actually not decrease my energy for taking the class. I don't know why. Okay, but I will give you a break. I will give you a break, yaar. I will give you a break. Because you are not the same person. You require food. Okay, and yes, I don't require food, but yes, a little bit rest is fine for me. Okay, let's start. Now guys, see, now I'm just making it little bit detailed, this quicksand condition. See, sigma bar is sigma minus u. This is always valid. Always valid. Okay, but this chapter case I'm going a little bit detailed. But pore water should be actual pore water pressure, whether hydrostatic or not hydrostatic, or not hydrostatic. Okay, this is valid. You should be writing pore water pressure should be the actual pore water pressure, whether it is hydrostatic or not. This formula is valid. This formula is valid if you write the actual pore water pressure. Now, here the sigma bar net in terms of seepage is sigma bar old. That means when there is, or assuming the case to be hydrostatic, plus minus HL into gamma W. This is at the time of seepage. And actually it is every time. If there is no seepage, the HL will be 0. If there is no seepage, HL will be 0. If there is no seepage, HL will be 0. Plus for downward seepage and minus for upward seepage. Guys, if obviously there is a contact force between me and the floor, if somebody is pushing me downward seepage, then contact force will be more. Between me and floor. So contact force will be more, sigma bar will be more. Plus, if somebody is pulling me like this, so contact force will be less, so it is minus. Okay, now Suppose it is seepage occurring here. Now students ask me, because I use the same diagram now. So from offline last 10 years, 11 years, students are asking me that, sir, what is the difference between seepage and permeability? Because I am using the same diagram. Guys, I say permeability is the speed, representing the speed. It is not exactly speed, because V is not equal to K. V dash is also not equal to K. V is Ki. So permeability is not speed. Permeability represents the more permeability, more speed. But actually permeability is not speed. V is not equal to K. V is equal to Ki. And this speed is represented by permeability and volume of water is represented by seepage. Okay. So the seepage pressure PS is equal to HL into gamma W. Seepage force capital PS is HL gamma W into A. Seepage force per unit volume, suppose area is A and L length is L. So HL gamma W into A upon A into L. So seepage force per unit volume, A to A is cancelled, HL by L is I gamma W is seepage force per unit volume. Now this is the seepage. Now guys, sigma quicksand condition or floating condition, okay, or piping failure. This is when sigma bar net becomes zero. Zero means that Budhav, where that Budhav goes. See, we reached to 217 slide. See how much I have to do this here. This much we have studied. This is quicksand condition. Let me make it copy here. Copy. Paste. This is quicksand condition. Here the particles are not in contact with each other. Here the particles is not in contact with each other. This is quicksand condition. Okay. Now quicksand condition, sigma bar net 0, no contact, no, it is not able to resist the load, this person will be drowned. Okay, so in downward seepage it is fine here, it is plus, so why it will be 0? In upward seepage there are chances of 0. Suppose this is a soil mass, and in this soil mass, suppose the length is Z and upward seepage. So upward seepage may be 0 because in downward it is plus. So here the sigma bar net is equal to, in seepage ke sigma bar old minus HL into gamma W. Old means hydrostatic condition. It was gamma submerged into Z minus HL gamma W, and quicksand condition means this becomes 0. Quicksand condition. So Z2 okay. So from here gamma submerged Z, HL can be written as I is HL by L. So HL is IC into L. Guys, this IC is critical gradient, floating gradient, piping gradient, when it will be making 0. Okay, HL I am writing as IC into length. So IC is gamma submerged by gamma W. Gamma submerged I told you G minus 1 upon 1 plus E. G minus 1 upon 1 plus E into gamma W. Divided by gamma W is this. And if I put E as N upon 1 minus N, this will be G minus 1 plus N into 1 minus N. This is critical gradient, quicksand condition gradient. Why this is quicksand failure, not clay? Because in clay, even if sigma bar is 0, In quick clay, even if sigma bar is 0, in quick clay, even if sigma bar is 0, still we cannot say that soil has lost its strength because of its cohesion. Because of its cohesion, guys. Because of its cohesion. So that is what it is called quicksand. In quick clay, even with zero effective stress, still there is some attraction between the particles. Okay. And factor of safety is IC, critical gradient by I. Okay. And this IC is always near about 1 year. Why? Because CR. G value is around 2.6 to 2.7. Minus 1, that is 1.6 to 1.7 upon 1 plus E. E value is for sand is 0.6 to 0.7. E value is 0.6 to 0.7. So it is almost ratio is 1. Almost ratio is 1. Okay. Now, moving further, this difference in quicksand and liquefaction. Quicksand and effective stress, quicksand condition and liquefaction both are effective stress 0. Quicksand condition and liquefaction both are effective stress 0. But in quicksand condition effective stress is 0 due to upward seepage, and liquefaction effective stress is 0 due to upward epicentric waves when in dynamic loading. Upward waves like earthquake, shock waves, dynamic loading. Have you got it, guys? Come on! In both condition, this will be like this. Sand will be like this. But in quicksand condition, this is due to upward seepage, and liquefaction, this is due to, and I have made a short video from a quicksand condition from Chhattisgarh. Have you seen that video 1 year before? I have made a short quicksand condition live from Chhattisgarh. I have made, and I was sitting on that quicksand condition, standing like this. Have you seen that video? And same, liquefaction is also same, but in quicksand condition it is due to upward seepage, and liquefaction is due to the dynamic loading. Okay. Now guys, this we'll do in the evening class we'll do. What is tan alpha 1 by tan, this is alpha 1. What is tan alpha 1 by tan alpha 2 is K1 by K2. Okay. Do this question. Let me know the answers once you do it. Yeah, Sumit sir is here. So the Balya ke Babu sir, one of the most dynamic, good nature person who is, guys, let me tell you, Sumit Singh, the positive energy I got from the Sumit bhai. Okay, he has taught me yoga also, and then in the Chandigarh he taught me yoga. Please everybody, guys, welcome Sumit sir, the faculty, one of the famous faculties of civil engineering. Sumit Singh, the Balya ke Babu sir. Sumit sir, have you shared the session? Share kar do yaar. Okay. Yes. Ambikapur mein. Yes, Sumit sir is also there. Na? I guess Sumit sir has shooted that video. I guess Sumit sir, you have shooted. Na? I was here and you have made the video for me. And then we have done there that also. What is that? English mein kya? Bullock. Oh, that off-roading type of vehicle. I don't know what we said to this. यही तो कमाया यार मैंने जिंदगी में, पैसे का कमाया, ऐसे दोस्ती कमाए मैंने. रियलिटी, मतलब डायलॉग नहीं मान रहा हूँ. मैंने आज तक पैसे तो कुछ कमाया नहीं है, सब जितना कमाया उतना खा पी लिया है. ऐसे दोस्ती कमाए मैंने. ओके बलिया, Guys, let me tell you, have you ever heard of Chandrasekhar sir? The Prime Minister Chandrasekhar? Prime Minister Chandrasekhar? Sumit sir is very closely associated with him, not Sumit sir, actually, sir, his father. Okay? Prime Minister Chandrasekhar sir has, Sumit sir's father is his best friend and he has many letters that Chandrasekhar has written. Okay. Chalo, kare? Okay. Now see, on the factor of safety. First of all, tell me the value of IC. This is, of course, this much small void ratio cannot be there here. G minus 1 upon 1 plus E. So it is 1. What is I? I is HL by L. 2 by 4 is 0.5. So factor of safety is IC by I. So 1 by 0.5 is equal to 2. Is equal to 2. Is equal to 2. Have you got it? Have you got it? Okay. Now, yeah, certain MSQs. Let's just mix up the questions. Okay, first of this is MSQ. An expression for A line is wrong. Expression of A line is this. The A line is the plastics that separate organic clays from inorganic clays. Yes, you can say above is inorganic and below is organic. Yes, mostly you can say this. The area marked by X is inorganic clays. Right hand side is H and clays. Yes, correct. BCD. Okay, Sumit sir is here. Now, what is the liquid limit? Just guys, I'm coming back to the Seepage. Quicksand condition is totally done. Guys, when N is 25, so liquid limit is 20 minus log 25. Okay? Above A line is clay, na, Deepak? This one, which of the following has internally consistent? This is again MSQ. Guys, for fine grain soil, H2 square is equal to H1S3. Okay, and please check because here the time is same. So H2 square is equal to H1S3. Please check wherever it is matching, those will be consistent. I guess A, B, and D will be consistent or whatever. Okay, Q is equal to KIA. I is HL by L into A. When the head is doubled, so this is 2 times. And the length is reduced by half. This is half, so it will be 4 times. Obviously. Oh my god, this has been. Okay, consider the following statement. Seepage force is applied by flowing the water through frictional drag. Correct. The magnitude of seepage force per unit volume, we have derived this here, is not gamma W by I. No, it is I into gamma W. In a soil mass subjected to upward flow of quicksand conversion when when sigma bar is sigma minus u. When sigma and u both are equal, sigma bar will be 0. Seepage, how without head difference it can be occurring. This is also MSQ. Okay. Now, let us come to the topic that most of you are not knowing and I will be making it clear to you. This is water and there is water this much and this is a impermeable surface. Okay. Now please see here, everyone. Guys, what is the head loss? Head loss is this water level difference. Now whenever there is a head loss, there is a head loss. Water goes from high head to low head. Agree? Agree? Water goes from high head to low head. Okay. So that means the water will be going here like this. From high head to low head. Two more extra lines we have to make. One is this and one is this. These are flow lines. These blue are flow lines. How many flow lines for this figure? 1, 2, 3, 4. 1, 2, 3, 4. Guys, just wait for 15 minutes. After 15 minutes, I am giving break. This 15 minutes, this topic will be cleared for you. 1, 2, 3, 4. Okay. Now there is some flow lines are 4. 1, 2, 3, 4. There are some equipotential lines like this. Like we have made two flow lines extra, one here, one here. This is also equipotential line having same energy. Equipotential line means line joining the points having same energy. Equipotential line means line joining the points having same energy. All these points are having same energy. All these points are having same energy. Datum same, pressure same, velocity is always 0. So these are potential lines. Potential lines are also represented by phi and flow lines are represented by this. Now potential lines are how many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Potential lines are 6. Potential lines means all these points are having same energy. All these points are having same energy. All these points are having same energy. Of course, this point and this point is not having same energy because water is going here. Water is going here. So, of course, here is more energy, here is less, here is less, here is less, here is less. These point, this point, this point are not having same energy. Because water is going, that means this is more energy, less, 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 then only water is going. Yes, but all these points are having same energy. And from a very my cunning head, I can see that if this is a point, if this is a 2 point, if this is 1 point, this is 2 point, energy will be same because it is an equipotential line and one is more datum. One is having more datum head and velocity head is 0. So there are 3 matches. Velocity head is tie. One is having more datum head and actually it has to be tie because it is same energy. So 2 will be having more pressure head. 2 will be having more pressure head. Okay. Now, what are the number of flow fields? Number of flow fields, NF. Number of flow fields, NF. So, number of flow fields is water going here, 1 drop. Energy drop na, here to here energy will be drop. Here to here energy dropping, reducing, then only water is going na. Then only water is going na. From here to here 1 drop, 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 from here to here 1 drop. 1, 2, 3, 4, 5. 5 drops. Any way, 1 drop and energy dropping, then only water is going na. 2, 3, 4, 5. 1, 2, 3, 4, 5. NF is number of flow fields, it is 5. It is always number of lines minus 1. It is always number of lines minus 1. This is N number of flow fields, the number of drops here. And D. Number of drops. Now NF, number of flow fields, how many water is going, and D, how many way water is going? Water is going from here, 1 way, second rasta and third. So 1, 2, 3. It is 3. So it is always 4 minus 1, number of flow lines minus 1. And it is not always 5 and 3. It can be 32 and 1, 17 and 5. Just for this figure, it is 5 and 3. And I am not going derivation. Q is equal to the discharge passing from here is K equivalent head loss NF by ND. If Kx and Ky are different, then K equivalent is Kx into Ky. Everybody give me yes or no in the comment box. Everybody on the comment box. Give me yes or no. Have you understood this or not? Have you understood this or not? Please. Please. Everyone. Okay. So this is formed from this differential equation. Okay. Properties of flow net are that these flow fields are square. Okay, these flow fields are square, curvilinear square, although it is not liking square in my figure, but these are curvilinear squares. If here the discharge is delta Q, then from this field also delta Q, from this field also delta Q. Three fields na, so all discharge will be same. If water condition is changed, that is reversed. Here this head is here and this head is here, then also the flow field will be same, but only the water is going in this to this. Okay, these are the conditions are given here. Now let us do this question for making it better understand. For making this concept understand little better, let us do this question, then we will be taking break. What is head loss here? What is head loss here? HL is 10 minus 1.5, 8.5. Yes. What is number of flow lines here? What is number of flow lines here? What is number of flow lines here? Tell me number of flow lines. Tell me number of flow lines. Number of flow lines. Number of flow lines. Everyone. इसका आंसर कितना है? आंसर याद नहीं रहता ना मेरे को. Number of flow lines बता दो. 3, 5. Excellent. Excellent. I thought that you all will be saying 3, but actually whatever we made, actually there are 2 extra. Whatever we make, there are 2 extra. Okay, so 5. Excellent. NF is equal to, what is ND? No, lines is 5 now. What is fields? NF. Number of flow lines is 5. Correct. You all are correct. 4 fields are 4. 1 water going here. 2, 3, 4. Excellent. What is ND? What is number of lines? First of all, if number of lines are 1 line, 2 line, 3, 4, 5, 6, 7, 8, 9. 2 lines extra na, this and this. So what will be ND? 9 minus 1, 8. Otherwise you can see this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Anyway you can go it. So what is seepage? Q is equal to K into H into NF by ND. NF is 4, ND is 8, H is 8.5, K is given. What is the value of Q coming? What is the value of Q coming? 0.38 meter square per day. Correct? 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 Correct guys? Correct guys? Yes or no? Yes or no? Yes or no? Any doubt? Okay. And what is the factor of safety? Guys, where it is a critical case, where the case will be critical, where the case, guys, here it is actually the downward seepage. So downward seepage is not a critical condition, it is good. From here the water is going above. So here is the worry, here is the danger. Guys, I told you now the sigma bar is sigma bar old plus minus HL gamma W. For downward flow it is plus, so it's good if sigma bar is more. For upward flow is minus, so that is the worry na. Okay, so what is the factor of safety? Factor of safety is IC by I. So what is IC? What is IC? G minus 1 upon 1 plus E. G is given, E is given. What is IC? What is IC? What is IC? युवराज पूरा देख रहे हो क्या सेशन? What is IC? 0.9189. 0.9189. 0.9189, please check. Yes. And what is I? Guys, we have to check I exit. Because exit is the chance of failure. Exit is the chance of failure. So at exit, HL by L. So length here is given as 3 meter. This flow field is 3 meter. So HL by 3. This distance is 3. What is HL? Total loss is 8.5. Total loss is 8.5. And this 8.5 is occurring in 8 drops. Loss, 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 loss. 8 drops. 8 drops. So from here to here, see here to here the loss is 8.5. But loss is from here to here 1 drop, 2 drop, 3 drop, 4 drop, 5 drop, 6 drop, 7 drop, 8 drop. So what is the loss at the last drop? What is the loss at the last drop? 8.5 by 8 upon 3. Upon 3. Guys, I am not considering here. This is the most riskiest situation. That is why they have given this. Because here the length is small. Here the length is big. So when length is small, this will come big. IE will come big, denominator. And when IE will come big, when I will come, factor of safety will be less. So this is the most critical case. This is the most critical case. This is the most critical case. Have you understood this, guys? Okay, what is IE? What is IE? 0.354. So it is 0.9189 by 0.354. This is how much? 2.6. Give me a heart sign on the comment box if you got this concept. Give me a heart sign on the comment box only if you got this concept. Only if you got this concept. Okay. Eunice, just in break, you can just revise and just check. After the break or in between the break, I'll be available in the comment section. You can ask me doubts. Okay? Okay? Okay, Eunice? Or let me explain you here, yaar. See, Eunice, factor of safety is IC by I. And I exit because exit is the dangerous case. Is upward seepage. Okay? So IC is G minus 1 upon 1 plus E. We got IC. Now I exit Prince. Okay, Prince Pankaj. I exit is HL by L. So here at the exit length is 3 meter. This is given that this length is 3 meter. Now what is head loss? From here to here, what is the head loss? From here to there, the loss is 8.5. 10 minus 1.5. From here to here, the loss is 8.5, and this 8.5 loss is occurring in 8 drops. This 8.5 loss is occurring in 8 drops. So in every drop, what is the loss? What is the loss? 8.5 by 8. So from here to here, the loss is 8.5 by 8. Have you got it now? Have you got it now? Have you got it now? Please let me know. Please let me know, friends. Okay, and guys, how this can be saved? How this can be saved? By providing the sheet walls. by providing the sheet walls. Okay, because what sheet walls, if we provide the here sheet wall, this will, the water will not be coming with so much high energy. There will be huge way, huge distance traveled by the water, and the loss will be there. Okay, so guys, this one, can you please let me know? Seepage velocity is V by N. N is less than 1, so seepage velocity is greater than the normal velocity. Seepage velocity can never be smaller. Okay, okay, this we will do in the end. Now this becomes the vertical stress. Now this becomes the vertical stress below soil. Okay, just I'm announcing the break. Just give me 2 minutes. Somebody is in the bell. Bell की आवाज आई होगी ना? Bell की आवाज आई होगी ना? Let me check. I'm coming to announce the break and the duration of break. Okay. Okay, guys. Somebody was in the bell. Okay. Yes, you can avoid the length of drainage part by avoiding the sheet pile, and that only does not elongate the length, but also it increase the length of last flow field. So if L of I exit will become less. Okay, guys. So now, at what time we have given the break? That time, and now guys, after break there will be some prize questions. We'll be doing next chapter then. Okay, so let me tell you, the Sunday marathon will be tomorrow of fluid mechanics. Then Monday morning will be 100 expected questions by whole civil team. Then Monday night, special about survey will be, it will be night. The marathon of survey will be night. Are you coming there in the survey marathon? Are you coming there in the survey marathon? Please let me know. Okay. अब ब्रेक चाहिए कि नहीं चाहिए? You want break or not? Then after the break we'll be reading consolidation and all these topics. Consolidation on all these topics. Workshop will be on 15th. And within next 3-4 days I'll be coming with a topic, ask me anything, and how to utilize those 3 hours. That will be very important. Okay. So what's the time? 3:27. So let's meet then at what time? 3:50 is fine. 3:50. 3:50 is fine, I guess. Consolidation, shear strength, earth pressure chapter is left, up, and slope stability and foundation. Okay, so consolidation and shear strength, lots of questions are coming. Okay, so let's meet at 3:50. Till then, share the session. Okay. Okay. So ready, guys? Ready once again? एक बार फटाफट से शेयर कर दो यार. एक बार फिर से शेयर कर दो फटाफट से. ओके, ऑडियो वीडियो सब सही है? कहाँ चले गए सब बच्चे? कहाँ चले गए? लंबा ब्रेक ले रहे हैं बच्चे. रेडी. ओके स्टार्ट करते हैं, ठीक है सब। ओके इसका वॉल्यूम कैसे कम होगा? ओके करें स्टार्ट। सर सर्वे की क्लास नाइट हो? हाँ, नॉट टुडे नाइट. Today night will be the practice session of this. Today night is a practice session of Geotech. Okay, that will be on Monday 9 p.m. That will be Monday 9 p.m. Okay, what you have done in lunch? Lunch, tea, snacks, क्या खाया भाई? What have you done in the lunch? What have you done in the lunch? Geotech किया लंच में पंकज. टेलीग्राम में मेरे को यहाँ ज्वाइन कर सकते हैं. लंच में क्या किया? जियोटेक बिरयानी, बाप रे बाप, दाल रोटी दही. बिरयानी के बाद तुम नींद तो नहीं आएगी? पावर नैप श्वेता, इट इज टू मच पावर नैप यार. ओके आज नाइट तो क्लास, हाँ आज नाइट विल बी द क्लास ऑफ, टुडे नाइट इज द क्लास ऑफ जिस. ओके नाउ लेट्स गो फॉर सीपेज. No, not seepage. Seepage we have done here. Vertical stress below soil. Chapter number 7. Chapter number 7. Okay. So guys, in this chapter, we will be finding the stress due to a vertical point load or a line load or a irregular load. Okay. So we are finding here in this chapter the vertical stress at a particular point. Okay guys, please see that in soil mechanics, if this is a ground level, then this is a point P, some loading is acting above, maybe point load, maybe line load, anything. Then at this point P, the vertical load sigma V and sigma H may be different, and most of the times it is different. Okay, because soil is not as homogeneous as water. Soil is not as homogeneous as water. Okay, so here the sigma V and sigma H may be different. Here this is a point, so sigma V and sigma H may be different. In this chapter we are finding on the vertical stress, whether it is point load, whether it is line load, whether it is UDL, whether it is surcharge, whether it is irregular loading. We are finding the vertical stress at this point. Horizontal stress at a particular point we are finding in earth pressure chapter. In earth pressure chapter. Okay, this is the earth pressure chapter. Now here we will be finding the vertical stress. Got it? Got it? Now for finding the vertical stress, there are various equations. Like first of all, let me do with the, okay, first of all let me do with the, what is Boysen equation. So it is saying that at z depth below and r distance away, at z depth below and r distance away, due to a point load Q, the vertical stress is Boysen constant into Q by z square. Q is the point load. This formula is valid. Boysen equation is valid for point load, and z is the vertical depth. Now what is Kb? Kb is 3 by 2 pi 1 plus r by z whole square ki 3 by 2. R is the radial distance. R is the radial distance. Suppose the point is, let r is equal to 0. Suppose the point is below it, exactly below it, there is no radial distance. So if r is 0, then Kb is equal to 3 by 2 pi. Kb is 3 by 2 pi. Okay, okay everyone. Okay, now guys, when r is 0 na, r is 0, this is well 0.4775, this is 0.4775. So at that case the vertical stress, we should be writing vertical here, is 0.4775 Q by z square due to a point load Q when the point is exactly below it. Okay, similarly the Westergaard has given its own formula, that he says, Boysen says Kb into Q by z square, he says Kw into Q by z square. He has given different equation. Similarly When R is 0, that point is exactly below it. Point is exactly below it. In that case, when R is 0, Kw is, this becomes 1 by pi. 1 by pi, I guess the value will be 0.318. 1 by pi, whatever is the value you are getting, that will be the value of Kw, that is 1 by pi. Both are given their different formulas. And if I compare BYJU'S and Westergaard, then BYJU'S value here is 0.4775. Please tell me the value of 1 by pi. Please tell me the value of 1 by pi. This is Kb. This is Kb. Please tell me the value of 1 by pi. Everyone on the comment box here, come on, where is your energy, guys? Come on. सब बिरयानी खाने के बाद energy गायब. Come on, guys. 0.318. This is 0.318 for Westergaard. And at 1.5, when R by Z is 1.5, both the values of Kb and Kw are same. Okay. Now, vertical stress due to line load. So, vertical stress due to a line load is given by, let me just, I'm not remembering these formulas, nah. I'm not remembering these formulas. Soon, guys, this is a very small chapter. After this, we are coming to the, this. So, at P point, sigma vertical at P point, which is Z depth below, this is Z depth below and X distance away. This is Z depth below and X distance away, and this is up to infinite. Can you give me the example of such, when for infinite case there is a line load? So vertical stress here is 2q by pi z into 1 upon 1 plus x by z whole square ka power 2. Can you give an example? Rail, self rate, I am not asking of train, only rail. So rail self is a line load. Okay, now vertical stress due to a strip loading, it is given by this formula, q by pi 2 theta upon sine 2 theta. Q by pi, let me just check this formula, q by pi theta plus 2 theta plus sine 2 theta. Okay, this is due to a strip loading. All these are empirical formulas in this chapter. Due to corner of rectangular area, the surcharge is q. So here at the corner, sigma vertical plea is q into I sigma. Q into I sigma, where I sigma is a function of m and n. I sigma is a function of m and n. That I sigma value will be given to you. M is length upon z, n is width upon z. Okay. And if you want to see the function of I sigma, this is a long function, no need to remember. Now when point is inside the area, see, this formula was q into I sigma when it is at the corner. So when the point is at center inside the area, suppose point is here, then divide the whole rectangle into 4 parts, 1, 2, 3, 4. Now we can apply the formula. Why we can apply the formula? Because now this point P is the corner of 1, is the corner of 2, is the corner of 3, is the corner of 4. So sigma vertical point is q of I sigma 1 plus I sigma 2 plus I sigma 3 plus I sigma 4. Because this is valid. All are rectangles and this formula I sigma is valid for the corner. And now it is the corner. Okay, and when the point is outside, suppose this is the area where stress is acting and the point is outside. The point is P here. Now you extend the area like this. Okay, now you extend the area like this. So sigma vertical at point P is I sigma of total. Let this be A, let this be B, C, D, E, F, G, H, P. So here sigma vertical at P point is Q of I sigma of A, C, P, G. Is this formula valid? Yes, this formula is valid because P is at the corner of this. This formula is, now you have added this much extra. Actually there was no load there. So you have added this much extra. So subtract this. I sigma of F, G, P, D. Is this formula valid? Yes, P is at the corner of this rectangle. You have added this much extra. So this also I subtract I sigma of BCPH. Okay, because this you have added extra. Now this thing you have added only one time. This extra added only one time. This in this term, but subtracted 2 times, plus I sigma of EHPD. Everybody on the comment box, have you understood? Give me yes or no. Everybody on the comment section, if you have understood, give me yes or no, yes or no, yes or no. Everybody, give some energy, yaar. Give some energy, yaar. Let me drink little bit guava juice. Okay, let me take my energy. So, oh, just kidding. Okay. But consolidation and shear strength are very important, huh? Consolidation and shear strength are very important. Very important. Okay. Now, Newmark's chart. What Newmark's chart is that it is saying that this formula is valid for irregular areas also. Suppose here is a ground level, and in this ground level, suppose this is an area, irregular area, and in this irregular area, suppose the stresses are Q, kilonewton per meter square. Now, at a P point, which is Z depth below and a particular radial distance R distance away, what is the sigma V? So, the formula of sigma vertical at point P is 0.005 into Q into NA. What is this formula? Let me tell you. First of all, there is an area which is irregular. Now, this is a tracing paper, TP tracing paper. Draw this irregular area in this tracing paper. The projection of P is somewhere here, P dash. Draw this irregular area with a suitable scales. Generally, the depth Z is equal to 5 centimeter. That scale, draw this and draw P dash also. Now put this tracing paper here. Such that P dash is here. And put this tracing paper here. Like this. So this is a Newmark chart where there are M concentric circles and N radial lines. Generally, there are 10 concentric circles and 20 radial lines. 10 concentric circles and 20 radial lines. This is actually 1 by 200. Okay. Now, once you put it, this you know, 1 by M into N, 1 by 200. If M and N are different, this can be different. Okay, 1 by 200 is 0.005. Q is the stress on that. NA is number of sector areas occupied. So either we will consider area as full or 1 by 2, 1 by 4, not anything else. So either 1 or 1 by 2, 1 by 4. So these blue are complete. So 2 are complete, 2 into 1. Now half. This can be considered as half. This can be considered as, this can be considered as half. This can be considered as half. 4 into half. Now 1 by 4. Either we have to consider anything as full or half or 1 by 4. 1, 2, 1 by 4. 1 by 4, 1 by 4. So 5. NA can be in fraction also. 5 into 1 by 4. From here we get the stress. Have you got this concept, guys? Please let me know. Everyone. Okay. Now there are some approximate method also. Like you want stress here. Now divide this area, this stress into this area, A1 will be 1 point load. Now Q into this area will be 1 point load. Similarly, there will be 6 point loads or 8 point loads or 10 point loads. For every point load, apply the Westergaard or Boissingham formula. For every point load, apply the formula. you'll get stress here, then do the algebraic summation. Not getting. We know the formula for vertical stress at point P due to point load. Yes. So when the area is something like this, divide into number of areas. Suppose there are 6 areas. 1, 2 and 6 areas you are dividing. For every area, multiply the area, get a point load, for every point load, find the stress here. In that way you can go. Yes, it will M and N. And Zama, if nothing is mentioned, we take it as M at 10 and 20 radial lines. Now, approximate method, another one is load distribution method. What is here? That if you want stress at this level, there is a load dispersion. There is a load dispersion. Okay? There is a load dispersion. Okay? Like here. Suppose it is 1 vertical is to n horizontal. 1 vertical is to n horizontal. I want stress here at this P point. Now, very easy. Just physics, just maths. No rocket science. Suppose this is B and this length is L. Towing. What is this? B. For 1 vertical, it is n horizontal. From here to here, how much vertical? From here to here, how much vertical? Z vertical. So it is nz horizontal. So from here to here, for 1 vertical, n horizontal. So for z vertical, it is nz horizontal. So this is nz. Now what is stress? Just pure physics, pure maths. What is stress? What is stress? Force by area. So sigma vertical at point P is force by area. So what is force? Q into B into L. This is force. Q is acting on B into L. Q is acting on B into L. So Q into B into L is force and area is B plus NZ here, NZ here. 2NZ. This is the dispersion and similarly perpendicular to the board also. L plus 2NZ. Like this. Have you got the concept? Please let me know in the comment section, everyone. Any down, please. Let me know. Let me know. Let me know. Let me know. Okay, isobar is there are certain lines having the stress 0.8Q, 0.6Q, 0.4Q, 0.2Q, generally at 1.5 times of width. Suppose this width, stress becomes negligible after that. Okay, so if isobar is given, we know that here the stresses are 0.2Q, 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 0.2Q. Isobars are the charts where the stress is same. So if isobar chart is known for a field, then we can find the stresses. करना है तो कर लो मजाक, बाकी अदरवाइज मिडनाइट में तो क्वेश्चन कराऊंगा ही मैं. Tell me. पंकज जी क्या कह रहे हैं? सर ये कौन सी फील्ड में आ गए आप? आपको सिंगर बनना चाहिए था. क्यों भाई? क्यों नहीं पढ़ा रहा? अच्छा क्या? पंकज अभी आए क्या भाई? अभी आए क्या? सुबह से पूरी रामायण हो गई, अभी आए क्या? आलाप अच्छे से करते हो आप. तो क्या बोला था मैंने कि कब से क्वेश्चन कराऊंगा? शायद से कम 10 बार से ज्यादा बोल चुका है सुबह से. ALAP क्या होता है? What is ALAP? Okay. So guys, a concentrated load of 15 nanometer, if Boyson equation is applied for, then the ratio of vertical stress at depth of 3 and 5 vertically below, that means R factor is not there. R factor is not there. So sigma vertical R is 0. 4775 Q by Z square. So sigma vertical R in the ratio of Z square. Okay. 3 and 5. So it will be 25 by 9. 25 by 9 is 25 by 9. 2 point something. 2 is 18. Okay. This will be 2.77. 2.77. Okay, Pankaj. Okay. Okay. Now, for a vertical constant load acting on the surface of this, the vertical normal stress at depth is proportional to 1 by Z square. Pankaj and all the students who have just joined me, let me tell you guys that today will be the complete revision and some topics that will make you concept stronger or make you revise better. Then tonight, 11:55 p.m. I'll be taking the little bit challenging questions. And guys, prize question is also coming. These all things we can do here. Okay, these are the two sessions that I'm coming in couple of 2, 3, 4 days. Okay, and then tomorrow is the FM marathon. Then Monday is the 100+ questions. Okay, then abhi flicker kiya tha na? I guess now it just flickered. Then it is Monday 9 p.m. Survey will be the special here. The marathon will begins in the night. And then the geotechnical practice question that will be tonight. Mega workshop on 15 January 12:30 p.m. Telegram link. Now let's go to the main chapters: consolidation, shear strength, earth pressure. Then a little light chapter. Then again the deeper ones. Okay. Semi-infinite. Yeah, very interesting question, guys. Always in strength of material there is assumption homogeneous and Hooke's law is valid. Semi-infinite means always in soil we have a semi-infinite. That means depth is finite. You have always heard that water table is at 5 meter, 10 meter. You have always heard that clay is 3 meter, sand is 4 meter, gravel is 5 meter. You have always heard like this. But you have never heard that clay is at a depth of 3 meter up to how much extension? You have never heard this. Water depth is at 10 meter below up to how much extension? Because the water level in Delhi and water level in Chennai will be totally different. Okay, so we always take depth as finite. Area we have never measured in any chapter. That is why it is semi-infinite. Got it? Got it? Okay. Now let's begin with the consolidation. Guys, a soil consists of solid, water and air. Now the volume change or volume reduction can be due to compression of air voids. Air voids are compressed, compression of solids are compressed, water is compressed, but all these are treated as incompressible. Theoretically, all these in soil mechanics are considered as incompressible. Now, expulsion of air is removed, is called as compaction, and expulsion of water is consolidation. Okay. Now, this is the case. Suppose a soil is partially saturated. So, a partially saturated soil like solid, like water, like air, when load is applied, what I told you in compaction chapter, that once load is applied, air will be removed first. That is why the correct sequence of learning the soil mechanics, is studying compaction first. And compaction is very instantaneous. It will not take much time. Okay, this compaction is called immediate settlement. This compaction is immediate settlement, SI. If sufficient load is applied, then all air waters are removed and water will be there. Now it becomes saturated soil. And still, if load is acting on it, on a saturated soil, all load is taken by, on a saturated soil, all load is taken by water. Got it? All load is taken by water. Okay, so water comes in excess pore water pressure. So water dissipates and water volume reduces. Might not be the 100%, might be this much reduces. Might not be the 100%, might be this much reduces. This is called consolidation. This is time taking. This is consolidation. Why time taking? Because the speed of water is not like the speed of Usain Bolt. The water permeability is very less, 10 to the power minus 5 range, 10 to the power minus 6 range. In this range is there. Okay. So here the speed of water is very less. Okay. So it is consolidation. Now there are two types of consolidation: primary consolidation, SCSS. This is also called as S1 degree. This is SI, immediate settlement means compaction, and this is S2 degree. By default, whenever I am saying or any book is saying anything is consolidation, by default the consolidation means primary consolidation. By default the consolidation means the primary consolidation. Okay, and questions will be only coming from primary consolidation, not from secondary consolidation. Although there is empirical formula, I will be telling you, I will be sharing the notes, but question will be only coming from the primary consolidation. Okay, sir. Got it, sir. Understood it, sir. This is the primary consolidation and that is the secondary consolidation. Now, friends, what is primary consolidation? What is secondary consolidation? When the load is applied, water comes in excess pore water pressure. Nothing in this world wants to be in excess pore water pressure. So water dissipates out. Because nothing in this world wants to be in extra pore water pressure. All load here taken is by the water, dissipates. Now when water is dissipated, we say the primary consolidation is done. Guys, consolidation takes 5 years, 10 years. It is not like compaction. Consolidation is a time taking phenomenon, 5 years, 10 years, 15 years, like this. Now, secondary consolidation is very highly viscous fluid, khasa fluid. Very highly viscous fluid. If that highly viscous fluid is moving out or some rearrangement of particles is done, that is secondary consolidation, and that is very, very less, and it is significant. Mainly in clays. Okay, it is significant mainly in clays. Okay, now this is primary consolidation is reduction due to removal of water, and here it is highly viscous water, highly viscous fluid and rearrangement of particles. This is immediate settlement is SI, that is compaction, very instantaneous. It takes years, 2 years, 5 years, 10 years. This is S1 degree, also called as S2 degree. As primary consolidation is, this is coming in the examination, not secondary. Now if I take about the immediate settlement, that is compaction. In compaction we have studied OMC. In compaction we have studied the Proctor test, but we have not studied the settlement. How much settlement will be there? This is the settlement formula. All the terms written is here. This can be asked, not very high chances, but also not negligible. 1 or 2 times this formula is asked. Okay. Now, if I talk about the primary consolidation, let me tell you the thing of primary consolidation and secondary consolidation. Don't worry. Guys, first of all, understood that there is a over consolidation ratio. That is stress in history upon present stress. Suppose in history there is elephant sitting on a soil. History. and today a small dog is sitting. So that soil is called as over consolidated soil, OC soil. For OC soil, OCR value is greater than 1. Overly consolidated soil means where the history stress is maximum, elephant was sitting, but today only very small stress. So present stress is less and past stress is more. That is called overly consolidated soil. OCR value is greater than 1. Normally consolidated soil is, in history only small dog is there. Maximum load in the history was a very small dog, but today the elephant is sitting. This is called as NC soil, normally consolidated soil, and here the OCR value is less than equal to 1 because earlier stress is minimum and today's is the maximum stress. Now what is the significance of OC and NC? I'll be telling you. Till then you can understand why we study, guys. Many of you have studied OCR, many of you have studied OC soil, many of you have studied NC soil, but what is the significance? The significance is that on a soil, by applying the same amount of load, deflection will be different. I'm again saying, on a same soil, application of same magnitude load, deflection may be different. That depends. It is OC or NC. Can you please let me know in the comment section? Can you please let me know in the comment section where the deflection will be more, NC or OC? Where the deflection will be more, NC or OC? Where the deflection will be more, NC or OC? Where the deflection will be more, NC or OC? Where the deflection will be more? Everybody on the comment section. Deflection will be more in NC because OC soil already it is acted by a huge amount of load. So the voids are very less. So you cannot apply, you cannot consolidate it more. But NC soil, in history the stress is not more, you can apply the load. Suppose I have already compacted a soil and somebody else is coming now. He is not able to compact it more. It is already OC soil. And suppose there is a fresh soil and the same person is coming, now he may be able to compact it more. Okay. Now, guys, change in volume upon original volume is change in H upon original height. Do you know how? I will derive this, don't worry. You are always reading this formula, let me explain you. Do you know how? Can anybody tell me this? How? This is a price question. Tell me how this comes. Leave this. Tell me how this comes. Tell me how this comes. Winner is Sai Prasad, Aslam, Swapnil and Dinesh. Let me taking 4 people only. Swapnil, Dinesh. Combined winner or total winner, I'll be telling you in the night. Alikya also. See, all these 5%, your names are coming to the 1,000 of the students when I'm sharing the PDF. Guys, all the change is due to height only because I told you soil is semi-infinite. So when soil is semi-infinite, that means all change is occurring on height. There is no change in area. So delta V is only due to height difference. Area is not changing. Okay. Okay, Prince, okay. Now, see, if this is solid and this is void, this is E, this is Vs, and now after compression, this is voids, this is delta E, change in voids, this is change in voids. So, now my friends, now wait, let me derive this. This is E initial, this is E final. into Vs. So volume here is E1 into Vs, EF into Vs. E into Vs is what, yaar? E into Vs is what? E is volume of voids by volume of solid, this. So E into Vs is volume of voids. E into Vs is volume of voids. So here E1 Vs is the volume of voids, here Es. So what is the change in volume? Change in volume is only this value. That is E initial into Vs minus EF into Vs. What is the original volume? Original volume is Vs into 1 plus E initial. So Vs constant, EI minus EF, E initial minus EF, delta E into Vs upon delta E into delta E into Vs into Vs 1 plus E initial. So delta E upon 1 plus E naught. Got it, guys? Everybody in the comment section. Have you got all these three values? Have you got all these three values? How I have proved every value? Please let me know. Please let me know. Please let me know. Okay. Now, what is coefficient of compressibility? Okay. Guys, if I make a graph of delta E and delta sigma bar, then of course the graph will be like this, because when more is the sigma you are applying, void ratio will be decreasing. Got it? Got it? When more is the stress you are applying, voids will be decreasing. Slope of this is AV, y2 minus y1 upon x2 minus x1, like this. Coefficient of volume change. This is coefficient of volume compressibility. Coefficient of volume compressibility is MV. Okay. Now, coefficient of compression index. If I make the graph here delta E, or not delta E, in fact E, and here log sigma graph, log sigma bar, E and log, when I make, this is E, when I make E and sigma bar, it is curve, but when we make E and log sigma bar, it is straight line, and this slope is CC, y2 minus y1 upon log sigma 2 minus sigma 1. This is the slope, coefficient of compression for NCC soil. For NC soil. Same for OCC soil is called CR. Same slope for OCC soil is CR. But for OCC soil it is not coming straight line, it is come curve. Slope is CR. And it is very flat, and it has to be flat. It has to be flat. Because OCC soil, I just told you, will not be changing much. Settlement will not be much. In OCC soil, settlement will not be much, because OCC soil is already acted by a lot amount of stress earlier. OCC soil is already acted by a lot of amount of stress earlier. Okay? Okay. Okay. So this slope is 1/5 to 1/10 of CC. CC is the slope for NCC soil. Give me yes or no. This is log sigma bar. Tell me the value log. Compression index is slope of this minus delta E upon log sigma 2 by sigma 1. So minus 1 minus 1.3 upon log 100 by 10. Log 100 by 10 is 1, and it will be 0.3. Have you got it? Okay. What is here? They are asking the coefficient of compressibility. AV is minus delta E upon delta sigma bar. So it is minus of 0.8 minus 0.85 upon 400 minus 200. Whatever is the value coming. Whatever is the value coming. Okay. This is for which, NCC or OCC? This is for what? NCC or OCC? Please let me know in the comment section. Guys, for NCC it is changing quite drastically. OCC is that soil which is acted by a large amount of stress in the history. When it is acted by large amount of stress in the history, voids are not changing very fast. For NCC soil, voids are changing fast like this, but not here. Okay, these are, guys, now sometimes in the gate examination or other examination also, the question is asked that below a clay layer for a flexible footing, what is the case? What is the pressure acting? These are all given values by IS code. Gate has asked this many times. For sand, that is gravelly soil, what is the stress? So let me tell you one thing first. There are two types of footing, flexible and rigid. I am telling you a method how to remember this. Flexible and rigid. Now see, everyone, please. हाँ, method बता रहा हूँ, असलन method बता रहा हूँ. I am telling you the method how to remember this, guys. I am telling you the method how to remember this. Flexible and rigid. Guys, always remember, for flexible, contact pressure is same. Contact pressure from base of soil. If it is sand, it is clay, it is silt, contact pressure is same. Deflection is different. Deflection is changing. Rigid, it is vice versa. Here contact pressure is different. Settlement is same. Settlement is same. Like it is flexible footing over granular soil, maybe sand. Now flexible footing, what is same? First of all, leave this here. What is flexible? What is rigid? What is flexible? What is rigid? They see, in real life, nothing is rigid. Nothing is rigid. We assume a thing to be rigid, a footing to be rigid. We assume a footing to be rigid if inside the footing there is not much orientation change of 2 points. The relative position of 2 points is not changing much. Otherwise, in real life, no footing is rigid. We consider it to be rigid. Itself, footing's elongation is not happening. Yes, it can settle like this, but itself it is not changing. Abhinav Negi's height is not changing. Yes, Abhinav Negi is moved here. 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 But itself, Abhinav Negi's orientation is not changing. Abhinav Negi's height is not changing. So footing may settle, but itself, its own dimensions are not elongating, not compressing, then it's rigid. It's assumed to be rigid. If it is changing reasonably, because everything will change, rigid will also change, nothing is rigid in this word. But if it is changing with high value, then it is considered to be flexible. Okay. So this is flexible. So contact pressure is same. See, contact pressure is same, x. Here x, see the distance between two parallel lines is same, na? And flexible, deflection is changing. See, deflection changes. Now this much you have to learn. Yar Aslam, Ansal Maza. This much you have to learn that it is changing like this. Settlement is more at the edges and less at the center. Now it is what? Flexible. So flexible means pressure is same. See, pressure is same. And settlement is here. Here less settlement, here more, then less. Now rigid means settlement same. See, settlement same. It is settled here, settlement same. This is different. Pressure X, Y, Z. Okay, and it has pressure like this, that you have to learn. And granular, settlement is same. Here settlement this. Yes, settlement pressure is different. Have you got it? Guys? Everybody? Now a very important term in consolidation from where various numericals will be asked. That is capital U, and capital U is degree of consolidation. Degree of consolidation, very important term in consolidation. What is degree of consolidation? If the total settlement of a soil was expected to be 100 mm and it has settled till now 20 mm. So that means 20% consolidation is occurred. Degree of consolidation is 20%. If a soil is expected to settle, by 100 mm and it has settled 35 mm till now, because consolidation is a long phenomena, it is settled by 35 mm till now, then degree of consolidation is 35%. If a soil is to be settled by 100 mm and till now it has settled 70 mm, so 70% degree of consolidation is occurred. Degree of consolidation means how much consolidation has been happened. So one formula is delta H by H. How much is the settlement at any stage upon the total settlement. Of course, nothing is mentioned is primary consolidation settlement. Okay. Now one more formula. All formulas will give the same answer. This one. See, at T is equal to 0. E is the actual void ratio. E is equal to E naught. So degree of consolidation is 0%. Exactly. At T is equal to 0, degree of consolidation has to be 0% only. तब तो start ही नहीं हुआ ना. And at long time, T is equal to infinity. E is equal to EF. Final void ratio. So E naught minus EF upon E, then degree of consolidation is 100%. Yes, formula is validating, correct. Similarly here, T is equal to 0, this will be 0. So 0%. At T is equal to infinity, delta H is equal to capital delta H. Okay. Now, here, UI is initial pore water pressure. U is pore water pressure at any stage in between. And UF is pore water pressure at the end of stress. So at T is equal to 0, U is equal to UI. Okay. So at T is equal to 0, U is equal to UI. So it will be 0% and T is equal to infinity. U will be UF. So it will be 100%. So it is validating. So that means degree of consolidation means how much consolidation has happened. Degree of consolidation means how much consolidation has happened, how much consolidation has occurred. Okay. Now, this is, guys, from two formulas, 90% questions of consolidation will be asked. From two formulas, 90% questions of consolidation will be asked from two formulas. What are those two formulas? One formula is this: TV is equal to CV into T by D square. Now TV is depending upon function of degree of consolidation only. If degree of consolidation is less than 60%, TV formula is this. Suppose a degree of consolidation is 30%, pi by 4 into 0.3 square. Suppose degree of consolidation is 59%, pi by 4 into 0.59 square. And if it is more than 60%, formula is this. That means for 30% degree of consolidation of sand, silt, clay, gravel, TV value is same. TV only depends on degree of consolidation. No soil factor is coming. For 72% degree of consolidation of sand, silt, clay, gravel, TV will be same. Nothing to do with sand, nothing to do with silt, nothing to do with clay, nothing to do with gravel. Okay. CV is a function of soil only. Function of soil. CV is a function of soil. That means for clay, 20% consolidation or 30% consolidation or 40% consolidation or 50% consolidation, CV will be same. CV is a function which is depending on soil. CV is a function which is depending on soil. For 30%, 40%, 50%, 60%, 70%, any percent degree of consolidation of clay, CV will be same. Okay? Okay? Now D is drainage path. For single drainage, suppose here is rock. All water is going here. All water is going here. This is suppose H. So here single drainage D is equal to H. Suppose like this, and water is going here also, here also. No rock at the bottom. Water can go. So here D is equal to H by 2. Now two questions which will give you minus 2 by 3, not plus 2. Two questions which will give you minus 2 by 3 instead of plus 2, or minus 1 by 3 instead of 1. And if it is MSQ and NAT, there is no negative marking, they will give you 0 instead of plus 1. What are those two questions? What are those two questions? First question. This is not a price question. If in single drainage, for a particular soil, for a particular load, total settlement is 10 mm, then for the same soil, for the same load, what is the settlement in double drainage? I repeat the question. In single drainage for a soil, settlement is 10 mm. Total settlement will be 10 mm. For double drainage, for same load, same soil, total settlement will be 10 mm. Total settlement in single drainage will take more time. In double drainage it will be faster because water is going from here also, water is going from here also. But value will be same. Total settlement will be 10 mm. Total settlement will be 10 mm. Okay. Now, next question. In single drainage, for settlement, it takes T time. So in double drainage, how much time it will take? Yeah, it's flickering right now also, na? In double drainage, how much time it will take? In double drainage, how much time it will take? In double drainage, how much time it will take? In double drainage, how much time will take? एक बार ना प्रिंस आप हैं क्या अभी? हाँ प्रिंस, एक बार कब कब फ्लिकर हुआ ना एक बार नोट करते रहना और मेरे को बाद में टेलीग्राम में भेज देना. एक बार तो ये लिख दो कि टाइम फैक्टर पढ़ाते हैं फ्लिकर हुआ, क्योंकि फिर मैं ये स्मार्ट बोर्ड वालों को वो वीडियो बना के भेज दूंगा ना, फिर वो ठीक कर लेंगे. ठीक है प्रिंस? सो इन डबल ड्रेनेज टाइम यू सेड दैट T/4. एक बार ये वाला टाइम नोट कर लेना, टाइम फैक्टर वाला, है ना? बस ये टाइम भी नोट नहीं करना है, बस ये नोट कर लेना टाइम फैक्टर पढ़ाते हुए. एक बार पहले हुआ था, वो याद है किसी को कब हुआ था, क्या पढ़ाते हुए हुआ था? Okay, so all of your answer is wrong. T/4, it is wrong. Many times I told you, yaar. What you are doing now? TV is equal to CV into T by D square. This is for single drainage. And for double drainage, TV is equal to CV into T D by 2 whole square for double drainage. And you are dividing both of them. And here in double drainage T dash is equal to coming to be, here in double drainage T dash is coming to be of single drainage YT by 4, है ना? You are dividing this and doing this, but you are doing this wrong, yaar. Why, guys? In single drainage time is T, double drainage time will be T/4. In double drainage time is T, in single drainage time will be 4T. Yes, this is only valid. See, I am seeing this is only valid when soil is same and U is same. Sab you are copycat, yaar. Guys, this is dividing, that means this and this is cancelled and CV is cancelled. So CV and CV is cancelled, that means soil is same. TV and TV is cancelled, that means U is same. So it is not every time in double drainage time will be T/4. Have you got it? Guys? Come on, please let me know in the comment section. Please let me know on the comment section. Have you got this or not? Have you got this or not? Everybody. everybody. Enjoying? Enjoying, guys? Okay, now this is, see how to find CV. Find T of 50%. Okay, TV 50, time required for 50%, H square. These are similarly, it is 90 also. This is waste of time. Do this. Do this. In ultimate settlement is 10 mm. However, there is no drainage at the bottom. So ultimate settlement remains same, na? Ultimate settlement remains same, na? Ultimate settlement remains same, na? Then for same soil with same degree of consolidation in double drainage, now time will be T by 4. Now say these two words should be written, same clay. Otherwise, if it is not written, you have to apply this formula, complete formula. With different TV here, different TV here, if consolidation are different. If soil are different, different CV here, then find T dash and T ratio. That we can, okay? Now, guys, now how to find the settlement? The two formulas I told you now in this chapter. Second was this one. Second is this one. Okay? So, delta H by H naught is delta E upon 1 plus E naught. So delta H is this, one formula for certain. Any of these formula can be applied depending upon what the condition is given in the exam, what values are given in the question. Suppose MV is not given, these are CC is given, so you have to apply this formula obviously. Another formula is MV. First of all, what is MV na? MV is change in volume with respect to original volume with respect to change in stress. This is MV. I am talking of this one. Here there is someone MV na. I've told MV here na. Kahan gaya? Yeah, this MV, coefficient of volume change. Yeah, this one. Okay, so this MV is kitni slide ho gayi? Any guesses? How many slides we have completed? These questions we'll doing in the midnight. So delta V by V upon delta sigma bar. Now delta V by V is also called as delta E upon 1 plus E naught into delta sigma, and delta E by delta sigma is AV. So MV is equal to AV upon 1 plus E naught. One more relation, CV is equal to K upon gamma W into MV. From here also many times questions are asked that a particular soil is 4 times more permeable, 3 times more compressible, then what is the ratio of CV? So 3 times more permissible and 4 times more compressible. Compressible means MV, then 3 by 4, like this. So here delta H is MV into delta sigma bar into H naught. H naught is the height of the layer. H naught is the height of the layer where we are finding the settlement. Suppose this is the soil clay, this is the sand, this is the silt. Suppose some load is applied, I want to find the settlement of sand. So H naught is for the sand and delta sigma bar is the change in effective stress at the center. Delta sigma, see delta H is equal to CC upon H naught 1 plus E naught log sigma naught bar plus delta sigma. This is also the same thing, na? I have written sigma 1 as sigma naught and sigma 2 I have written as sigma naught plus something. So here also delta sigma is at the center of the layer we are finding the settlement. Delta sigma bar is the stress increment at the center of layer, and H naught is the height of or the thickness of the layer where we are finding the settlement. Suppose we are finding the settlement of sand only, so H naught will be of sand, and delta sigma is the increased stress increment here. And if it is overly OC soil, then instead of CC we should be using CR. Okay. Okay, so how many number of slides we have done? 3, 4, 5, 6, 7, 8. Yes, now comes this 9th chapter. Shear strength. Guys, enjoying or not? Please like the session if you have not liked till now. Please like the session if you have not liked till now. Everyone. And subscribe the channel for more such sessions. Subscribe the channel for more such sessions. Okay. Guys, थके नहीं? Girish is there? हाँ Girish, एक बार जो आपने कल रात whatever the question that you have sent me in the night ना, please around 9-10 PM again ping me on the WhatsApp. So I should make that question in tonight's PPT. Otherwise I will be forgetting. Okay. 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 Ready for the shear strength? Ready for the shear strength, everyone? And how many number of slides? उसको save भी कर लेते ना, कहीं बाद में save ना हो पाए. Keep. हो गया save, हो गया. 328. In between, suppose 50 slides are not of use. That means, okay, अच्छा खासा पढ़ लिया. See how much we studied. My God. Okay. 11, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 PM to 4 PM. And now it's 4 PM to 5 PM. Okay, so nothing is ज़्यादा नहीं बचा है. Okay. Enjoying? Yeah, Girish guess is quite correct. Girish, is it getting benefited? Getting benefit? Okay. Chalo, guys, let us come to the shear strength. Whatever the load in the soil, always the failure is in shear, sliding of two planes. Okay, irrespective of the load, always you have seen such kind of figures in Facebook, social media. The failure is always shear. Whatever the loading is, one plane is coming out or sliding with respect to the other plane. So this is the shear failure. Okay. बिल्कुल Rahul Sharma. Okay. Now, Guys, there are two things that is giving us strength in shear. One is cohesion, and see, interlocking is in the friction only. One is cohesion, one is friction angle. Now cohesion is also helping us in two ways. One is the electrostatic cohesion, like in clay, plus is attracted towards minus, because clay there is charge separation na. And one is apparent cohesion. Apparent cohesion means that looks like to be cohesion, but it is not actually cohesion, like capillary action. So capillary action causes negative pressure, and negative pressure means suction of particles. Negative pressure means suction. How vacuum cleaner works? How vacuum cleaner works? So vacuum cleaner works that we put negative pressure inside the vacuum and that sucks the particle, because everybody wants to go from high pressure to low pressure, and once in the vacuum cleaner there is low pressure, so low pressure means particles are sucked. Low pressure means particles are sucked. Okay, so if there is negative pressure, then the particles will be attracting, and it appears like apparent cohesion. Now friction angle is also helping in two ways. One is interlocking, one is friction between the two particles. If more friction, it is good, na, strength will be more, it will not be sliding. Strength will be more sliding. Sliding will not be there, slip surface will not be there. And one is interlocking. Suppose there is angular shape particles, they will be interlocked here like this. For clay, C is equal to not 0 but phi is 0. Why phi is 0? Logic. You are always remembering that for clay phi is 0, but why? Because phi is related to friction and clay is a flaky shape, not an angular shape. Flaky shape. So flaky shape, interlocking and friction is very less. That is why 0. For sand and NC and NCC clays, NCC clay is also working behaving sand. So here C is equal to 0 because there is no charge attraction, there is no electrostatic attraction, but phi is equal to not 0. Have you got it? Have you got it? Okay. Now the shear strength is given by C plus sigma tan phi, or shear strength is C dash plus sigma bar tan phi dash. Now when I was in college, I was every time wondering that what is C dash, what is C? Nothing yaar. If while calculating C and phi, there is some process. I will tell you a process right now. If you use sigma, if you have used sigma, then the values are, let me just explain you, just explain you. What we do, that shear strength is C plus sigma tan phi. This is shear strength. See, equation is a straight line. Tau is equal to shear strength. This is strength. This is strength. Straight line. You can see a straight line. Y-axis tau is equal to m. M slope is phi, x, y. See here. Y-axis tau, x-axis sigma. This is slope m, phi, and this is c. C is the intercept. C is the intercept. Now y is equal to mx plus c. This is the strength. Okay, now how to find c and phi? How to find c and phi? Now see. Please see. Take a soil sample and apply the confining stress, that is called sigma 3, from all around, or also called as sigma c, all around, top, bottom, here. Then to break it, apply sigma d only in vertical direction. First sigma 3 is coming from all direction. Now to break it, apply the Davidric stress only in the vertical direction. Apply the Davidric stress only in the vertical direction. So finally it comes as sigma 3 sigma 3, sigma 1, sigma 1. Of course, what is the major stress here? Major sigma 1. Minor, not sigma 2, here we represent as sigma 3. This horizontal plane is major plane because the major stresses are acting. And the vertical planes are the minor plane because the minor stresses are acting. Now, if I draw the Mohr circle, this comes like this. This comes like this. Leave this. So for failure, we have drawn a Mohr circle, one soil sample. For a particular sigma 3, it fails at a sigma 1. For a particular sigma 3, it fails at a sigma 1. For a particular sigma 3, it fails at a sigma 1. Now same soil, a different sample is made. Now same soil, and we are applying more sigma 3 now. We are confining more 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 now. So when we have confined it more, so more amount of diabatic stress is required for failing it. More amount of diabatic stress is required for failing it. Yes or no? For more amount of diabatic stress is required for failing it. So bigger diabatic stress is required for more sigma 3. So more sigma 1 is required. Bigger Mohr circle will be there. Why bigger Mohr circle? Because sigma 3 have increased. So more stress is required for failing it. Okay. Now from here, draw the common tangent. So the common tangent will be phi and this will be C. Everybody on the comment box, give me yes or no if you have understood. Everybody on the comment section, give me yes or no if you have understood. Come on, champions. Come on, champions. Shiva, more diabatic stress is required because you have confined it with more stress. So when we confine it with more stress, that means more stress is required to fail. Now, if you are confining it, nahi jaane dunga. Okay. So from first Mohr circle, then second Mohr circle, you can make infinite Mohr circles. At different sigma 3, it will be failing at different sigma 1. So here as we find C and phi, if we have used here in x-axis sigma, it is C and phi. If in x-axis we have used effective stress, then it is C dash and phi dash. Have you got it, guys? If we have used, it can be not center. Yeah, sigma 3 can be here also, not center. If we have used sigma 3, if we have used sigma, it is C and phi. If you use sigma bar 3, sigma bar 1 and so, it is C dash and phi dash. This intercept then is C dash, it is phi dash. So actually this is stress. This is strength, green one is the strength. Green one is the strength and this is stress. And this is the point of failure. This is the point of failure where strength and stress both are same. Where strength and stress both are same, that is the failure. Where strength and stress both are same, that is the failure. Guys, see, failure is not happening here at maximum stress. Why? Because at maximum stress, the strength is even more. Green, strength is even more. Because at maximum stress, strength is even more. Green is even more. Strength is even more. Okay, so failure is where the strength and stress both are same. The strength and stress both are same. Okay, because see, what is this? What is this? What is this? What is all these values? What is all these values? All these values are stresses at different planes. Mohr circle concept here. At different planes there are different stresses. At different planes there are different stresses. This is stress and this is strain. Oh sorry, this is green one is strength. Okay. So failure plane. See, this angle is phi. This angle is phi. This is 90. So this is 90 minus phi. and this is 90 plus phi. So from major plane, failure makes how much angle? Not 90 plus phi. In Mohr circle, every angle is represented by double. See, sigma 1 and sigma 3 are 180 degree apart. Actually, they are 90 degree apart, na? One is vertical, one is horizontal. So in Mohr circle, everything is represented by double. So in actual life, the major principal stress and failure stress from major plane, failure plane is at 45 plus phi by 2 angle. And from minor to failure, it is 45 minus phi by 2 angle. Everybody on the comment section, give me yes or no. Everybody on the comment section, give me yes or no. Okay, and relation between sigma 1 and sigma 3. Relation between sigma 1 and sigma 3 is this. Yaar, come on. Wait. This can be derived easily. And if I use here bar, so here you have to use phi dash, c dash, like this. And 1 plus sine phi value upon 1 minus sine phi value is equal to tan square 45 plus phi by 2 value. And it is also equal to tan phi is cot 90 minus phi. So it is cot square 45 minus phi by 2. 1 plus sine phi, 1 minus sine phi is tan square 45 plus phi by 2 or cot square 45 minus phi by 2. Similarly here, 1 minus sine phi, 1 plus sine phi is tan square 45 minus phi by 2 or equal to cot square 45 plus phi by 2. Okay. Now, okay, these questions. Tell me this question. Come on. Tell me this question. Tell me this question. Tell me this question. The ratio of shear stress to normal effective stress. Tau is equal to C plus sigma tan phi. Cohesionless C will be 0. So tau by sigma is equal to tan phi. So tan 38 will be less than 1. Because tan 45 is 1. 0.781 or whatever you are getting. Now, okay, now how to find C and phi? Not with experiments. Now there is the analytical way. Analytical means the numerical way. Okay, so first way is there is a PQ plot. How this PQ plot works? Let me tell you, guys. If you draw that Mohr circle, na, in that Mohr circle, if you do this, there will be an equation. Sigma 1 minus sigma 3 by 2. Sigma 1 minus sigma 3 by 2 is equal to C cos phi is equal to C cos phi plus sigma 1 plus sigma 3 by 2 into sin phi. See, everyone. This is an equation from Mohr circle. You can easily derive this. Let this value be Q. And Q, sigma 1 minus sigma 3 by 2. And let this value be P. So on Q and P, it is a straight line. Okay. Effective stress. So U is not given, na? So that means that this phi will be phi dash in that case. That will be phi dash. Okay. Okay, so this is Q and P. Now what we do, that it again flickered, write down that pins. Okay, this is a sample 1. I applied sigma 3 1 from all around, then David's test, it fails with sigma 1 1. So for this first sample, everybody, for this first sample, there will be a Q point sigma 1 1 minus sigma 3 1 by 2, and there is X coordinate sigma 1 1 plus sigma 3 1 by 2. Y coordinate will be sigma 1 1 minus 3 1 by 2. This is sigma 1 1. 1 1 means 1 of first experiment, sigma 3 of first experiment. So there will be a point like this. Now same with the same soil, I make after failing this, after breaking this, I am making a second sample. So in second sample, I am making sigma 1 2, and this is sigma 3 2. So sigma 1 of second sample, sigma 3 of second sample. So here will be some point sigma 1 2 minus sigma 3 by 2, and x-axis is sigma 1 2 plus 3 2 by 2. Now here join this because it is a straight line. So joining this, there will be some slope. Find the equation of P and Q. Find the line. With 2 points I can find the equation na. With 2 equations I can find the equation na. So here is the equation. Slope angle is beta. So what is beta? Actually the slope angle beta is sine phi. So phi is sine inverse of tan beta. Have you got it? Have you got it? Have you got it? Okay. And while drawing the graph, we got a C point. C point. So the intercept is C cos phi. C cos phi. C cos phi. So C is intercept. Intercept here comes alpha, suppose. Intercept, suppose, comes to be alpha. So alpha is C cos phi. So C is alpha by cos phi. Everybody give me yes or no? Come on yaar, only one people, you cannot write Y. I'm shouting like this from morning and you can't write Y. And you can't write Y. Wah. 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 Good. Okay, this is how we find C and phi. Any doubt, please let me know na yaar. Any doubt, please let me know na yaar. Any doubt? And guys, in the night I'll not taking much of time. Only 12 questions to complete whole geotechnical engineering. Beautifully designed 12 questions to represent all concepts. Specially designed questions will be those. Okay. Another way is N phi method. First is the PQ method and N phi. N phi is this is the equation na. Write this 2 times. For first experiment, for first sigma 1 3 1, sigma 1 1, write down this. For another experiment, sigma 3 2, sigma 1 2, write down this, and you will get it. Everybody give me yes or no? Everybody give me yes or no? Everybody give me yes or no? This is one equation, 2 unknowns na. Unknown is C and phi. 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 Okay, these are analytical methods. Otherwise, there are some empirical, experimental methods also. There are some experimental methods also. Like, please see, there is a vein shear test. Now I am coming to the test. The vein shear test is a field test. Here we insert a vein in the field. Insert the vein in the field. Okay. and we apply the torque. And once it is rotating like this. Okay, diameter is d, suppose height is h. So we require some torque to rotate this. We now write down that torque. So from here the C value is T by pi d square into d by 6 plus h by 2. From here we find out the cohesion value. T is the torque required to rotate it. T is the torque required to rotate it. D is the diameter of this movement and h is the thickness. H is the height. One more case is there. When the top of the vane you have not inserted. So here C is equal to T upon pi d square d by 12 plus h by 2. From here we find out the C value. This is why I am not finding for phi. Why I am not finding phi? Because this is used only for clay. Why it is used only for clay? Because guys, this is a field test. A very sensitive soil like soft clay, if we take that soil to lab, the properties will drastically be changed. Okay, so we have to do the testing in the field itself. Either we take an undisturbed sample or we do in the field test. So for clay we use this because that is very sensitive. If we take the lab, the properties may change. Therefore I am only finding the C. Now direct shear box test, that is used for sand. Please see here. We put the sand here and we apply some load from here N. So on this plane, this is the failure plane. Some stress is applying and we are moving it here. We are doing like this, shearing from here. So with N load there will be some normal stress. Sigma is N by A. Okay, and this is shear force by area. So we applied some normal load, and due to this normal load on this failure plane, because why this is failure plane? Because I am shearing it like this here. So there will be some normal load, sigma value is N by A and shear value is T by A, at which it fails. Since it is used for sand, so it will be starting from origin, because phi is 0 na. C is 0. C is the intercept na. So it is starting from here. So that is how we got phi value. We apply a load N and see how much load it is failing. Okay, then x-axis N by A, y-axis T by A, and we find the phi. Now this is only used for sand, not for clay. There is a long story behind that. One advantage is there here the horizontal plane is failure. Might not be in real life, this is the weakest plane. Guys, if I'm tearing my shirt like this, if tearing my t-shirt like this, it will tear from here, not from here. But might be the weakest fiber is here. So here one drawback is that it is failing from a horizontal plane. Might be in real life this is not the weakest plane. Another thing is, guys, let me take the chair for this. Let me take the chair for this. Everyone, please see. Please see. Guys, C and phi are not the inherent properties of soil. Okay? C and phi are not the inherent properties of soil. Means, for a particular soil, on different types of condition, C and phi can be different. Suppose this is soil sample. I am applying sigma 3. I am applying sigma 3. Sigma D here for filling it. Now if I am allowing the water to go out, drainage allowed, I have put the porous stones here so the drainage can be there. Then C and phi can be different. If on the same soil, on the same test, if I have not applying the water to go down, I have not applied the porous stones, I am not applying the water to go down, then here it will not be, then here this will not be, this sample will be having different C phi. Okay? Okay, same soil sample can give many C and phi. If when you are applying sigma 3 and sigma 1, when you are applying sigma 3 and sigma 1, if drainage is allowed, C phi different. If drainage is not allowed, C phi different. If loading you applied fast, C phi different. So same soil sample. If drainage allowed, if loading applied gradually, C phi different. So the same specimen can have different C phi. Now the condition arises that what type of test we should use then? What type of test we should use then? So friends, we should use those C phi that are simulating the field conditions. Like for clay, we should not allowing the water to expel because clay permeability is very less. In actual life also the permeability in clay is not much. So while finding C and phi for clay, while applying the sigma 3 and sigma 1, we should not be allowing the water to go down because that is representing, that is simulating the field condition. For sand, we should allow the water to go out because in actual life also sand is permeable, so water is going down. However, this is not the mandatory condition, because if loading is very slow, if loading is very slow, then even the clay can be drained. And if loading is very fast, आज ही मायावती का पुतला बनाना है, कल आ रही है बहन जी चक्कर पे, so even sand can be sometimes undrained condition. So whatever is the condition, same thing we should be representing, same type of testing we should be doing. So that, because C and phi is not the inherent property na, C and phi is not the inherent property na, it depends on type of testing. So same type of testing should be done, and that liberty is given by us by the triaxial test. Triaxial test is a universal test that every type of test can be performed, sand, clay, there is no limitation, and all types of testing, all types of things can be done there. Okay, in triaxial test there is a soil sample, we put a rubber membrane, okay, and here I am putting the water. Guys, many of you are not knowing today that why it is rubber membrane here, because we have calculated everything for semi-infinite. I always allow the water to move in this direction. So to simulate the field condition, the soil sample is also rubber. We put a rubber here. We put a rubber here. We put a rubber here. So water is not going here. Only water is going in vertical direction. And this water is applying the confining stress. This water is applying the confining stress. This water is applying the confining stress from all around. This water is applying the confining stress from all around. And from here I am applying the divertive stress. This proving ring and dial gauge are twins. Proving ring and dial gauge are twins, looking like same. Looking like same, but proving ring gives load or stress. Dial gauge gives deflection or strain. So here I am applying the sigma D. Now if in field the drainage is allowed, suppose there is sand, drainage is allowed, so we put this wall open so that this testing is exacting the field condition. Here in water is applying sigma 3 and from here I apply sigma D. This is also like same na. This is also same na. And here I am applying sigma D. So it will become sigma 1. Sigma D I am applying from here. Okay. So my friends, Ashish, you want to purchase, तो मैं क्या करूँ? Record lectures are available. Yes, you can take, but I don't know the cost. I don't know the number. What is the number of BYJU'S? I don't know. We don't know. We here in the BYJU'S faculty are not having any code also. 10% discount, this percent discount. I don't have even number. Number is written कहीं. Number नहीं लिखा. Number तो नहीं लिखा. We don't have any code like also Abhinav 10. I don't have any such code. And unfortunately I don't have any number also. So what I suggest you that go to the app, might be there is some number or talk to counselor option. So from there you can do. Otherwise I don't know yaar. Otherwise okay, leave. Okay, so okay, kahan gaye? Sigma 3 and sigma 1 are applying. So if in the actual field condition drainage is allowed, so we'll put this valve open so that here also soil water is going out. If you want to measure U, you can put this valve open and measure the U, pore water pressure. So triaxial test is very universal. We can do all types of testing here. Okay, we can do all types of testing here. If this drainage valve is closed, this will be a undrained test, undrained. If drainage valve is open, this will be a drained test. From here you can measure U also. U measuring also means you are measuring sigma bar also. Sigma bar measuring sigma bar means that you can find C dash and phi dash also. Okay, so this is how it works. Got it? Sigma 3 is applied and from here sigma D is applied. Now in this also there is no predetermined failure plane. There is no predetermined failure plane here. There is no predetermined failure plane here. Okay, whatever is the condition, it will fail from there. Whatever is the weakest plane, it will fail from there. Whatever is the weakest condition, this will fail from there. Have you got it? Everyone please let me know. Okay, now there are various types of tested like CD test. In CD test, what happens in first stage? First stage means application of sigma 3. Second stage means application of sigma D. That will make sigma 3 plus sigma D is equal to sigma 1. In CD test, what we do? In CD test, it takes long time, and in both the stages, valve is open. First stage also, second stage also. First stage means when we are applying the sigma 3. And second stage means when we are applying sigma D. Second stage means when we are applying sigma d. Okay, in both the stages here, in both the stages, drainage wall is opened, this wall, C, D, C also, D also. Another is CU test. First stage, application of sigma 3, wall is open, but when I am breaking the sample, applying the sigma D, wall is closed. Third stage, walls not open in both cases. Now which test to apply where? Which test to apply where? Which test to apply where? This is the question. Which test to apply where? Now let me tell you. Suppose there is a very old building. Suppose there is a very old building. Very old building. And now I want to find the CN5 today. We should be doing which test? We should be doing which test? CD test, because its consolidation and drainage has been happened. Suppose my village, my building that was made by my grandfather 30 years back, 40 years back, drainage is done, CD test. Now suppose I just made a building, and that too very rapid construction. Commonwealth game is here in 2024, 2023, and suddenly somebody from United Kingdom has said, oh, from Delhi, Arvind Kejriwal, oh, Narendra Modi, there will be a Commonwealth game next year, and we are giving this opportunity to you. Can you make in 1 year the stadium? Arvind Kejriwal say yes. So all the manpower are there to make the stadium, and then they make the stadium. If after making the stadium, I want to check, the C5, what type of testing should be done? UU. Because the water will not be going out very fast. No, yeah, not CU. So after one sir will come in too, na? You are thinking like that, na? That after one sir will come in too. If I want to check the immediate stability just after construction, so never the drainage occurred, I'm just making 10 days, 20 days building, very fast construction, it will be UU test. And the speciality of UU test is that here the more circles are of same radius, not bigger radius. Same radius. Do you know why? That is why we are not getting phi here. Common tangent is only giving C. That is why we are only finding it for clay. Even clay is undrained. Na? Do you know why? Because here sigma bar is sigma minus U. Sigma bar 3,1, sigma bar 1,1, second experiment, sigma bar 3,2, sigma, because once you increase the U, it is undrained testing. It is undrained. You are not allowing the water to go out. So sigma bar will be increased. So this will be unchanged. Sigma bar represents the love between the particles. Sigma bar represents the love between the particles. And that is unchanged. So unchanged means the unchanged means that if it is earlier failed by alpha incremental stress, again it will fail by alpha incremental stress. Got it? Because particles are having same strength now, na? Sigma bar is not changing. If sigma bar is not changing, that means it has same stress. Got it? The same love between the particles as earlier. Sigma bar is same. So if it is earlier failed by alpha incremental, now also alpha. So CD for a long testing, for that building which has lived many of lives, UU is just, and CU means like that. Let me tell you, have you seen that picture where the Kader Khan is the owner of a 5-star hotel, his daughter is Ravina Tandon, and in front of his hotel there is a dhaba of Govinda, and Govinda phasa leta hai Ravina Tandon ko, and some bulldozer is coming to, because the business of 5-star hotel is badly affected by dhaba. So Kader Khan calls bulldozer to thrash the dhaba of Govinda, but Govinda do something and the ulta, in reverse, the 2 floors of Kader Khan has been out. Have you seen that film? Okay, now a particular embankment which has lived some of its life, and now the 2-meter soil from it is removed. 2-meter soil is removed. So earlier the consolidation is happening, but now suddenly the soil is removed, the load is removed. It is not consolidating now because load is removed. So that will be CU test in that case. Not getting. Suppose this ground level, I make a building. This building load is applied. So consolidation is happening. Consolidation is happening. Like in Qutub Minar also. Now I remove the top 2 floors. So load is decreased. So suddenly for some time consolidation stops. So here we will be doing CU testing because earlier it was consolidation, now it has stopped. Or like in Qutub Minar, top 2 floors are broken now. So at that time when they have fallen down, it was a CU testing there to find the C5. Have you got it? OCC is different, na? OCC, yes, you can say. But OCC soil, see, this after some time will be behaving like a CD test. I am saying just for, yes, OCC soil is correct, Prince. OCC soil is correct, but at that instant when the load is removed. After a very long time, it again can become CD. Okay, this all is whatever I told you, this is written here. Okay, and another type of test is UCS test. Another type of test is UCS test. Unconfined. Unconfined means sigma 3 is 0. Unconfined. 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 Sigma 3 is 0. So whatever load you are applying here, at that it will fail. It is also called as compression test. How much load it can take. Unconfined. Compression. How much load it can take. QU. Okay, if sigma 3 is 0, it will start from here and it's failing here. QU. So C is radius. This is UCS, unconfined strength by 2 or QU by 2. This load is QU, yaar, at how much load it's selling. Why this is used for clay only? Why this is used for clay only? Because only clay can stand without confinement due to cohesion. Sand cannot stand straight without confinement. Sample can be made only for clay. Sample can be made only for clay without confinement. Got it? Got it? Okay, this sample, this I will give you in PDF, not much important for GATE. These are the 2 sessions coming. Now, this is FM tomorrow. This is Monday. Monday evening I'll be coming with survey marathon, and today night practice session. Workshop will be on 15th. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th chapter. It will not take much time now. It will not take much time now. Okay? You want break? You want break? How much time? Okay, let's meet at 6 p.m. then. Pore water pressure coefficient, I have taken a numerical in the evening, that's why I'm not taking here. That's why I'm not taking here. I will explain it there. 6 or 6.5. Okay. 6.5 or 6.10? 6.10 will be more, na? Okay, 6.5 is fine. Yes, yes, correct. Due to negative pore water pressure. 6.10 पे मिलते हैं. Let's meet at 6.10. Good evening, good evening. Six five, 6'5". स्पीड बढ़ाएंगे भाई अब थोड़ा, ठीक है? सुन रहे हो? सब चले गए। Ready? Ready, everyone? Okay, thank you, Prince. Thank you. Thank you, Prince, for sharing in Telegram. Just wait. Let me share. Okay, so everyone ready for the final lap? For the final lap, are you all ready? Yes. Here I will be sharing the PDF, na? Oh no, earth pressure right now. First, let me save it till here so that ink should not be wasted. This is chapter number now 10, earth pressure. This is now chapter number 10, earth pressure. Yes. So anyone here, not anyone here, most of you are here from the beginning, na? Most of you are here from the beginning. Yes. Excellent here. Excellent, guys. Thanks for your support. Thanks for your love, guys. Okay. Now let's move to the earth pressure. I already told you that in soil, suppose this is ground level, and suppose here I want to find the vertical stress. That is done in the chapter vertical stress below soil. Here in this chapter we will be finding the horizontal stress. Why we are finding the horizontal stress here? Because when a retaining wall is made, let me show you the retaining wall. Suppose this retaining wall is made, this is retaining the soil. This is retaining the soil. So here what stress is acting? Vertical stress will make it fall, or the horizontal stress make it fall? Please let me know in the comment section. Here the vertical stress will make it fall, or the horizontal stress will make it fall? Here this horizontal stress will make the wall topple. This horizontal stress is more liable to make the wall topple. Okay, these are the weep holes. I told you, na? Sigma bar is sigma minus u. I told you in effective stress chapter. So these are the weep holes so that water can come out. These are the weep holes so water can come out. So u should not be more. Otherwise in rainy season u is more, sigma bar is less, and once the sigma bar is less, strength is less, so it will topple, a shear failure. So we don't want u should be more, so we are providing the weep hole. Okay. Now let us do, we will be finding now the horizontal stress. We will be now finding the horizontal stress. And should I increase the speed a bit? Guys? Can you please let me know? Please like this session if you have not liked till now. Like the session, guys, everyone. Okay, now little bit increase karte. Suppose I have a wall here. Okay, this is ground level and the wall is not moving anywhere. This is the case of rest. So here the vertical stress, what is the vertical stress? Gamma into h. What is the vertical stress? Vertical stress will be gamma into h. So what is the horizontal stress? So horizontal stress is K naught into sigma V. K naught here is nothing is mentioned, it will be 1 minus sine phi. And if it is given as elastic condition, it will be mu upon 1 minus mu. Okay, and if it is given as overly consolidated soil, then K naught will be the normal K naught, that is 1 minus sine phi, into the over consolidation ratio under root. So by default we have to use this. If it is given as OC soil and also given as overly consolidation ratio, we have to use this one. If it is given that the SOM conditions are there, elastic conditions are there, then we have to use this one. So if vertical stress is gamma h, horizontal stress is K naught into gamma h. This is the case of rest. Now these all values are written here. Okay, now active case. By default, if nothing is mentioned in the question, out of the rest case, out of the active case, out of the passive case, we have to assume the case to be active case. Okay, suppose this is the wall, this is the ground level. Active case means that wall is moving away from the soil, and of course by default, if nothing is there, it will be always moving away. This is not magnet, soil is not magnet here, soil is not magnet here, it will not be attracting it. By default it is moving away from the soil only. Okay, so this is delta H, this is H. So delta H by H for full movement of active earth pressure is 0.2% for loose sand, and delta H by H is 0.5% for dense sand. 0.2% for loose sand and 0.5% for loose. This much movement for full development of active earth pressure, and this is for dense. Okay, so here at point P, this is the vertical stress, this is the horizontal stress. So sigma H is active earth pressure Ka. Okay, here it is K naught, earth pressure coefficient at rest. Here it is the active earth pressure coefficient Ka. Okay, and Ka value is 1 minus sine phi upon 1 plus sine phi. That is also equal to 10 square 45 minus 5 by 2. That is also equal to cot square 45 plus 5 by 2. So you can see the numerator is less here. Sorry, numerator is less, denominator is bigger. Numerator less, denominator bigger. So Ka is less than 1. So when Ka is less than 1, that means that sigma H is less than sigma V. Ka is less than 1, sigma H is less than sigma V. So sigma H is minor principal stress, minor, and this is major. And if this is minor, that means this vertical plane is minor plane, because here the minor stress is acting, and this horizontal plane is major plane. Okay, now guys, after here, this is not the general formula, this is only valid when cohesion is equal to 0. The real formula which is applicable always is given as, we have seen these kind of formulas in shear strength chapter. In shear strength we have used this formula. So actually sigma 3 is minor. So the real formula is this. This is Ka, sigma 1 major stress sigma V. This is the actual formula. And once the C value is 0, then this formula will be there. Okay, now if I make the diagram of sigma and tau, this is major, this is minor, and this is more failure envelope, this is the failure plane. So this is the line going. So from sigma V it makes 90 plus phi angle, and from here it makes 90 minus phi. So from sigma V plane it makes 90 plus phi. Sigma V is which plane? Sigma V is from which plane? Horizontal. From horizontal plane 45 plus phi by 2. This is 90 plus phi na? So in real life it is 45 plus phi by 2 from the plane of sigma V, and sigma V is the horizontal plane. From horizontal is failure plane. is failure plane. Everybody on the comment box, give me yes or no. Have you understood? Have you understood? Have you understood? Please let me know. Guys, come on! Come on. Okay. Now passive case is, this is the wall, this is the ground level, here is the point P, in point P this is the vertical stress, this is the horizontal stress. Here passive case means wall moves towards the fill, wall moves towards the fill, and it is possible wall moves towards the fill. It is possible when some wind load is coming, earthquake load is coming. That is why by default it is active case. By default always the wall will be shifting here away from the fill. Some wind load is coming, that is why it is coming here. So delta H by H is 2% for dense sand here for full movement of pressure, and delta by H is 5% for loose sand. Okay, again here same thing, sigma H is Kp into sigma V. So Kp is 1 plus sin phi 1 minus sin phi. 1 plus sin phi 1 minus sin phi is also 10 square 45 plus 5 by 2 is also cot square 45 minus 5 by 2. So Kp value is greater than 1. That means sigma H is greater than sigma V. So this is major here and this is minor. But this formula is only valid for C is equal to 0. Because the real formula is sigma H is equal to Kp into sigma V plus 2C root Kp. This is the real formula. Sigma H is equal, this is sigma, this is same na, sigma 1 is equal to sigma 3, 1 plus sin phi 1 minus sin phi plus 2C this. This is the real formula. Okay. And if I make the graph, this is major, this is minor, and so from the plane, horizontal plane, this is the horizontal plane, plane of sigma V. From plane of sigma V it is 90 minus 5. So from horizontal plane is the plane of sigma V. Horizontal plane is the plane of sigma V. From sigma V it is making 90 minus 5. So failure plane will make 45 minus 5 by 2 angle. Okay. One more thing here. Ka and Kp are reciprocal. This is 1. And Kp difference from K naught is much larger than K naught difference from Ka. Give me yes or no. Give me yes or no. Okay. Thank you, Yuvraj. So guys, Yuvraj is here, one of my very favorite student from Jabalpur. Okay. I guess I taught him in 2018, 19, 17, something like this. Okay. Now, there are some cases now. Let us do one by one each cases. Okay. Like case 1. Case 1. Everyone, please see here now. All cases will be revised. All cases will be revised. Keep sharing, guys. Share the session. And are you coming tonight at 11:55 p.m. midnight? Are you coming tonight again at 11:55? Please let me know. Please let me know. Please let me know. Okay. Cohesionless on vertical wall. Suppose this is H. This is ground level. So horizontal stress will be like this, whether it is Ka or Kp. This is Ka gamma H. So what is the active force? Stress into area. Stress here is 0. Stress here is bottom at K gamma h by 2 into area. H into inside width as 1. So FA is Ka gamma h square by 2 or FP is equal to Kp gamma h square by 2. Okay. Now let's do the next case, submerged case. Now this is the wall. In this wall, this is the ground level, and here the water is also here. Water is also here. So here, see one thing, sigma h is K, whatever Ka, Kp or K naught, whatever Ka, Kp, K naught, whatever. It is K times of sigma V. So sigma h is equal to K. Sigma V can be written as sigma bar plus U, and it is K sigma bar plus U, because the water is applying same pressure all around. Water is applying same pressure all around. That is why I have written the U should not be multiplied by K. U should not be multiplied by K. It should be only 1, because water pressure in vertical also and horizontal is same, gamma WH. Now here this K into sigma bar, let it be Ka active phase, K gamma submerged H, and U is not multiplied by K, so it is gamma WH like this. So total horizontal stress will be looking something like this. Total horizontal stress will be something like this, Ka gamma submerged H plus gamma WH, like this. Now average will be 0 plus this by 2 into area. Have you got it? Have you got it? Please let me know. Please let me know. Okay, partially submerged, cohesionless. Let me do the difficult case with surcharge load. Okay, this is also easier. This is wall, this is ground level, and here is some surcharge also. Q kilonewton per meter square. Now here it will not start from 0. It will not start from 0. It will start from the low. Stress here is not 0. Stress here is not 0, it is Q. So this value is Ka into Q, and this value is Ka into Q plus gamma H. Now what is force? This plus this by 2 into area, H into 1. Okay, now this is the case. This is the ground level. This is the wall, this is the wall, this is the wall, and here there are two different soils. Here it is phi 1, here it is phi 2. Suppose phi 2 is greater than phi 1. What is Ka? Tan square 45 minus phi by 2. Ka is tan square 45 minus. So if phi is more, so Ka will be less, Ka2 will be less, Ka1 will be more. Okay, now here the stresses will be 2, then Ka2 is less, so it will be dropping like this, like this. Have you understood this? Let me make you understood. Leave horizontal stress, leave horizontal stress, leave horizontal. What is vertical stress here? 0. Suppose gamma 1, gamma. What is vertical stress just above is? Vertical stress here, gamma 1 into H1. And what is vertical stress here? Gamma 1 H1 plus gamma 2 H2. This is vertical stress here. This is very easy na? This is very easy na? This is very easy na. So horizontal will be multiplied by Ka. So here you are multiply with Ka, it will be 0. This is one soil, so multiply by Ka1. So Ka1 into gamma 1 into H1, just below this value. The vertical stress is gamma 1 H1, but it should be just below is soil 2. Soil 2 is Ka2. Ka2 is lesser. So this is Ka2 gamma 1 H1. And this value, this is reason 2, soil 2. Ka2 and vertical stress is gamma 1 H1 plus gamma 2 H2. Give me yes or no on the comment section. Give me yes or no on the comment section. Everyone, every commando. आई एम नॉट समझ केस में क्या किया मैंने, समझ केस में क्या कर दिया के ओ यस दिस शुड नॉट बी यस. थैंक यू गिरीश. बैकफिल विथ डिफरेंट सॉइल्स, ये तो कर लिया ना हमने. अच्छा नाउ इसमें एक और आगे cos बीटा भी लगता है. नाउ backfill is inclined. Now backfill is not horizontal like this. Backfill is inclined at beta angle. This is h height. Then same formula. Case 1 half Ka gamma h square. Same formula. But only difference will be this net force is acting at beta angle at h by 3 height. But Ka formula should be this one. Here one cos beta is also actually acting. Same formula is case 1. Case 1 is half Ka gamma h square na. Same formula. But it should be at beta inclination. And the formula for Ka will be different. Now inclined wall or horizontal backfill. See here when the wall is inclined, wall is inclined like this, okay, and backfill is horizontal. Whenever the wall is inclined, you have to make an imaginary wall like this. And once you make the imaginary wall like this, what is this becomes case 1? This becomes case 1. Fa is equal to half Ka gamma h square. This becomes case 1. Since the actual wall is not inclined, so you just have to add this much weight. This weight of soil, W. So resultant force is horizontal force Fa square plus W square, and resultant angle is F vertical upon Fa with respect to horizontal. Okay, any doubt please let me know. Now inclined wall, my god, inclined wall and inclined backfill is also inclined. Now in this case, whenever this case you have to make an imaginary wall, whenever such things are asked, you have to make an imaginary wall. Once you made the imaginary wall, what to do now? On this imaginary wall, due to this becomes now case 6. Here inclined backfill. So here this comes Fa like this at beta angle. So this component will be Fa cos beta, and this component will be Fa sin beta. And whenever there is an inclined wall, you have to make this weight also. Okay, so now the net resultant force in vertical direction is W plus Fa sin beta, and net horizontal force is Fa into cos beta. So what is the resultant force? F vertical square plus Fh square. And what is the resultant angle from horizontal? F vertical by F horizontal. Guys, everybody, please put a heart sign on the comment box if you understood this. Everybody, mandatory. Mandatory to each one of you, if you have understood. Otherwise, if you have not understood, I recommend you not to make a heart sign. If you have not understood, I recommend you not to make a heart sign. Everybody. Share the session, guys, so that more and more commanders can join in. Everyone. Now, this is very important case. In cohesive soil, what happens? In cohesive soil, what happens? Please see. Suppose that here the formula is sigma h, I just told you at the beginning, minus 2c root k for the active case. Active case is important, passive case it is a plus. It is like this. So at z is equal to 0, at z is equal to 0, see this sigma h is at z is equal to 0, vertical stress is 0. So vertical stress is 0. That means it is minus 2c root ka at z is equal to 0. Okay, and sigma h becomes 0 at z is equal to कितना होता है? Z is equal to 2c by gamma root k. If you put here 0 and sigma v is gamma z, z value you will be getting 2c by gamma root k. Therefore, the stress here at z is equal to 0, minus 2c by root k, and this becomes 0. This becomes 0 at z is equal to this much. This becomes 0. This value is 2c by gamma root k. So this might be something 2c by gamma root k. Now see the logic here. If tension cracks are developed, if tension cracks are developed, that means, what does that mean? The tension crack is developed. What does that mean? The tension cracks are developed. What does that signify? That signifies that here the contact is lost between soil and retaining wall. The contact is loose. If tension cracks are developed, contact is loose. So force is due to CFG region, that is half 0 plus whatever value here into area. Area will be only this much from here to here, because that contact is loose, and once the contact is loose, how it will be applying force? Yeah, once the contact is loosed, how it will be applying the force? Okay, now moving further, if tension crack not develops, contact is not there. If tension crack not develops, tension crack is not developed, tension crack is not developed, in that case all is acting. So either take all is acting, here it is to left hand side, here it is right hand side, minus means that hand side, here it is this hand side. So either you take all or just do Y's calculation. This minus and this plus will cancel out. This minus will be to here and this plus will be here, cancel out. So it is only due to DEFG. Only due to DEFG. So you have to check in the question that it is there or not. Now, give me yes or no. Guys, if we want to cut a bracing, guys, it is very difficult to cut a bracing. वो हटा दिया भाई, अब चेक तो कर लो मंडा साहब चेक कर लो, मंडा साहब थोड़े पीछे चल रहे हैं क्या? Okay, guys, it is very difficult to excavate because stresses at the bottom are more. Stresses at the bottom are more. So horizontal stress is more. Since the vertical stress is more, therefore horizontal stress will also be more. Since the vertical stress is more, so horizontal stress will also be more. And once the horizontal stress is more, so this may collapse like this. This may collapse like this. So we have to apply the bracings just like sleepers in rails to make the rails parallel. To make the rails parallel, this bracing is at 4C by gamma root Ka. No bracing is required because 2C by gamma root K and 2C by gamma root K net 4C. Up to 4C net force is 0. Up to 2C by gamma root K and 2C by gamma root K. So net is 4C by gamma root K. Up to 4C by gamma root Ka, net force is 0. Net force is 0. So no need to apply bracing. And guys, I have just told, make a daily dose video. Some mistakes. It is not always 2C by gamma root K. When there is no surcharge, then the formula is this. Otherwise, you have to derive the formula like this. I have driven. Okay. Now this will do at the night. This is not for the gate. Leave that. Okay. Now the force on the struts. There's sometimes these struts are leave. These this is so much big slide that it is hanging. Now guys, what are the forces on the struts? Like these struts. What are the forces on the struts? This. So in our case, they will be asking only for sand. Force will be stress into area, na? So actually this is a 3D figure. And suppose these are the orange struts. These orange struts are these. So we have to find out the area into stress. Stress is 0.65 Ka gamma H. Suppose we want to find force on this. So half of above, half of below. Half above it will be occupying, half below it will be resting, half of left, half of right. This. Suppose this area is A. So 0.65 Ka gamma H is the stress into area for sand. This is the force on the strut. This is how we design. Okay. Next chapter is our landslides. After this, foundation will start and then we'll end. Okay. Slope stability, chapter number 11. Guys, Monday evening, 9 PM survey marathon. Okay. So guys, you know that failure is always due to shear. So failure will be when strength is more and stress is less. Sorry, stress is more and strength is less. Shear stress is more and shear strength is less. Shear strength is less. This is failure. This is failure when shear stress is more and shear strength is less. Now those factors can be divided into two categories that are making failures. Now those are made into two categories. Those factors which are increasing the shear stress and those which are decreasing the shear strength. Oh no. Force which are increasing the shear stress. These are the factors: load, pressure, seepage, sloping, more slope. So guys, see, we know in school, this is theta, this is car, or W sin theta. If we increase the theta, then shear stress will be more. W sin theta will be bigger. 9 p.m. serving. Okay, and these are the factors which decrease the strength. Now there are two types of failure: two types of slope, infinite and finite. Infinite means when the length of the slope is quite large. When the length of the slope is quite large. Okay, like hills, like Himalayas, like mountains. So if the length is quite large, this slope angle is beta. This is infinite slope, like mountains, hills. So here the failure surface is parallel. Here the failure surface is parallel. It is assumed to be parallel to the ground slope. And here I say that factor of safety is resisting force upon sliding force. Resisting force upon sliding force. In finite slopes are like dams. Dam slope is of 100 meter, 50 meter, 70 meter. Okay. Here we assume to be rotational failure. Rotational failure can be this face failure, can be toe failure, can be base failure. Face failure, toe failure, base failure. Now out of these three, which failure will be there? That depends on where the soil is weak. If soil near the face is weak, face failure. If the soil near the toe is weak, toe failure. If the soil at the base is weak, it is the base failure. And here it is rotating. So here we say factor of safety not as resisting force upon sliding force. Here we say as overturning moment upon the resisting moment. And this slip surface can be spiral, can be circular. This slip surface can be spiral, can be circular. But for calculation we assume it to be circular. Okay. Now infinite slope, first case is that there is a dry soil, no cohesion. Dry soil, no cohesion. Here the factor of safety is no water, tan phi by tan beta. So for no failure, phi should be greater than beta. Phi should be greater than beta. Okay, leave. Now this from here might be question is asked. Here, this is a ground level. This is the water surface, and I want to check the failure surface here. I want to check, this is H and this is small h. Of course, this is gamma dry, this is gamma saturated. The slope angle is beta, so this water is also flowing with beta angle. Seepage case. So here the factor of safety is given as gamma T, or let it be gamma T. Gamma T for H minus H region plus gamma submerged for H into cos square beta tan phi plus C, cos square beta into tan phi plus C upon gamma T H minus H plus gamma sat H into sin beta cos beta. Of course, Of course, if this is a cohesionless soil, so numerator C will become 0. And if it phi is 0, that is clay, so this will be 0, numerator only C will be there. And if C and phi both are there, then both will be there. I am again repeating, this is a general formula. If it is a clay, so phi will be 0, numerator only C will be there. If it is a pure sand, so C will be 0, numerator only will be this. If it is both C soil, then both will be there. Okay. Okay. And sometimes the question is asked that, this I already told you, sometimes a question is asked that where the failure will occur. So answer will be you will be calculating this formula by factor of safety equal to 1. Yes, one more thing I want to tell you there. One more thing I want to tell you there, that if there is a complete submergence, if there is a complete submergence, that, yes, Swapnil, good. Complete submergence, note here, complete submergence, capital H is equal to small h. Capital H is equal to small h. That water goes up to here. So here, this will be 0. Okay, this will be 0, H minus H will be 0, this will be 0. So then this and C, complete submergence, and C is equal to 0. So this will be 0, this will be 0, gamma submerged upon gamma sat, and cos square beta sin beta will be cos square beta, and this cos beta will be cancelled, it will be tan phi by tan beta. Tan phi by tan beta. And this is approximately equal to half, because gamma submerged is approximately half of gamma sat. So it is half of tan phi by tan beta. What happened to my laptop? Guys, my voice is coming? Okay. Coming na? Okay. Now, here this I told you. Now Taylor's stability number is Sn. ये दोनों question, I will take this question in the midnight. Sn is equal to C. Sn is equal to C gamma factor of safety into H. This is a Taylor stability number. What gamma we have to use, this is written here. What is the use of Sn? There are some charts. From where if we find Sn, from those charts, if we find Sn, then the factor of safety can be determined from those charts. Okay, let me tell you something. Those charts are not in our exam. Suppose this 520, 530, 540. Okay, here it is FOS. Here, so Sn you find from this formula is 0.3 and your soil phi is 30. So like this we can find out the factor of safety. These questions will be taking, don't worry. This MSQs also I have made for you. Want to do, okay, करेंगे ना इसको workshop. Shall we start to the last chapter, foundation? Shall we move to the last chapter, foundation, if you allow me? If you allow me. Tell me, guys. Tell me, guys. Enjoying? Google Meet करें क्या क्लास के बाद? But only the students who are here. Google Meet करें क्या क्लास के बाद? मैं आपको एक लिंक दूंगा, अपनी जीमेल आईडी से आ जाना. ओके, देखते हैं चलो उस समय क्या होता है. ये चलो किसी और दिन टेलीग्राम पे दे दूंगा, ठीक है? ठीक है. कैसा रहा सॉइल? अब फाउंडेशन की बारी है, पर सॉइल कैसा रहा? सॉइल कैसा रहा? सही पढ़ाया मैं? सॉइल पढ़ाया? ज्यादा लंबा हो गया? ज्यादा डीप में तो नहीं चले गए? क्यों पूरा, ऑफ कोर्स पूरा तो नहीं पढ़ा सकते, पूरा डीप में तो नहीं चले गए? कितने घंटे हो गया क्लास? 5 आवर्स नहीं, 10 12 12 से क्यों गिन रहा हूँ मैं? 10 to 6, 8 आवर्स। रियल जूस कल मैं रात को ऑफिस से जब आया था, सो आई हैव टेकन ऑल द रियल जूसेस, रेड बुल्स, एवरीथिंग। खाना नहीं खाया है बस, सुबह से खा खा के भूख लगेगी भी नहीं, रात को भी नहीं, क्योंकि अब होटल का नहीं खा पाऊंगा इतना पढ़ाने के बाद। बनाना मेरे को आता नहीं। So yesterday I was thinking that if I'm able to take this much long class or not, but let me guys, believe me, I can still continue with marathon of surveying. If you want, I can still directly continue marathon of surveying here, marathon of surveying in this particular session only. True MN कहाँ गया with respect to MN? ये आज गजब लिखाया था आपने। अच्छा अच्छा, लकी वो see, Lucky is saying that something I write in Hindi in the notes when I was used to teach in offline. Lucky, from which center you are? गजब लिखाया था, गजब ही हूँ, जबलपुर से। ओके, इन 2018 कि रॉन्ग मैग्नेटिक, मैं ऐसा लिखाता था कि रॉन्ग मैग्नेटिक मेरिडियन होता है कि ट्रू नहीं, गलत हो गया लकी आपका। रॉन्ग डिक्लिनेशन होता है कि रॉन्ग मैग्नेटिक मेरिडियन कहाँ गया? ट्रू मैग्नेटिक मेरिडियन से, ना कि ट्रू कहाँ गया रॉन्ग से, ऐसे लिखाता था मैं। क्योंकि बच्चे अभी तो समझ जाते हैं कि भाई ये एक राइट मैग्नेटिक मेरिडियन है, वो होके यहाँ चला गया। अब भाई जो इसको रेफरेंस मानेगा वो बोलेगा 2 डिग्री ईस्ट लोकल अट्रैक्शन है, जो इसको रेफरेंस मानेगा वो बोलेगा 2 डिग्री वेस्ट लोकल अट्रैक्शन है। तो हमेशा राइट मैग्नेटिक मेरिडियन को रेफरेंस मानना है। ऐसे ही ये ट्रू नॉर्थ है, ये मैग्नेटिक नॉर्थ है। अब जो इसको रेफरेंस मानेगा वो कहेगा डेक्लिनेशन 2 डिग्री ईस्ट है, जो उसको मानेगा वो कहेगा 2 डिग्री वेस्ट है। तो हमेशा ट्रू वाले को रेफरेंस मानना है आपको। रॉन्ग कहाँ गया ट्रू से? देखो अभी भी याद है इसको। शेयर कर देना भाई लक साहब। चले चलो फाउंडेशन पे। भाई ये लकी बेइज्जती कर रहे हो मेरी। 100 रुपीज कहाँ देता था भाई? 500 रुपीज देता था सही क्वेश्चन होने पे। I guess I used to give 500 rupees when the question is correct. No? Okay. Chalo. So guys, shallow foundation means when the depth of foundation is not very big. And what is that not very big? So that not very big is not at all defined. As per Terzaghi, if df by b is less than 1, it is shallow foundation. But for any other thing, it can be different. But for any other thing, it can be different. What is the ultimate use of foundation? The ultimate use of foundation is that a P load is carried that has to be spread over an area, because when area is more, stress will be less. Yes, thank you, Lak. So this is the P load. Thank you, Lak. This is the P load, and we are making the area. How much area we have to increase? So such that we have to increase the area so that sigma comes lesser than the permissible value. And there is no definition of shallow foundation. For Terzaghi, df by b less than 1 is a shallow foundation. For Phlana, df by b less than 1.5 is a shallow foundation. For any other, df by b less than 2 is a shallow foundation. So that depends on case to case, that depends on person to person. Strip footing is when length is greater than 5 times of the width, like this. Strip footing. What is isolated footing? Isolated footing is one column, one footing. What is combined footing? There are 2 or more columns, one footing. Strap, I'll tell you later. Raft means when the whole area we have made one footing, पूरी concrete की चद्दर बिछा दी है, we have put a blanket of concrete once together for the whole plan, and then we are putting the columns. This raft foundation is used when either when there are so many individual footings, that it is occupying more than the 50% of the total area. If there are so much footings, that is making that it is occupying more than 50%. It is occupying more than 50% of the total area. If there are so much footings, if it is making more than 50% of the total area, then it's better that एक ही बार में पूरा concrete बिछा दो. Or when a particular location is weak, then also we use raft foundation, because here the load is distributed through the whole area, not the particular location. Okay. बहुत बढ़िया लल्लू. Good. Now, what is the gross pressure? Gross pressure representation is done by, let me check. Gross pressure is QG. Oh my god, let me make the charger now. Today all my accessories are all charger is over. Okay, Q gross is what is P by area B square plus gamma df. This is the net load acting here. Due to external load, P by B square, due to soil, gamma into df. Now, there is net pressure also. Net pressure is difference of now and before. That how much extra is coming. So earlier how much was there? Only gamma df. When we have not constructed the building, that how much stress was there? When we have not constructed the building, how much stress was there? Gamma df. Now this is coming, so what is extra? P by B square. When soil is placed back. When soil is not placed back, then in that case it is the difference na. So earlier it was gamma df and now it is only P by B square, because soil is not put, it is empty, like basement. So earlier it was gamma df, now it is only P by B square. So what is the difference? P by B square minus gamma df. So Q net is how much extra is coming. What is the difference? So if earlier it was gamma df and now it is this, so difference is this. If earlier was gamma df and now it is only P by B square. We have not placed the soil. So difference is P by B square minus gamma df. Everybody on the comment section give me yes or no. Only load. Very good Rahul. So load is उसके क्वेश्चंस के लैंग्वेज से पता चलता है आपको. ऐसा पूछा है कि हाउ मच लोड कैन बी अप्लाइड ऑन द फाउंडेशन. दैट मीन्स वो ऊपर का, ये पी वाला पूछ रहा है, ऊपर का लोड पूछ रहा है. Just guys, come on. Give me yes or no. Give me yes or no. Okay. So now, guys, gross pressure is how much total load is coming. Okay. Net pressure intensity is how much extra is coming. The difference of earlier and before. अब राहुल आपने क्वेश्चन बहुत अच्छा पूछा, समझे कि नहीं? अच्छा, बेस ऑफ फुटिंग पूछे तब गामा डीएफ बी, तब दोनों. मैं आपका क्वेश्चन बहुत अच्छा समझ चुका हूं, और जिस बच्चे का कॉन्सेप्ट बहुत अच्छे क्लियर है ना, वो यही क्वेश्चन पूछेगा, क्योंकि वहां पे देख के पता ही नहीं चलता. ओके. Ultimate bearing capacity is how much total load can act so that shear failure is not there. Net ultimate, this is QU. QU is if soil is loaded, then the maximum shear stress at which soil get failed is known as the ultimate bearing capacity. This net ultimate means the maximum net intensity of loading at which the base of foundation that the soil can support before failure. What is net safe bearing? QNS. Guys, have you seen this video? Here there is various confusion and I have made all the confusion clear here. Gross safe QS is QNU. Now guys, here is various problems here. Safe bearing pressure QPS. Okay, and this. Now listen to me. Now forever you will remember this. See, all the white ones are related to each other, and all the yellow ones are also related to each other. Listen. QG is how much total load is coming. मेरे दिल में बसी हारत हो तुम, मेरी आंखों को मिली शरारत हो तुम, मिलने की बगावत हो तुम. बहुत बढ़िया, ताली बजा दो सब उसके लिए. बहुत बढ़िया दारू, खूब. Now see, QG is total load acting on the soil. This is QG. QU is how much total load can come. And another white is, this is how much total load can come with factor of safety. All these are cousins from your father side. White. 1, 3 and 6. I'm again telling you. What is QG? How much total load is coming. QU is how much total load can come. 6 is how much total load can come with factor of safety. For safety, QG is the total load. Okay. So for this QS is less than QU. QS is less than QU. QS is less than QU, and our load coming should be also less than QS. Q, not some understanding, yaar. Leave all this. Leave. Guys, have you understood? This much is coming. How much total load? This much is how much can come. And this much is how much can come with factor of safety. No factor on safety on gamma DF because it can be accurately find out. Got it? How much total load is coming? How much total load can come? How much total load can come with factor of safety? So this QG should be least. How much total load can come should be less than the total load. How much total load coming should be less than the permissible value. Even it should be less than the permissible value for factor of safety. Again flickered. Okay. Now, friends, here net pressure intensity, how much extra load is coming, should be less than how much extra load can come with factor of safety. Q and U. Q and U. And even how much extra load is coming should be less than how much extra load can come with factor of safety. Give me yes or no. Yes, 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 Rahul. Yes, Rahul. Yes, Rahul. नहीं, बेस ऑफ फुटिंग पे आप दोनों से कर सकते हो. मैं पूछ रहा हूं कि टोटल लोड कोई पूछे कितना आ सकता है, आपसे कोई पूछे कि टोटल लोड कितना आ सकता है बेस ऑफ फुटिंग पे, तब आपको जो लोड का वैल्यू बताना है वो P प्लस सॉइल का वेट दोनों का बता के बताना है. लेट मी टेल यू यार. See, इधर see Rahul and Girish and everyone, they're asking a very, very deep doubt, and that doubt is also with me. That doubt is also with me. That should we when while designing, should I design from this, that QG total load and QG brother is QS, should I design from here or should I design from here? QN should be less than QNS. So QG is P by B square plus gamma DF should be less than QS. QNU by factor of safety plus gamma DF. And if I check from QN, extra load. So extra load was P by B square minus gamma DF should be less than QNS. And QNS is QNU by factor of safety. Oh, so extra is if the soil is placed back. This is this. So both will give the same answer, na? This is based on total, Girish. Rahul and Girish, is it clear now? This analysis of design is based on total load. Rahul and Swapnil, Rahul and Girish, this analysis Q gross, this is total and this is Q safe. And this is on the basis of extra load, net. So both gives the same result. Rahul, have you got it? Have you got it? Girish? Girish, have you got it? Okay. Now Lalu is not asking this. Lalu has a different question. देखकर खुशी उसको सारे गम चुरा लो. वाह लालू, बहुत बढ़िया, मजा आ गया यार. Okay. Now Rahul is having different questions. Suppose load is asked that how much is the permissible load. Then that load we should be answering on P, this load, P or the total load. So of course there in history there are some questions that are very confusing, ambiguity. So always they have given marks to all in such question. Otherwise from the language you have to check. Okay. Otherwise from the language we have to check. Guys, please like the session and share so that everybody can join, everyone. Okay, now all these things, these are cousins from father side. This yellow is the cousins from mother side. These are the cousins from father side, and these yellows are the cousin from the mother side. Now all these are on the basis of shear failure. How much load can be applied on the basis of shear failure? But actually shear and settlement both should not be there. So QPS is on the basis of only settlement. QPS is all these are on the basis of shear. QPS is on the basis of settlement, and actually it should be the minimum of how much load we should be applying. It will be the minimum of QNS and QPS. Okay, got it? Got it? These all on the basis of how much load is applied, how much extra load is applied on the basis of shear failure. This is on the basis of settlement, and this is on the basis of minimum of both. Got it? Got it? Now there are three types of failure. There are three types of failure: general, local, and punching shear failure. General, local, and punching shear failure. What are these? What are these? General shear failure is when this is our footing, and the load is coming and it propagates up to here. It propagates up to here. In ground, heaving is also there, soil also comes there, and the crack propagates up to there, and even the soil is also, foundation is also tilted. Okay, it occurs generally when relative density is greater than 70% and phi value is greater than 36 degree. And since it is failing, so we find a curve like this. Settlement and load, we got a curve like this. Okay, we got a curve like this. This is the load at which it is failing. Now local shear failure is phi is less than 29 or 28 degree. There is not much tilting, much heaving. Okay, and if this is the footing, so the crack is not coming till the top. Okay. Now punching shear failure. Punching shear failure is that column punches down. So a large relative settlement. Okay. So general shear failure is like this. Since in general shear failure there is a failure, tilting. So whenever there is a brittle failure, relative density is more than 70%. Relative density is more than 70%. So whenever there is a brittle failure, there will always a sharp change in slope. This is general shear failure. Local shear failure, there is not brittle failure, and whenever there is not brittle failure, it will be like this. And punching shear failure has a maximum settlement. Have you got this? Everyone? Okay, now Terzaghi has given the formula of how much total load can be applied. How much? Guys, just remember this formula. It will be used. This is DF. This is B. and here this is B. This is suppose zone A. This is suppose zone B. Okay. So Terzaghi has assumed the failure to be. Terzaghi has assumed the failure to be. Terzaghi has assumed the failure to be general shear failure. And it has given the formula that ultimate bearing capacity is CNC plus Q and Q plus half B gamma and gamma. Now if you understood these three terms, it is very fine. Everything is fine then. Now QU is CNC plus Q and Q plus half B gamma and gamma. First of all, what is the first term? CNC. First of all, what is NC, NQ and gamma? What is NC, NQ and gamma? NC, NQ and gamma are function of phi. And if you want to be very precise, of zone B. If there are different phi's here, zone A and zone B, then it is a function of phi of zone B. It is a function of phi of zone B. Okay. Now, C represents cohesion. Of course, if more is the cohesion, more is the ultimate bearing. Ultimate bearing capacity, how much total load? How much total load it can bear? Okay, that is QU. How much total load it can bear? CNC plus Q and Q plus half B and gamma. So C represents the cohesion below the base of footing. Of course, if C is more load it can bear. So C is the factor for Q. Obviously, if C is more load it can take. Now Q is actually the stress here, gamma dF. Both from here to here and here to here we assume to be gamma dF. From here to here we assume that to be gamma dF. So gamma, yes, is gamma dF is more, it will be holding the footing, not allowing it to tilt. It will be holding the footing, not allowing it to tilt. Okay, so that is my friends Q. Okay, holding the footing. Okay, half B gamma n gamma. Half and n gamma is a constant. B gamma is the further stress below this, at B depth below. So if the gamma is different, so here in this Q is gamma dF. Which gamma we have to use? Gamma A. Because Q is the surcharge on the footing and this soil is applying the surcharge. And here gamma of zone B, because B gamma is the stress here. More is the stress here, it is not allowing the crack to propagate. More is the stress here, it is not allowing the crack to propagate. Okay. So now if I want to find out the Q and U, so Q and U is QU minus gamma dF. Net ultimate is, in which we don't take this gamma dF. Gamma dF we don't take Net ultimate is how much extra. We don't take gamma dF. So gamma dF is represented by Q. Gamma dF is represented by Q. Gamma dF is represented by Q. This is Q and U. Q and U is QU minus Q. So from here if I subtract Q, so Q and U is C and C plus Q and Q minus 1 plus half B gamma and gamma. But as per the assumption of Terzaghi, it is for strip footing, okay, and it is for general shear failure. Okay, this formula is for strip footing and it is for general shear failure. Okay, now here let me tell you that if it is clay, for clay phi is equal to 0. If NC, NQ and gamma are function of phi, if NC, NQ and gamma are function of phi, then for phi is equal to 0 also there will be some value, na? For phi is equal to 0 also there will be some value, na? So, for phi is equal to 0, NC is 5.7, NQ is 1 and gamma is 0. Putting it here, Q and U, 5.7 C, that's it. 1 minus 1, NQ is 1, na? 1 minus 1 is 0 and gamma is 0. So this is for clay. And for clay if you want QU, so QU is QNU plus gamma DF, na? It is QNU plus gamma DF. Okay? 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 Okay, and this formula is for general shear failure. If it is local shear failure, then in local shear failure, Q and U, instead of C we will be using 2 by 3. Instead of C we will be using 2 by 3. And instead of NQ, we will be using NQ dash half B gamma. Instead of N gamma, we will be using N gamma dash. So if it is local shear failure, we will be using, instead of C, we will be using 2 by 3C. Instead of C, we will be using 2 by 3C. And instead of NC, NQ and gamma, we will be using NC dash, NQ dash and gamma dash. Now what is NC dash, NQ dash and gamma dash? If it is local shear failure, what we will be doing? We will be using tan phi m is equal to 2 by 3 tan phi. From here find phi m. And from phi m, NC dash, NQ dash and gamma dash are function of phi m. Okay. So again I am repeating, don't worry. If it is local shear failure, then instead of C we should be using 2 by 3C, one change. And instead of NC, NQ and gamma, we will be using NC dash, NQ dash and gamma dash. And NC, NQ dash and gamma dash are function of phi m, and phi m will be calculating from here. Everybody on the comment box give me yes or no. On the comment box give me yes or no. On the comment section give me yes or no. Okay, that formulas are for that formulas are for strip footing. If there is some different shape, then slight modification factors has to be applied. Then shear phi less than 28 or 29. Certain modification factors are applied, because other formulas, previous formulas are for strip footing. For square it is 1.3 CNC. 1.3 CNC and it is 0.8. In no factor is multiplied in the second term. Now here in circular it is 1.3 and it's 0.3 B gamma, 0.6 into this. B is diameter in that case. And for rectangular it is 1 plus 0.3 B by L and 1 minus 0.2 B by L, like this. Okay. Now what if there is water table? I'm not doing all just one thing I'm doing. Suppose just one case I am doing, all other case will be same. Ground level, this is suppose DF, this is suppose B, and suppose water table is here at X distance. So what is Q and U? C and C plus Q and Q minus 1 plus half B gamma and gamma. Okay. Now see, just who has studied from me now, he does not have to require all these formulas. He does not have to require all these formulas. So it is C and C. Q is the load here now. Q is the load here. So it is gamma T into X plus gamma submerged into dF minus X. Understood? Gamma T into X bulk and gamma submerged into dF minus X. This is small q plus half below water is all submerged. Gamma submerged into N gamma. This is how we can write any case. This is how we can write any case. Got it? Got it, friends? Everybody give me yes or no, yaar. Come on, show some energy, yaar. Show some energy, yaar. Skempton has this simple formula. Q and U is equal to C and C. Simple. Q and U is equal to C and C. And C is a function of shape and dF by B. And C is a function of shape and dF by B. Simple formula. Simple formula for Skempton. Okay, this is for Mayer-Hoff. This is for IS code formula. Okay. Now, Peck equation has given a different formula for finding out the Q allowable net. That is minimum on the basis of permissible settlement, minimum on the basis of permissible settlement, and the shear. These values are all written here. On account of eccentricity, how to do? On account of eccentricity, how to do? इसका भी एक मैं रात को क्वेश्चन लेने का ट्राई करूंगा. I will try to take this question. Account of eccentricity is if this is the center of mass of a footing and load is acting here. Load is acting here. Okay. Suppose load is acting here. In such case, movements will also come. Okay. In such case, movement will also come. In such case, movement will also come. And this movement will making it bending stress extra will be generated. Bending stress extra will be generated. Extra bending stress will be generated. So due to this, we don't want to take the effect of extra bending stress. So we do opposite. Either you take more loads because your bending stress will be there will be direct stress, there will be bending stress. Either take more load or do the reverse process. Take load as normal load, no bending stress, but take area less. So we'll be taking area less that. Now we'll be reducing our such that now the reduced area, this load is center of mass of the reduced area, either on both axes or single axis. This area is such that it is now the particular load is center of mass. So we will be taking less area now. So we are not taking any different like earlier we will be doing. We will not be taking effect of bending stress like earlier we will be doing, but we are taking this. So this is not required. Guys, we are doing some SPD test. A 65 kg rammer is fall from 75 centimeter to a borehole. Okay, from 65 kg it is on a borehole, and find 65 kg from a height of 75 centimeter. From a height of 75 centimeter is put here. First 150 mm, how many blows are required are not counted. First 150 mm, how many blows are required are not counted. Then next 300 mm are counted and that reading is taken as N0. The reading is taken as N0. Now for N0, first we apply the overburden correction. Overburden correction is N1 is equal to N0 350 upon sigma bar effective stress at the depth of test into 70. Sigma bar should not be greater than 280. If it is more than 280, no need to apply overburden correction. So from field, first 150 values are not counted. Next 300 values are counted. We get N0. From N0, we find N1 by applying the overburden correction. Then after N1, we find the final value. After N1, we find the N value, final value. And this value is 15. This dielectric correction due to presence of fines, half N1 minus 15. And it is applied when the value is greater than 15. So first we got the N0 value. First 150 mm are not counted, next 300 mm are counted. Then after the N0 value, we do the overburden correction, find N1 value, and this is the dielectric instruction. Here we find the final value. Now this is the case, okay, everybody understood this. But what is the use? What is the use of finding the N2 value? There is some Tanks formula, no need to learn. No need to learn. In that Tanks formula, this N value is taken. That is the use only. But we don't have to do this. We just restricted ourselves to finding the N value. We are not using the Tanks formula. Okay? Got it? Now there are plate load test. There we go to the depth of excavation of footing. We excavate it. BP is the width of plate. We excavate 5 times of width of foundation, 5 times of width of plate. Then we apply the load on the plate, and by applying the load on the plate we find its settlement and at which it fails, at the load at which fails. Now settlement of plate we have found out now. So settlement of footing we have found it from this expression. BF is the width of foundation, with BP is the width of plate. BF is the width of foundation, BP is the width of plate. SF is the settlement of foundation, SP is the settlement of plate. Okay, settlement of plate is found from the dial gauge. Here SP is found out from the dial gauge. Okay, this is for sand. For clay, SF by SP is equal to BF by BP for clay. Okay, so main aim is found out the SF. Main aim is to find the SF. Now for QF, UF, ultimate capacity of foundation. Ultimate capacity of foundation upon ultimate capacity of plate is 1 for clay. For clay it is 1. Ultimate capacity of plate will be found from dial gauge. And QUF by QUP is BF by BP for granular soil. Okay. Okay, first 150 mm are not counted, so answer is 18. 18. Deep foundation in soil exploration, the last topic. My God. My God. Ready for the last? Ready, guys? Swapnil is from the morning. Anbu is also from the morning. Okay, yaar. रेडी? करें? लाइक शेयर सब्सक्राइब कर लेना भाई. ओके. लास्ट चैप्टर. एनर्जी सही थी. अरे ये क्या हुआ? कैसे करते हैं इसे फुल? भाई पहले से सेव करने दो यार. So we are on the 486th slide. Very less to come. Every slide, how much time it will be taking? So in 4 out of 486, only count for 400. Might be there are some different slides of schedule and all. 400 slides. काम. अरे यार काम हो गया क्या? लैपटॉप का हो गया क्या काम? What happened यार? सेव हुआ कि नहीं हुआ भाई? आठ 6. भाई कैसे सेव करेंगे यार? कैसे सेव करेंगे? कोई आइडिया है आप लोगों को? कैसे सेव करेंगे? सॉइल मैराथन पीपीटी. ये सेव ही तो दिख रहा है. सेव है क्या? ये वाला सेव नहीं है. 4:10 के बाद सेव नहीं हुआ. कोई बात नहीं है, उससे देख लेना. 2 चैप्टर शायद सेव नहीं हुए ना. ये सेव है, ये सेव है, ये सेव है. अर्थ प्रेशर नीचे सेव हुआ और शैलो फाउंडेशन. कोई दिक्कत तो नहीं भाई? अर्थ प्रेशर सेव नहीं हुआ. हो जाएगा क्या अभी भी? अब वो आ ही नहीं रहा. चलो देख लेंगे, छोड़ो. चलो स्टार्ट कर रहा हूं. सब्सक्राइब द चैनल गाइस. चलो देखो, जब भी हमारे पास शैलो डेप्थ पर, जब भी हमारे पास शैलो डेप्थ पर, जब भी हमारे पास शैलो डेप्थ पर जो सॉइल रहेगी वो बहुत स्ट्रांग नहीं है, वो बहुत स्लरी है, वहाँ पे फेल होने के चांसेस हैं, उसकी बियरिंग कैपेसिटी अच्छी नहीं है, तो हमारे पास 2 ऑप्शन रह जाते हैं. या तो मैं इतना ज़्यादा अमीर हूँ कि इतना बड़ा फाउंडेशन बना दूँ, अगर जगह परमिट करती है, ऐसा नहीं कि दूसरे की बाउंड्री में पहुँच जाएंगे, कि मेरा जो एरिया मैं इतना ज़्यादा बढ़ा दूँ कि स्ट्रेस कम हो जाए. ऑलरेडी वो सॉइल ख़राब थी, उसकी स्ट्रेस लेने की क्षमता ज़्यादा नहीं थी, लेकिन मैंने इतना एरिया बढ़ा दिया कि मेरा स्ट्रेस ही बहुत कम आ जाए, तो मैं अनइकोनॉमिकल डिज़ाइन कर लूँ. या दूसरा है, फिर मैं अपने स्ट्रेस को वहाँ लोड ही ना करूँ, मैं नीचे कहीं तक जाऊँ और यहाँ पे लोड अपना डिस्ट्रीब्यूट करूँ, अपना लोड ट्रांसफ़र करूँ. तो ऐसे पाइल फाउंडेशन है, ठीक है. ऐसे पाइल्स रहते हैं आपके पास, ऐसा ठीक है, ऐसे ये पाइल्स हैं, जनरली स्क्वायर में यूज करते हैं, 1 2 3 4 इधर, 1 2 3 4 इधर, ठीक है। अब जो पाइल, अगर मैं सिंगल पाइल की बात करूं ना, तो जो क्यू यू टोटल लोड लगा सकते हैं, जब मैं किसी पाइल पे लोड लगा रहा होऊंगा, व्हेन आई एम अप्लाइंग अ लोड ऑन द पाइल, इट इज एक्टेड बाय, and from how much time I'm not speaking English? From how much time I'm not speaking English? Last chapter I taught in English or not? Last chapter I taught English or not? Okay, so the load, whatever the load I am applying here, QU, it is acted by QP and from side friction. If I am applying a load here on this pile, so it is QP, and from side it is QF. So QU is QP plus QF. And if I want to do factor of safety also, so Q allowable is equal to QU by factor of safety. Okay, Q allowable is QU by factor of safety. Okay, so factor of safety if not mentioned, it is taken as 2.5. Now there are various piles: concrete, steel, timber, H section. Now QU ultimate capacity is friction and point. If QF is very big, it is called as friction pile. If point bearing capacity is very big, it is called point bearing pile. And might be both QF and QP are of similar. It may be possible that QF and QP, it may be possible that both QF and QP are almost same. QF and QP are almost same. Then it is neither friction pile nor point bearing pile. Now, if in single pile capacity, let me tell, just wait. Guys, if single pile capacity is QU, then 3 piles together is not 3 QU. Might be they are very near to each other, pressure bulbs are intersecting. So if one pile capacity is QU, then 3 pile capacity may be less than 3 QU if pressure bulbs are intersecting. If pressure bulb is not intersecting, so one pile capacity is QU, then 3 pile capacity is 3 QU. Then 3 pile capacity is 3 QU. Okay, no, wait. Okay, so first of all I am considering only single pile. For sand, what is QP? For sand, the value of QP is, for sand the value of QP is Q into NQ plus half B gamma N gamma. It is point and so this is stress into area base, stress into area base. Okay, stress into area base is force. If N gamma is not given, take it as 0. Q is effective stress at base, but effective stress variation is only taken up to 15D in loose sand. Effective stress variation is only taken 15D in loose sand and 20D in dense sand. Means the variation of effective stress is varying like this is only up to 15D. After that you have to make it constant. For dense sand it is up to 20D. After that you have to make it constant. Suppose diameter is 0.3 meter and it is dense sand. So up to 6 meter only you will be varying. After that you will be taking constant. And if pile length is less than 6 meter, then of course the constant region will not be coming. Okay. So this is due to arcing effect, because we are taking less value. Anyhow the value will be more we are taking less value so we are taking less value here Q. So less is, this is QP is helping us, so helping hand we are taking less. That means we are safe due to arcing effect. And for clay, from base QP, it is C and C. NC is not given, we'll take 9 into area base. Okay. Now, if I talk about friction, here it is alpha C into AS, area surface, because friction is acting on the surface. So stress into area. And sand, for sand, what is QF? It is K, average stress on the pile, tan delta, this is stress into A surface. Okay. So K's and delta value all are this. K delta value is this. This is the value for K. Okay. Now, can you do this? Okay. Circular pile, QF is some stress, like for clay it is alpha C, like for sand it is K sigma tan delta into A surface. A surface is, what is the surface? Friction is acting on the surface na, pi d into L. So it is proportional to LD. It is proportional to LD. Guys, please like and share the session so that everybody can join in. Okay. Now piles are actually, these are formulas for single pile. These are formulas for single pile. Actually pile is used in groups. Actually the pile is used in groups. So suppose first of all, the group, what is the group efficiency? Group efficiency is the capacity in groups upon number of piles into single capacity. Suppose in groups there are 16 piles. There are 16 piles. Okay. Suppose in group there are 16 piles. So one pile capacity is 100. One pile capacity is 100. So efficiency is and one pile efficiency is 100 and 16 piles efficiency is 800. So it is 800 upon 1600 into 100. That is 50%. That is 50%. This is the formula, engineering news formula for finding the Q allowable. Okay. This is another formula. Negative skin friction is suppose sometimes what happens that soil is coming below with more speed than pile. Okay. Suppose friction is opposite to the relative motion. See, friction is opposite to the relative motion. Friction is opposite to the relative motion. If motion of pile is this and motion of soil is this, so soil is thinking that pile is going backward, so relative motion is forward. Okay, I hope you are getting. Guys, friction is opposite to the relative motion, and relative motion of pile with respect to soil is backward. Relative motion of pile with respect to soil is backward. So friction is opposite, forward, or you can say as a drag force. So that is a negative friction. Here actually friction should be helping us. Friction is helping us, but here in negative it is in the direction of load. दुश्मन के direction में है. Okay. Now this is group settlement. Group settlement, S of group upon S of individual has this value. Of course empirical, I can't derive this. So other questions or depth of exploration, nothing to do here. In soil exploration, this only area ratio has to be done. So these questions of pile foundation also will be taking in the night. Okay. So these are the two sessions that I'll be taking in coming 2-3 days. Okay, now Sunday will be FM marathon. Then on Monday there will be 100 expected question. Then on Monday in the midnight complete survey marathon. And tonight, are you coming, guys? This is the complete schedule. Tomorrow will be fluid mechanics, and today night will be geotech questions. You can join me in my Telegram group, Civil by Abhinav sir. Let me share you my Telegram where I'll be showing just in 10 minutes. In 10 minutes, let me compile this, then I'll be sharing. This is my Telegram link. Are you coming in the night for the practice? There we'll be taking the other questions of pile. There we will be taking other coefficients of pile, like that little pile capacity will be taking. Okay, there will be taking. Need not to worry. Okay, guys, please like this session and share this right now. Like this session and share this right now. Thank you, guys. I hope you enjoyed this video. I hope you enjoyed this video. Two chapters are not saved, earth pressure and one more. Others are saved. Okay. Thank you, guys. My all best wishes with you. BYJU'S exam prep team is with you before the exam and even after the exam also. Okay, so thank you, guys. Thank you all. Thank you, guys. My blessings with you. Lots of love, lots of love. Thanks for your support. Thanks for your love. I don't want any food to be energized. Your all love is my biggest motivation. Okay. Thank you all. Take care. See you in the session, this session. Okay. Thank you, guys. Good night. Take care. Good night. 11:55 we are meeting again. Thank you.